So, 7 days, whatever. Today I'm gonna be, I'll have Siri read off the ECMA JavaScript standard, and then, today I'm gonna be like, fighting the compiler, the Visual Studio compiler, because, it crashed yesterday, and it, screwed up my files. I didn't notice till later, and I got all confused, and then at the end of the stream, whatever, a folder is like locked because Visual Studio, the compiler, it like locked up a folder. So I'm gonna turn on the computer today. I'm gonna see if it's still stuck. I have a feeling it's stuck because I've dealt with this before. This compiler is absolute trash. So I have to Google how to fix this again because I don't remember what to do with whatever's happening. I don't know. And then I'm gonna get back to working on a JavaScript engine, the fastest JavaScript engine implementation. That, I don't know, it's not really okay, whatever. So I'm gonna get Siri reading this I guess you could call it a standard. It's not the standard, like, it literally says in it that leaks are acceptable for JavaScript implementation, like memory leaks and stuff. There's a whole bunch of weird things that, well, I don't think should be considered standard or whatever. Because like memory leaks, bugs, that all drops down to the end user, just like Microsoft Visual Studio. I don't know, pull up the compiler on the internet. I'm gonna try to fix this today because I can't make progress until the compiler works and stuff. So I'm gonna turn on this other computer. I'm gonna go on Google. I gotta fix whatever the compiler screwed up. Okay, so like in this JavaScript standard, whatever, I'm gonna do Command F whatever on Mac to find the word leak. I'm typing on the wrong keyboard. And inside of the standard, it says this.
However, any value associated to a well-known symbol in a live weak map is unlikely to be collected and could leak memory resources and implementations.
So inside of the standard, there's circular references in memory. There's like JavaScript is a high level programming language, which means it's for elites, you know. Not really for elites. It's developed by the elites, you know, elitists, like the people that are on a high programming horse and they're like, oh, it's so perfect. I don't know, whatever. We don't need C language. We program in Python and stuff. We're so smart. Okay, so I'll just have it like read off again.
However, any value associated to a well-known symbol in a live weak map is unlikely to be collected and could leak memory resources in implementations. Unlikely to be collected and could leak memory resources in implementations. Collected and could leak memory resources. Could leak memory resources. Leak memory resources.
So what I'm getting at here is that it's acceptable. I'm sure there's a lot of other things in this documentation that I'll come across, but this is like glaringly obvious that I don't know how this is standard. This is ridiculous. They do have like down here they have like a solution, I guess. In this documentation, whatever they say,
Weak map and weak set are intended to provide mechanisms for dynamically associating state with an object or symbol in a manner that does not leak memory resources if, in the absence of the weak map or weak set instance, the object or symbol otherwise became inaccessible and subject to resource reclamation by the implementation's garbage collection mechanisms.
I'll just have read the rest of it, whatever.
This characteristic can be achieved by using an inverted per-object symbol mapping of weak map or weak set instances to keys. Alternatively, each weak map or weak set instance may internally store its key and value data, but this approach requires coordination between the weak map or weak set implementation and the garbage collector. The following references describe mechanism that may be useful to implementations of weak map and weak set.
So there's an issue with this documentation and this whole thing with circular references in memory that can't really be solved. So their resolution to this is to provide two solutions, possible solutions, but they don't state which one to use and which one's better. They just say some of the implementations are going to
leak memory resources
because they're designed by people who don't know what they're doing, and anyone that's reading this documentation or whatever that knows what they're doing realizes that it's broke. They can't cook, and the solution that they provide are these two documents here, whatever. And they basically say in here, whatever, that these could be solutions, but they don't say like they are solutions. They're just really like vague and stuff. I don't know. So this documentation is garbage, but I don't know. The whole standard thing, like leaking memory resources.
leak memory resources.
I don't find that acceptable at all, because then it comes down to the person using the product to have to deal with it. So like Microsoft Visual Studio, that program leaks a ton of resources and it breaks files and it doesn't work. And that's what I'm dealing with today So this mindset in programming, where it's acceptable to
Leak memory resources.
that's not. It just pisses me off because I'm gonna waste however much time today trying to fix this compiler. I'll pull it up, whatever. Because it broke my build, and now I have to like figure out what the fuck it did and undo it. Because I can't build code until I fix whatever the compiler did, because the folder's like stuck because the compiler fucked it up. Okay, so Microsoft Visual Studio, MSVC. I don't know, I think that's like the older term for it. This thing is a piece of garbage. It's designed by Microsoft. Why it's called Microsoft Visual Studio. And it compiles C++. C++ is also garbage. And C++ has a lot of the errors, and it has a lot of this, whatever.
Leak memory resources.
Because lots of I don't know, whatever. I have Siri read about MSVC, whatever, but it says that development features. The main development feature of Visual Studio is bugs. That's like the main feature. Like, you turn it on, you get it running, you start working, and then you get a bug, and then you have to Google what's happening with my project, why is it not building, and then you get another bug, and then something else happens, and then something else happens, and then the folder's unopenable. That is the main feature of Visual Studio is bugs and not working.
V8 inline cache. Google search. V8 JavaScript Engine. MSVC stands for Microsoft Visual C++. It's a C++ compiler developed by Microsoft, and it's a crucial part of the Visual Studio development environment. MSVC is the primary compiler used for building Windows applications, including desktop apps.
But you can't build applications when the program to build the application, the compiler, it doesn't fucking work. Okay, anyways.
Applications, Universal Windows Platform, UWP, apps, and more. It's known for its support of C++.
It supports a turd. C++ is shit.
Standards and features.
Microsoft Visual Studio is known for being shit.
Features, as well as its
The main feature is bugs and wasting time.
integration with the Visual Studio.
I'm tired of integrating with this fucking software. It's shit.
Studio Aid, which includes debugging
The IDE does fucking nothing.
tools and other
They need to debug their own fucking program.
development features.
Okay, I'm gonna stop getting angry and try to like fix whatever's happening with this compiler. At least they have a pretty website, you know. Go to visualstudio.com. Oh, it's beautiful. Look how pretty this website is. It's just so pretty. Look at that. It's so beautiful. I really wish they would spend the time that they like spend on this wonderful website on the compiler itself. And I really wish Visual Studio would that they deal with this issue of it's not clicking. I really wish Visual Studio would.
Not leak memory resources. Not leak memory resources. Not leak memory resources. Not leak memory resources.
But that would be too much to ask for, asking the compiler to,
Not leak memory resources.
or even screw up the file system itself. So now I'm gonna have to go through and figure out whatever the fuck the compiler did to this folder, because I can't copy it, I can't change a file path name, I can't run the compiler, I can't do anything because the folder is stuck, or it was stuck. This is a new day, so let's see what features I'm gonna have to deal with today with Visual Studio. I'm gonna start by trying to open the project stuff. So duplicate display. So, oh my god, shit. It's like glitching. I don't know what's going on with the video. It might just do that the whole time, I guess. I don't care at this point. First I gotta figure out why it's not whatever it did with the folder. So I'm gonna go to wherever my project is, and then I'm gonna pretend it's a normal day. I'm gonna make a backup. So I'm gonna click here, control, I'm gonna copy, I'm gonna go over to this drive, I'm gonna make a new backup file, I'm gonna call it 0023 today. This is like a random whatever. So I'm gonna open this folder, I'm gonna paste. Okay, so actually I'm gonna drag and drop. So I'm gonna go over here. It's a brand new day. I restarted the computer. It's been off for however long. I haven't been on the computer. So it's like a new day. A clean boot of Windows. Yesterday the compiler crashed and it screwed up some stuff. So let's say I want to make a backup. Okay, so it's a new day. I'm gonna make a backup. I'm gonna get to programming. So I copy the directories, or I'm gonna highlight whatever. I'm gonna drag and drop. Drag, drop. It's gonna copy now, okay? So I'm making a backup, just a normal day. It's just a normal day of programming. Making a backup. Oh my god, it's working. You know what? Never mind. It is a normal day. Everything's actually working. That's great. That's just fucking great. I'm actually kind of happy it's working, because I don't have to waste time Googling stuff and trying to figure out whatever it did, because it is actually working now, I think. Okay, so now I should be able to delete these two folders. And then I can pull up the right backup that I was trying to do yesterday that it wouldn't let me do. I'm actually in a good mood now. I was expecting to deal with a whole bunch of issues. Aside from the screen tearing, I don't know what's going on. Something else is wrong with the computer though, so that's great. Okay, I think everything's actually working, so I'm going to open up everything and try to get to programming. I don't know what's going on with the screen tearing. I'm just gonna leave it for now, I guess. I was really expecting to like spend 10-20 minutes googling why the folder's stuck, but I don't have to do that now, so I don't know what to do. I guess I'll just get to going then. Okay, so yesterday there was one if that to change to elif, so I made a backup before all that happened, however. So I copied that backup and I pasted it, and now it's actually running. I think the folder's not stuck now. I'm gonna try to run the compiler and see if it builds, and then I think I gotta restart the computer because the screen keeps glitching. I could restart the computer 1,000 times, and I have a feeling that something will always be wrong. So whatever, I don't know. So I'm gonna open the compiler, try to build it. I need some caffeine and water. I made a backup of the file, whatever, so I don't have to change it again. Now I get to click build. I'm going to clean the solution first, even though it doesn't even work half the time. And I'm going to rebuild. And I hope I don't get any features like bugs and stuff, because I really don't have the patience for that today. I'm really hoping this will just work and it's going to build and this program's going to work. This is going to take 2 minutes to build because this compiler is very slow. It is very slow. This compiler is working, doing its thing, it's compiling code. And it's using 33%. Something is running on this computer because it's never at 33%. It should be like 10, 18%. I need to restart maybe. And it's done. It only took 2 minutes to compile. I need to fix the clock on this computer. It's like, I don't know, it's not even in sync at all. So today might actually be a good day where I can make some actual progress. I'm really hoping. Oh, now the CPU is at like normal usage. So I don't know, whatever was going on in the background is done, I guess. Maybe Windows finally finished starting up. So I'm gonna click run. And I'm gonna run it. I gotta open Sublime Text. Sublime Text was also giving me issues yesterday. I'm hoping it's gonna work today. I think Visual Studio was locking the files, and then Sublime couldn't open them because Visual Studio locked them because it was using them and it forgot to unlock them or something. I don't know. So the output over here, copy, paste. I'll just look to compare the two. Compared to the old one, whatever. And if it makes the same output, then I can assume that everything works correctly because it loops through all possible type operations, combinations and stuff. So if like anything had issue, it'd be noticeable in the output, whatever. So I think everything's working, and I saved it back up like a minute ago, so I can delete all the broken backups I have from yesterday. Yesterday was hell. I don't even know what was going on. It's terrible. Nothing was working. So those are deleting. Close it. I'm gonna close everything and then restart, and hopefully it'll fix the screen flickering. I don't know. If I didn't know, I'd just fix why ever the screen's flickering, but I have no clue because the modern operating system is garbage. And I like how they call it the modern operating system. Modern. I guess this is just it's like a modern state of mind to think that it's acceptable for a product or an implementation that's designed by people, a collaboration of people, to create something for other people to make things on. I guess it's the new state of mind, the modern state of mind. It's acceptable to
Leak memory resources.
and it doesn't matter how that affects the end user. If some modern implementation of something,
Leak memory resources.
because it's not about the end user and their inconvenience. No, that doesn't matter at all. I guess that's the modern way of the world, I guess. I don't understand how it's ever acceptable to
Leak memory resources.
because you end up wasting people's time. People only have so much time, and when you make something that
Leak memory resources.
you are wasting their valuable time. So anyways, I'm gonna restart this computer because it keeps glitching or something. I'm gonna get Siri to read this documentation, and both of this Windows installation that's glitching and this OS X install, they're going to
Leak memory resources.
I think I clicked the button. Let me try it again. Wait.
Leak memory resources.
These are both modern operating system stuff, whatever, and they're gonna.
Leak memory resources.
So after 12 hours or so, they get kind of laggy because they,
Leak memory resources.
even though they're a modern operating system, I have to restart them from time to time. So I'm gonna restart this computer because it's potentially already,
Leak memory resources.
and if not, it's just a bug, which is why the screen is tearing. It might not be a memory leak, but who knows, because when it's acceptable for any form of whatever to,
Leak memory resources.
then anything is acceptable, and it's acceptable for the screen to tear like that. I don't know. I don't find any of this to be the modern operating system. I'm gonna Google what modern operating system means, and then I'm gonna take a break. I'll be back. I'm gonna restart this computer, this modern operating system on this modern computer, and I'm gonna try to work whatever.
A modern operating system is software that manages computer resources, provides a high-level programming environment.
Yeah, it's a modern operating system. It
Manages computer resources.
and also
Leak memory resources. Leak memory resources.
so a modern operating system that
Manages computer resources. Manages computer resources.
if it's leaking memory resources, I don't think it's very good at managing those resources.
Provides a high-level programming environment and offers a user interface for interacting with the system. It's evolved to handle complex tasks like managing processes.
I don't know how evolved the modern operating system is when it
Leak memory resources.
I don't think it's evolved very much because
Leak memory resources.
it's kind of it seems like is devolution like the opposite of evolution, devolution. I don't know.
It's evolved to handle complex tasks like managing processes, memory, and peripherals efficiently, while also incorporating multimedia support, network communication, and robust security features. Security features.
Nothing makes me feel like more secure than being spied on by Windows and Apple or Google. Really secure. Here's some key features of the modern operating system. I'm done complaining after this. I'm gonna actually do something or try.
Key features of modern operating systems. Resource management. Modern OSes manage CPU time, memory, input. Leak memory resources.
I just accidentally turned on the whatever the fuck this is called on Mac. I don't know how to turn it off. So I'm gonna just stop complaining and take a break. I'll be back. I think it's stuck. I can't turn this off, I don't know. There's no like thing at the bottom here to pick to turn off the magnifier. So I'll just like keep the magnifier. It's kinda cool. I'm done complaining, I'm just gonna whatever, I'll be back. I'm not done complaining though, just for now. I can't even see the screen. This is just... it's great. Can I even click the screen? I can't select, I guess, when it's magnified. Oh, it only does it on, I guess I just gotta like restart the PDF viewer. Okay, back to normal. I guess I don't have to fight the compiler right now, because it looks like it's working. I'll have Siri read the standard. I say standard, man, but I mean like air quotes because I don't think this is should be considered standard. I was gonna find like whatever those sound clips with like round one, ding 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 ding, and like fight the compiler and play a little sound clip, but I don't have to look it up now because it looks like it's working.
10.
So I'm gonna have Siri read this documentation, whatever. I'm gonna restart this computer and then I'll be back.
Object F takes arguments this argument, an ECMAScript language value, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Let target be F, let bound this be F, let bound args be F, let args be the list concatenation of bound args and arguments list. Return. Call. Target. Bound this, args 0, 4, 1, 2. Arguments list, new target. The internal method of a bound function exotic object f takes arguments list, a list of ECMAScript language values, a new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Let target be f, assert, is constructor, target, is true. Let bound args be f. Let args be the list concatenation of bound args and arguments list. If same value, f, new target, is true. Set new target to target. Return. Construct, target, args, new target, 0, 4, 1, 3. Bound function create, target function, bound this, bound args. The abstract operation bound function create takes arguments target function, a function object, bound this, an ECMAScript language value, and bound args, a list of ECMAScript language values, and returns either a normal completion containing a function object or a throw completion. It is used to specify the creation of new bound function exotic objects. It performs the following steps when called. Let proto be target function. Let internal slots list be the list concatenation of and the internal slots listed in table 31. Let obj be make basic object. Internal slots list. Set obj to proto. Set obj as described in 1 0, 4, 1, 1. If this constructor, target function, is true, then a set obj as described in 1 0, 4, 1. 2. Set obj to target function. Set obj to bound this. Set obj to bound args 0. Return obj 0, 4. To array exotic objects. An array is an exotic object that gives special treatment to array index property keys. C6, 1, 7. A property whose property name is an array index is also called an element. Every array has a non-configurable length property whose value is always a non-negative integral number whose mathematical value is strictly less than 32. The value of the length property is numerically greater than the name of every known property whose name is an array index, whenever a known property of an array is created or changed. Other properties are adjusted as necessary to maintain this invariant. Specifically, whenever a known property is added w, whose name is an array index, the value of the length property is changed, if necessary, to be one more than the numeric value of that array index, and whenever the value of the length property is changed. Every own property whose name is an array index whose value is not smaller than the new length is deleted. This constraint applies only to own. ECMA International 2024 187. Properties of an array and is unaffected by length or array index properties that may be inherited from its prototypes. An object is an array exotic object, or simply, an array, if its internal method uses the following implementation, and its other essential internal methods use the definitions found in 10.1. These methods are installed in array create 0, 4, 2, 1, p, desc. The internal method of an array exotic object takes arguments p, a property key, and desc, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If p is length, then a return array set length a desc. Else if p is an array index, then a let length desc be ordinary get own property a length b assert is data descriptor length desc is true c assert length desc is false d let length be length desc e assert length is a non-negative integral number f let index b 32 p g if index length and length desc is false return false h let succeeded b ordinary define own property a p desc I have succeeded is false return false j if index length then I set length desc to index plus 1 2 set succeeded to ordinary define own property a length desc 3 assert succeeded is true k return true return ordinary define own property a p desc 0 4 2 to array create length proto. The abstract operation array create takes argument length, a non-negative integer, and optional argument proton object, and returns either a normal completion containing an array exotic object or a throw completion. It is used to specify the creation of new arrays. It performs the following steps when called. If length 232.1, throw a range error exception. If proto is not present, set proto to %array prototype %. Let a be make basic object. Set a to proto. Set a is specified in 1 0 4 2 1. Perform. Ordinary define known property a length. Property descriptor length true false false. Return a 0 4 2 3. Array species create original array length. The abstract operation array species create takes arguments original array, an object, and length, a non-negative integer, and returns either a normal completion containing an object or a throw completion. It is used to specify the creation of a new array or similar object using a constructor function that is derived from original array. It does not enforce that the constructor function returns an array. It performs the following steps when called. Let is array be is array original array. If is array is false, return array create length. Let C be get original array constructor. If is constructor C is true, then 88. ECMA International 2024. Let this realm be the current realm record. B let realm.
And it looks like the screen is still tearing.
C realm is true. Set C to undefined. If C is an object, then set C to get.
I'm not gonna deal with distractions right now. So if the screen's gonna tear, it's gonna tear, I guess. My screen doesn't tear, but the other screen, it seems to be tearing and glitching. So my goal is to make some progress today on this program. I'm planning on 2 weeks. I have 7 days left now. Yesterday was hell. The compiler just kept getting stuck. My voice is cracking. I need some water. I put a pop in the freezer and it froze. So now I have warm pop. I'm gonna just imagine it's cold pop. It's not the same warm soda pop. I don't care, whatever it's called. I'm gonna imagine it's cold. There's imaginary ice cubes in this pop because the ice maker, the water line leaks or something from the ice maker. It falls down like the side and it makes this little icicle, and this little icicle forms right on the little lever that's connected to the ice thing that flips, and the icicle forms around that little lever, so the ice doesn't get made when it's stuck to the lever, and it did that, I guess. So I have no ice, so I also have warm water. So I have warm water, warm pop, and the screen's glitching on the stream. At least the compiler's working, so I'm going to go with whatever's working. I'm gonna focus on that, and then I'll deal with this other stuff later. Warm pop sucks. It's not cold. So yesterday I was overthinking and trying to overplan to not make mistakes because I'm streaming all this, and if I make a mistake, I feel like an idiot. Because if I make a mistake, it's a mistake. If I make a joke, it's a joke. So jokes, I don't care about. I'm trying to, whatever, be goofy. But when I make a mistake, it's like, fuck, that wasn't a joke. So I guess I'm gonna have to make tons of mistakes. This compiler, MSVC, it's not gonna work anyways. Nothing's gonna be ever in my favor. I'm gonna accept that. I'm just gonna get to working. So I'm gonna replace keywords and stuff like I did yesterday before the compiler went to poop and it started acting up and files are getting stuck. So I'm gonna do everything I did yesterday today, but I'm not gonna talk at all because I need to do actually get done what I was trying to do yesterday as fast as possible so I can get something done today. I don't know what I'm doing. So I'm like going to go through, find and replace these stupid keywords. I'm gonna build it, I'm gonna see if it builds. And I've decided that I'm gonna update everything to the common size T, whatever. Even where it's like a multiple of 4, that it shouldn't be a multiple of 8. It shouldn't break anything to make it a multiple of 8. It'll just waste memory because parts of it won't be used. And then later on I'll track down where it needs to be a multiple of 4 instead, and change only those places, because if I update and try to organize and pick which things need to be 64-bit and which things are based off 4 as a magic number relating to 32-bit, which aren't really 32-bit, I just use the number 4 because I was using 4 as a magic number and I had 4 types, and I shouldn't have done that because I need to add more types anyways. Instead of like trying to sort that out first, I'm gonna deal with possible truncation, data loss. I can break tons of stuff. My whole goal is to get this thing running in 64-bit so I can make a little like demo, get OpenGL running in a separate window, whatever, connect this to it, make like a little game demo with like a square cube or whatever, like really simple crappy demo, and I can like show how my engine's faster, JavaScript engine, that it doesn't leak memory. It's not the same as all the other JavaScript implementations. I don't know. So I'm gonna do whatever. My goal is to get done in 7 days, and I'm gonna try to make a little demo to show how fast it is, whatever, and that it can be used to like make video games, like real video games, like it's actually fast. And then I'm gonna go through this documentation. It's called the standard, I guess. So it's a standard. It literally says a standard right here. The mouse is even right here. It says standard, and then down here it says standard. Can you call that phone number? No, I'm not gonna call it. I think it's a phone number. I don't know who's gonna pick up. Like, hey, it's the ECMA standards. Nice talking to you. Okay. And in this standard, whatever.
Exotic object. It is used to specify the creation of new string exotic objects. It performs the following steps when called. Let S be make basic object. Set S to prototype. Set S to value. Set S as specified in 1 0 4 3 1. Set S as specified in 1 0 4 3.
And in this standard, it says
could leak memory resources in implementations.
So I don't know what kind of standard literally says
Could leak memory resources in implementations.
where a standard like says it's acceptable for there to be memory leaks in an implementation of our documentation because this thing's broke. In general, I don't know what kind of standard would do that, but this is a standard and it says that. It literally says
Could leak memory resources in implementations.
And I'm just gonna let it go and stop harping on that and get to work do what I said I was gonna do yesterday. After I'm done with all that, I get things renamed, whatever. Then I'll talk or whatever. I don't know, yeah. I think I'm like leaking my own memory resources, trying to like talk and actually do something because I just get stuck talking or doing something. I don't think I can do both, so I'm gonna stop talking and do something. Highlight and get this thing reading again.
Internal slot specification. Such state may consist of values of any ECMAScript language type or of specific ECMAScript specification type values. Unless explicitly specified otherwise, internal slots are allocated as part of the process of creating an object.
And now I'm going to try to get to work.
The initial value of an internal slot is the value undefined. Various algorithms within this specification create objects that have internal slots. However, the ECMAScript language provides no direct way to associate internal slots with an object. All objects have an internal slot named, which is a list of private elements. This list represents the values of the private fields, methods, and accessors for the object. Initially, it is an empty list. Internal methods and internal slots are identified within this specification using names enclosed in double square brackets. Table 4 summarizes the essential internal methods used by this specification that are applicable to all objects created or manipulated by ECMAScript code. Every object must have algorithms for all of the essential internal methods. However, all objects do not necessarily use the same algorithms for those methods. An ordinary object is an object that satisfies all of the following criteria for the internal methods listed in Table 4. The object uses those defined in 10.1. If the object has an internal method, it uses either the one defined in 1.0, 2, 1 or the one defined in 0, 3, 1. If the object has an internal method, it uses either the one defined in 1.0, 2.
And I'm just like documenting this, whatever. If you're watching this like in real time, you should like stop watching this and go live your own life, because you have your own stuff to be doing right now. So like stop watching this and go live life, because it's a waste of time to watch somebody else do something when you could be doing your own thing. Just saying.
Object. The signature column of Table 4 and other similar tables describes the invocation pattern for each internal method. The invocation pattern always includes a parenthesized list of descriptive parameter names.
It's a complete waste of time, of your time, if I have to click build on the compiler, and I have to physically sit here and wait for the compiler to build. So if the compiler takes 2 minutes to build, I have to wait 2 minutes of my life waiting for the compiler to build so I can advance on to the next step, whatever. And if you're watching this video as I'm waiting for 2 minutes, you're literally wasting 2 minutes of your life, because I'm just gonna be talking random stuff waiting, but you're waiting like for nothing, because you could be living your life. You don't have to wait for the compiler to build. So you should go do your own thing, like for real.
Piece for this object.
I got these stupid windows open, and I'm gonna try to get to work or whatever. The compiler seems to be working today. I'm really hoping that it's not gonna be like yesterday. I was so angry I was gonna lose it. I got nothing done. I just went in circle.
4. ECMA International 2024. Table 4. Essential internal methods. Continued. Internal method. Signature. Description. Prevent extensions. Boolean. Control whether new properties may be added to this object. Returns true if the operation was successful or false if the operation was unsuccessful. Get own property. Property key. Undefined property descriptor. Return a property descriptor for the own property of this object whose key is property key, or undefined if no such property exists. Define own property. Property key. Property descriptor. Boolean. Create or alter the own property, whose key is property key, to have the state described by property descriptor. Return.
And now it's building. So I gotta wait 2 minutes. You don't have to wait 2 minutes. You can go live your life. Go away. Get out of here.
Or inherited property whose key.
I gotta like open Sublime. It should build. It's built before it restarted. Okay, I'm gonna stop talking and do whatever I did yesterday again. The keywords and replace stuff.
Boolean. Set the value of the property whose key is property key to value. If any ECMAScript code must be executed to set the property value, receiver is used as this value when evaluating the code. Returns true if the property value is set or false if it could not be set. Delete property key. Boolean. Remove the own property whose key is property key from this object. Return false if the property was not deleted and is still present. Return true if the property...
I gotta wait. I can't hit save on anything until this is done, because I might screw it up. Get some more water.
Object that supports the internal method. A constructor is an object that supports the internal method. Every object that supports onStruct must support, that is, every constructor must be a function object. Therefore, a constructor may also be referred to as a constructor function or constructor function object. ECMA International 2024-45. Table 5. Additional essential internal methods of function objects. Internal method. Signature. Description. Call. Any. A list of any. Executes code associated with this object. Invoked via a function call expression. The arguments to the internal method are this value and a list whose elements are the arguments passed to the function by a call expression. Objects that implement this internal method are callable. Construct. A list of any object. Object creates an object. Invoked via the new operator or a supercall. The first argument to the internal method is a list whose elements are the arguments of the constructor invocation or the supercall. The second argument is the object to which the new operator was initially applied. Objects that implement this internal method are called constructors. A function object is not necessarily a constructor, and such non-constructor function objects do not have an internal method. The semantics of the essential internal methods for ordinary objects and standard exotic objects are specified in clause 10. If any specified use of an internal method of an exotic object is not supported by an implementation, that usage must throw a type error exception when attempted. 1. 7. 3 invariants of the essential internal methods. The internal methods of objects of an ECMAScript engine must conform to the list of invariants specified below. Ordinary ECMAScript objects as well as all standard exotic objects in this specification maintain these invariants. ECMAScript proxy objects maintain these invariants by means of runtime checks on the result of traps invoked on the object. Any implementation provided exotic objects must also maintain these invariants for those objects. Violation of these invariants may cause ECMAScript code to have unpredictable behavior and create security issues. However, violation of these invariants must never compromise the memory safety of an implementation. An implementation must not allow these invariants to be circumvented in any manner, such as by providing alternative interfaces that implement the functionality of the essential internal methods without enforcing their invariants. Definitions. The target of an internal method is the object upon which the internal method is called. A target is non-extensible if it has been observed to return false from its internal method. or true from its internal method. A non-existent property is a property that does not exist as an own property on a non-extensible target. All references to same value are according to the definition of the same value algorithm. Return value. The value returned by any internal method must be a completion record with either 46 ECMA International 2024 bullet type equals normal equals empty and equals the value of the normal return type shown below for that internal method, or type equals throw equals empty and equals any ECMAScript language value. Note 1. An internal method must not return a continue completion, a break completion, or a return completion. The normal return type is either object or null. If target is non-extensible and returns a value v, then any future calls to get prototype of should return the same value as v. Set prototype of v. The normal return type is Boolean. If target is non-extensible, must return false, unless v is the same value as the target's observed value is extensible. The normal return type is Boolean. If returns false, all future calls to on the target must return false. Prevent extensions. The normal return type is Boolean. If returns true, all future calls to on the target must return false and the target is now considered non-extensible. Get own property. P. The normal return type is either property descriptor or undefined. If the type of the return value is property descriptor, the return value must be a fully populated property descriptor. If P is described as a non-configurable, non-writable own data property, all future calls to P must return property descriptor whose is same value as P's attribute. If P's attributes other than and may change over time, or if the property might be deleted, then P's attribute must be true. If the attribute may change from false to true, then the attribute must be true. If the target is non-extensible and P is non-existent, then all future calls to P on the target must describe P as non-existent, that is, P must return undefined. Define own property. P desk. The normal return type is Boolean. Must return false if P has previously been observed as a non-configurable own property of the target, unless either P is a writable data property. A non-configurable writable data property can be changed into a non-configurable non-writable data property. All attributes of desk are the same value as P's attributes. Note to an object's prototype change should have finite length. That is, starting from any object, recursively applying the internal method to its result should eventually lead to the value null. However, this requirement is not enforceable as an object-level invariant if the prototype chain includes any exotic objects that do not use the ordinary object definition of. Such a circular prototype chain may result in infinite loops when accessing object properties. Note 3 is a consequence of the third invariant. If a property is described as a data property and it may return different values over time, then either or both of the and attributes must be true even if no mechanism to change the value is exposed via the other essential internal methods. ECMA International 2024-47, P desk must return false if target is non-extensible and P is a non-existent own property. That is, a non-extensible target object cannot be extended with new properties. Has property P. The normal return type is Boolean. If P was previously observed as a non-configurable own data or access a property of the target, has property must return true. The normal return type is any ECMAScript language type. If P was previously observed as a non-configurable, non-writable own data property of the target with value v, then, if P was previously observed as a non-configurable own access a property of the target whose attribute is undefined, the P v receiver. The normal return type is Boolean. If P was previously observed as a non-configurable, non-writable own data property of the target, then must return false unless v is the same value as P's attribute. If P was previously observed as a non-configurable own access a property of the target whose attribute is undefined, the P. The normal return type is Boolean. If P was previously observed as a non-configurable own data or access a property of the target, must return false. The normal return type is list. The returned list must not contain any duplicate entries. The type of each element of the returned list is either string or symbol. The returned list must contain at least the keys of all non-configurable own properties that have previously been observed. If the target is non-extensible, The returned list must contain only the keys of all known properties of the target that are observable using call. The normal return type is any ECMAScript language type. 8. ECMA International 2024. Bullet. The normal return type is object. The target must also have internal method. 6. 1. 7. For well-known intrinsic objects. Well-known intrinsics are built-in objects that are explicitly referenced by the algorithms of this specification and which usually have realm-specific identities. Unless otherwise specified, each intrinsic object actually corresponds to a set of similar objects, one per realm. Within this specification, a reference such as %name means the intrinsic object associated with the current realm corresponding to the name. A reference such as %name may be %means, as if the B property of the value of the A property of the intrinsic object %name was accessed prior to any ECMAScript code being evaluated. Determination of the current realm and its intrinsics is described in 9.4. The well-known intrinsics are listed in Table 6. Table 6. Well-known intrinsic objects. Intrinsic name. Global name. ECMAScript language association. Aggregate error %. Aggregate error. The aggregate error constructor. 20571. Array %. Array. The array constructor. 2311. Array buffer %. Array buffer. The array buffer constructor. 2514. Array iterator prototype %. The prototype of array iterator objects. 2315. Async from sync iterator prototype %. The prototype of async from sync iterator objects. 2714. Async function %. The constructor of async function objects. 2771. Async generator function %. The constructor of async iterator objects. 2741. Async iterator prototype %. An object that all standard built-in async iterator objects indirectly inherit from atomics %. Atomics. The atomics object. 25.4. Big int %. Big int. The big int constructor. 2121. Big int 64 array %. Big int 64 array. The big int 64 array constructor. 23.2. Big int 64 array %. Big int 64 array. The big int 64 array constructor. 23.2. Boolean %. Boolean. The boolean constructor. 2031. Data view %. Data view. The data view constructor. 2532. Date %. Date. The date constructor. 2142. Decodeary %. Decodeary. The decodeary function. 19261. Decodeary component %. Decodeary component. The decodeary component function. 19262. Encodeary %. Encodeary. The encodeary function. 19263. Encodeary component %. Encodeary component. The encodeary component function. 19264. Error %. Error. The error constructor. 2051. Copyright sign. ECMA International 2024. 9. Table 6. Well-known intrinsic objects. Continued. Intrinsic name. Global name. ECMAScript language association. Eval %. Eval. The eval function. 1921. Eval error %. Eval error. The eval error constructor. 20551. Finalization registry %. Finalization registry. The finalization registry constructor. 2621. Float 32 array %. Float 32 array. The float 32 array constructor. 23.2. Float 64 array %. Float 64 array. The float 64 array constructor. 23.2. For an iterator prototype %. The prototype of for an iterator objects. 14751. Function %. Function. The function constructor. 2021. Generator function %. The constructor of generators. 2731. Int array %. Int array. The int array constructor. 23.2. Int 16 array %. Int 16 array. The int 16 array constructor. 23.2. Int 32 array %. Int 32 array. The int 32 array constructor. 23.2 is finite percent is finite. The is finite function 1922 is nan percent is nan. The is nan function 1923 iterator prototype percent, an object that all standard built-in iterator objects indirectly inherit from JSON percent JSON. The JSON object 25.5 map percent map. The map constructor 2411 map iter at a prototype percent. The prototype of map iterator objects 2415 math percent math. The math object 21.3 number percent number. The number constructor 2111 object percent object. The object constructor 2011 parse float percent parse float. The parse float function 1924 parse int percent parse int. The parse int function 1925 promise percent promise. The promise constructor 2723 proxy percent proxy. The proxy constructor 2821 range error percent range error. The range error constructor 20552 reference error percent reference error. The reference error constructor 20553 reflect percent reflect. The reflect object 28.1 regexp percent regexp. The regexp constructor 2222450 ECMA International 2024 Table 6 well-known intrinsic objects. Continued. Intrinsic name, global name, ECMAScript language association, regexp string iterator prototype percent. The prototype of regexp string iterator objects 2229 set percent set. The set constructor 2421 set iterator prototype percent. The prototype of set iterator objects 2425 shared array buffer percent shared array buffer. The shared array buffer constructor 2523 string percent string. The string constructor 2211 string iterator prototype percent. The prototype of string iterator objects 2215 symbol percent symbol. The symbol constructor 2041 syntax error percent syntax error. The syntax error constructor 20554 throw type error percent, a function object that unconditionally throws a new instance of percent type error percent typed array percent. The superclass of all typed array constructors 2321 type error percent type error. The type error constructor 20555 data array percent data array. The data array constructor 23.2 8 clamped array percent 8 clamped array. The 8 clamped array constructor 23.2 16 array percent 16 array. The 16 array constructor 23.2 32 array percent 32 array. The 32 array constructor 23.2 Uri-error percent Uri-error. The Uri-error constructor 20556 weak map percent weak map. The weak map constructor 2431 weak ref percent weak ref. The weak ref constructor 2611 weak set percent weak set. The weak set constructor 2441 note additional entries in table 97 6.2 ECMAScript specification types. A specification type corresponds to meter values that are used within algorithms to describe the semantics of ECMAScript language constructs and ECMAScript language types. The specification types include reference, list, completion record, property descriptor, environment record, abstract closure, and data block. Specification type values are specification artifacts that do not necessarily correspond to any specific entity within an ECMAScript implementation. Specification type values may be used to describe intermediate results of ECMAScript expression evaluation, but such values cannot be stored as properties of objects or values of ECMAScript language variables. ECMA International 2024 51 6 2 1. The enum specification type. Enums are value s which are internal to the specification and not directly observable from ECMAScript code. Enums are denoted using a sans serif typeface. For instance, a completion records field takes on values like normal, return, or throw. Enums have no characteristics other than their name. The name of an enum serves no purpose other than to distinguish it from other enums, and implies nothing about its usage or meaning in context. 2.2 The list and record specification types. The list type is used to explain the evaluation of argument lists, C1338, in new expressions, in function calls, and in other algorithms where a simple ordered list of values is needed. Values of the list type are simply ordered sequences of list elements containing the individual values. These sequences may be of any length. The elements of a list may be randomly accessed using zero-origin indices. For notational convenience, an array-like syntax can be used to access list elements. For example, arguments 2 is shorthand for saying the third element of the list arguments. When an algorithm iterates over the elements of a list without specifying an order, the order used is the order of the elements in the list. For notational convenience within this specification, a literal syntax can be used to express a new list value. For example, 2 defines a list value that has two elements, each of which is initialized to a specific value. A new empty list can be expressed as, in this specification, the phrase the list concatenation of A, B, where each argument is a possibly empty list, denotes a new list value whose elements are the concatenation of the elements, in order, of each of the arguments. In order, the record type is used to describe data aggregations within the algorithms of this specification. A record type value consists of one or more named fields. The value of each field is an ECMAScript language value or specification value. Field names are always enclosed in double brackets. For example, for notational convenience within this specification, an object literal-like syntax can be used to express a record value. For example, 42, false, empty, defines a record value that has three fields, each of which is initialized to a specific value. Field name order is not significant. Any fields that are not explicitly listed are considered to be absent. In specification text and algorithms, dot notation may be used to refer to a specific field of a record value. For example, if R is the record shown in the previous paragraph, then R is shorthand for the field of R named. Schema for commonly used record field combinations may be named, and that name may be used as a prefix to a literal record value to identify the specific kind of aggregations that is being described. For example, property descriptor 42, false, true, 2.3 The set and relati on specification types. The set type is used to explain a collection of unordered elements for use in the memory model. It is distinct from the ECMAScript collection type of the same name. To disambiguate, instances of the ECMAScript collection are consistently referred to as set objects within this specification. Values of the set type are simple collections of elements, where no element appears more than once. Elements may be added to and removed from sets. Sets may be unioned, intersected, or subtracted from each other. The relation type is used to explain constraints on sets. Values of the relation type are sets of ordered pairs of values from its value domain. For example, a relation on events is a set of ordered pairs of events. For a relation R and two values are and B in the value domain of R, RB is shorthand for saying the ordered pair, A, B, is a member of R. A relation is least with respect to some conditions when it is the smallest relation that satisfies those conditions. 2. Copyright sign. ECMA International 2024. A strict partial order is a relation value R that satisfies the following. For all A, B, and C in R's domain, it is not the case that a RA, and if a RB and B are C, then a RC. Note 1. The two properties above are called reflexivity and transitivity, respectively. A strict total order is a relation value R that satisfies the following. For all A, B, and C in R's domain, A is B or a RB or BRA, and it is not the case that a RA, and if a RB and B are C, then a RC. Note 2. The three properties above are called totality, irreflexivity, and transitivity, respectively, 2. For the completion record specification type. The completion record specification type is used to explain the runtime propagation of values and control flow such as the behavior of statements, break, continue, return and throw, that perform non-local transfers of control. Completion records have the fields defined in Table 7. Table 7. Completion record fields. Field name, value, meaning, type, normal, break, continue, return, or throw, the type of completion that occurred, value, any value except a completion record, the value that was produced, target, a string or empty, the target label for directed control transfers. The following shorthand terms are sometimes used to refer to completion records. Normal completion refers to any completion record with a value of normal. Break completion refers to any completion record with a value of break. Continue completion refers to any completion record with a value of continue. Return completion refers to any completion record with a value of return. Throw completion refers to any completion record with a value of throw. Abrupt completion refers to any completion record with a value other than normal. A normal completion containing some type of value refers to a normal completion that has a value of that type in its field. Callable objects that are defined in this specification only return a normal completion or a throw completion. Returning any other kind of completion record is considered an editorial error. Implementation-defined callable objects must return either a normal completion or a throw completion. ECMA International 2024 53 6 2 4 1 Normal completion value. The abstract operation normal completion takes argument value any value except a completion record and returns a normal completion. It performs the following steps when called. Return completion record, normal, value, empty, 2, 4. 2 Throw completion, value. The abstract operation throw completion takes argument value, an ECMAScript language value, and returns a throw completion. It performs the following steps when called. Return completion record, throw, value, empty, 2, 4. 3 Update empty, completion record, value. The abstract operation update empty takes arguments completion record, a completion record, and value any value except a completion record, and returns a completion record. It performs the following steps when called. Assert. If completion record is either a return completion or a throw completion, then completion record is not empty. If completion record is not empty, return completion record. Return completion record, completion record, value, completion record, 2.5 The reference record specification type. The reference record type is used to explain the behavior of such operators as delete, type off, the assignment operators, the super keyword and other language features. For example, the left-hand operand of an assignment is expected to produce a reference record. A reference record is a resolved name or property binding. Its fields are defined by Table 8. Table 8. Reference record fields. Field name, value, meaning, base, an ECMAScript language value, an environment record, or unresolvable, the value or environment record which holds the binding. If unresolvable indicates that the binding could not be resolved. Reference name, a string, a symbol, or a private name, the name of the binding. Always a string if value is an environment record. Strict, a boolean, true if the reference record originated in strict mode code. False otherwise. This value, an ECMAScript language value or empty. If not empty, the reference record represents a property binding that was expressed using the super keyword. It is called a super reference record and its value will never be an environment record. In that case, the field holds this value at the time the reference record was created. The following abstract operations are used in this specification to operate upon reference records. 4. Copyright sign, ECMA International ONL 2024. 6. 2. 5. 1 is property reference, v. The abstract operation is property reference takes argument v, a reference record, and returns a boolean. It performs the following steps when called. If v is unresolvable, return false. If v is an environment record, return false. Otherwise return true. 2. 5. 2 is unresolvable reference, v. The abstract operation is unresolvable reference takes argument v, a reference record, and returns a boolean. It performs the following steps when called. If v is unresolvable, return true. Otherwise return false. 6, 2, 5, 3 is superreference. V. The abstract operation is superreference takes argument v, a reference record, and returns a boolean. It performs the following steps when called. If v is not empty, return true. Otherwise return false. 6, 2, 5, 4 is private reference. V. The abstract operation is private reference takes argument v, a reference record, and returns a boolean. It performs the following steps when called. If v is a private name, return true. Otherwise return false. 6, 2, 5, 5 get value. V. The abstract operation get value takes argument v, a reference record or an ECMAScript language value, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It performs the following steps when called. If v is not a reference record, return v. If is unresolvable reference, v is true. Throw a reference error exception. If is property reference, v is true. Then a let base obj be. To object, v. B if is private reference, v is true. Then I return. Private get base obj v. C return base obj get this value v. Else a let base be v. B assert base is an environment record. C return base get binding value v. V. C 9.1. Note the object that may be created in step 3 is not accessible outside of the above abstract operation in the ordinary object. ECMA International 2024 55 6, 2, 5, 6 put value v. W. The abstract operation put value takes arguments v, a reference record or an ECMAScript language value, and W, an ECMAScript language value, and returns either a normal completion containing unused or an abrupt completion. It performs the following steps when called. If v is not a reference record, throw a reference error exception. If is unresolvable reference, v is true. Then, if v is true, throw a reference error exception. B let global obj be get global object. C perform. Set global obj v. W. False. D return unused. If as property reference, v is true. Then a let base obj be. To object, v. B if as private reference, v is true. Then I return. Private set base obj v. W. C let succeeded b. E base obj w. Get this value v. D if succeeded is false and v is true. Throw a type error exception. E return unused. Else a let base be v. B assert base is an environment record. C return base set mutable binding v. W. V. C 9.1, 2, 5, 7 get this value v. The abstract operation get this value takes argument v, a reference record, and returns an ECMAScript language value. It performs the following steps when called. Assert is property reference, v is true. If is super reference, v is true. Return v. Otherwise return v, 2, 5, 8 initialize reference binding v. W. The abstract operation initialize reference binding takes arguments v, a reference record, and w, an ECMAScript language value, and returns either a normal completion containing unused or an abrupt completion. It performs the following steps when called. Assert is unresolvable reference, v is false. Let base be v. Assert base is an environment record. Return base initialize binding v. W, 2, 5, 9 make private reference base value private identifier. The abstract operation make private reference takes arguments base value, an ECMAScript language value, and private identifier, a string, and returns a reference record. It performs the following steps when called. Let privy be the running execution context's private environment. Assert privy is not null. Let private name be resolved private identifier, privy private identifier. Return the reference record. Base value, private name. True. Note the object that may be created in step 3 is not accessible outside of the above abstract operation in the ordinary object. 6. ECMA International 2024. This value, empty. 6. 2. 6. The property descriptor specification type. The property descriptor type is used to explain the manipulation and reification of object property attributes. A property descriptor is a record with 0 or more fields, where each field's name is an attribute name and its value is a corresponding attribute value as specified in 6. 1. 7. 1. The schema name used within this specification to tag literal descriptions of property descriptor records is property descriptor. Property descriptor values may be further classified as data property descriptors and accessor property descriptors based upon the existence or use of certain fields. A data property descriptor is one that includes any fields named either raw. An accessor property descriptor is one that includes any fields named either. Any property descriptor may have fields named and a property descriptor value may not be both a data property descriptor and an accessor property descriptor. However, it may be neither, in which case it is a generic property descriptor. A fully populated property descriptor is one that is either an accessor property descriptor or a data property descriptor and that has all of the corresponding fields defined in Table 3. The following abstract operations are used in this specification to operate upon property descriptor values. 6. 2. 6. 1 is accessor descriptor, desc. The abstract operation is accessor descriptor takes argument desc, a property descriptor or undefined, and returns a boolean. It performs the following steps when called. If desc is undefined, return false. If desc has a, return false. 2. 6. 2 is data descriptor, desc. The abstract operation is data descriptor takes argument desc, a property descriptor or undefined, and returns a boolean. It performs the following steps when called. If desc is undefined, return false. If desc has a field, return true. If desc has a field, return true. Return false. 2. 6. 3 is generic descriptor, desc. The abstract operation is generic descriptor takes argument desc, a property descriptor or undefined, and returns a boolean. It performs the following steps when called. If desc is undefined, return false. If is accessor descriptor, desc, is true, return false. If is data descriptor, desc, is true, return false. Return true. 2. 6. 4 from property descriptor, desc. The abstract operation from property descriptor takes argument desc, a property descriptor or undefined, and returns an object or undefined. It performs the following steps when called. If desc is undefined, return undefined. Let obj be ordinary object create, %object prototype %assert. Obj is an extensible ordinary object with no own properties. If desc has a field, then a perform. Create data property or throw obj value desc. ECMA International 2024 57. 5. If desc has a field, then a perform. Create data property or throw obj writable desc. If desc has a perform. Create data property or throw obj get desc. If desc has a perform. Create data property or throw obj set desc. If desc has an field, then a perform. Create data property or throw obj enumerable desc. If desc has a field, then a perform. Create data property or throw obj configurable desc. 0. Return obj, 2. 6. 5 to property descriptor obj. The abstract operation to property descriptor takes argument obj, an ECMAScript language value, and returns either a normal completion containing a property descriptor or a throw completion. It performs the following steps when called. If obj is not an object, throw a type error exception. Let desc be a new prop descriptor that initially has no fields. Let has enumerable be has property obj enumerable. If his enumerable is true, then a let enumerable be to boolean. Get obj enumerable be set desc to enumerable. Let has configurable be has property obj configurable. If his configurable is true, then a let configurable be to boolean. Get obj configurable be set desc to configurable. Let has value be has property obj value. If his value is true, then a let value be obj value b set desk to value. Let has writable be. Has property obj writable 0. If his writable is true, then a let writable be to boolean. Get obj writable be set desk to writable 1. Let his get be. Has property obj get 2. If his get is true, then a let getter be. Get obj get be if is callable. Getter is false and getter is not undefined. Throw a type error exception c set desk 3. Let his set be. Has property obj set 4. If his set is true, then a let setter be. Get obj set be if is callable. Setter is false and setter is not undefined. Throw a type error exception c set desk 5. If desk has a field, then if desk has a field or desk has a field, throw a type error exception 6. Return desk, 2, 6. 6 complete property descriptor desk. The abstract operation complete property descriptor takes argument desk, a property descriptor, and returns unused. It performs the following steps when called. 2. Let like be the record. Undefined. False. Undefined. False. False. If is generic descriptor desk is true or is data descriptor desk is true, then 8. ECMA International 2024 AB. If desk does not have a field, set desk to like. If desk does not have a field, set desk to like. 3. Else. If desk does not have a to like. B. If desk does not have a to like. If desk does not have an field, set desk to like. If desk does not have a field, set desk to like. Return unused. 2.7 The environment record specification type. The environment record type is used to explain the behavior of name resolution in nested functions and blocks. This type and the operations upon it are defined in 9.1, 2.8 The abstract closure specification type. The abstract closure specification type is used to refer to algorithm steps together with a collection of values. Abstract closures are meter values and are invoked using function application styles such as closure, arg1, arg2. Like abstract operations, invocations perform the algorithm steps described by the abstract closure. In algorithm steps that create an abstract closure, values are captured with the verb capture followed by a list of aliases. When an abstract closure is created, it captures the value that is associated with each alias at that time. In steps that specify the algorithm to be performed when an abstract closure is called, each captured value is referred to by the alias that was used to capture the value. If an abstract closure returns a completion record, that completion record must be either a normal completion or a throw completion. Abstract closures are created in line as part of other algorithms, shown in the following example. Let addend be 41. Let closure be a new abstract closure with parameters x that captures addend and performs the following steps when called. A return x plus addend. Let val be closure 1. Assert val is 42, 2.9 data blocks. The data block specification type is used to describe a distinct and mutable sequence of bite-sized 8-bit numeric values. A byte value.
I really hate const in JavaScript. I wish there was a way to make like a window object const, because if you define something that's constant once, even if it appears a second time, it'll be an error. So if you have two files that both define the thing as constant, even if it's the same, it counts as an error. So you have to turn it off in one of the files or the other. In C, I think that it doesn't throw an error, I'll just ignore it. But there's no way to like test, or easy way. There might be a way if eval is used, but then it's like a hack. I don't know. I'm gonna Google if there's a way to like make something constant that's in Windows scope or whatever, so I can like access it, because I want to wrap things in if-else blocks, so I can turn stuff like on, off, whatever.
Please consult the memory model for full semantics. Shared data block events and moduled.
Yesterday I was gonna like skip the JavaScript file, but now that things are working today, I'm gonna like try to get the tags in this JavaScript file. The one that's like the obvious one or whatever that was the issue last time. I'm gonna do this one first, and then I'll get the C files replaced and stuff. I don't know, this was all I was trying to do yesterday, and the files kept getting stuck. I think the files were getting stuck like way before in the compiler, and like files weren't saving, because I think I pulled up a couple files and I'm like, I thought I already did this file, and I hit save but it wasn't saving. I don't know, it was really confusing, and today things like seem to be working. I don't know, I was really annoyed yesterday. I threw a little fit, if you call that a fit. I think it's justified. I don't have time for this crap. I don't know. Windows sucks. I'm gonna try to look up some stuff with JavaScript or whatever.
For each index I of DB, do a append.
I'm not gonna get distracted, so I'm gonna stop talking and try to whatever, do something. Looking this up is gonna be distraction, so I'm gonna not look up what it just said I was gonna do. I'm just gonna not make these things constant, or I'll get rid of the if block. I'm gonna do that, and I'm gonna keep working. I'm not gonna get distracted today. I'm gonna try to not go off on some strange tangent and end up not doing anything because whatever. I'm gonna try to focus, I guess.
Number of bytes into block. Assert. To index plus count to size.
No, I'm gonna try to look up whatever.
0. ECMA into.
I just won't spend a whole lot of time trying to figure out how to make something constant that's not, that is a window or some property of a object or variable, whatever. So I can like test if it's defined, define it if not, but not have it throw an error as being defined constant twice, because I can't wrap it in block scope. Because when you put it in block scope, it's only constant and existent within that scope. I can't really explain whatever. If you don't know JavaScript, then you don't know JavaScript.
True to block. Byte int x to index 1 bytes to events record 9. Else set to block to int x to bytes 0 be else. I assert to block is not a shared data block. 2. Set to block to int x to from block from index. C set to index plus 1. D set from index to from index plus 1. E set count to count 1. Return unused. 2.10 The private element specification type. The private element type is a record used in the specification of private class fields, methods, and access source. Although property descriptors are not used for private elements, private fields behave similarly to non-configurable, non-enumerable, writable data property.
They added so much stuff to JavaScript. Unless this was there the whole time. There's a whole lot of stuff I'm gonna have to add to the stupid engine.
Referred to as private elements. Table 9. Private element fields. Field name. Values of the field for which it is present. Value. Meaning. Key. All. A private name. The name of the field. Method. Or accessor. Kind. All. Field. Method. or accessor, the kind of the element, value, field and method, an ECMAScript language value, the value of the field, get, accessor, a function object or undefined, the getter for a private accessor, set, accessor, a function object or undefined, the setter for a private accessor. The 6th of February 2011, the class field definition record specification.
I guess it's been there for a while.
Is a record used in the specification of class fields. Values of the class field definition type are record values whose fields are defined by table 10.
I wonder if the ECMA 5 has the word leak in the documentation. I'm gonna look that up, and then I'm gonna try whatever this is, and then I'm gonna get back to staying on track or whatever.
The field, if any, copyright sign, ECMA.
This is the 15th edition, and it contains the word.
Type is used to describe a globally unique value, one which differs from any other private name, even if they are otherwise indistinguishable.
It contains the word leak, and they say could leak memory resources and some implementations. I'm done complaining about that. I complained about that for like way too long. It's not funny anymore. It probably wasn't funny to start with, but I was just whatever, going with it.
2.13.
So I'm gonna look up the ECMA script 5, because this is script 15. I'm gonna see if script 5 has the word leak in it.
Block definition record fee, else abstract operations. These operations.
And then I'm gonna stop getting distracted because I gotta make up for whatever time was left yesterday during last stream.
Specialized abstract operations are defined throughout.
I got absolutely nothing done that stream other than end up frustrated and pissed off because nothing was working and whatever.
Constructs it is useful to define a set of conversion abstract operations. The conversion abstract operations are polymorphic. They can accept a value of any ECMA.
So here's a 5th edition of the ECMA 262.
These operations. The big int type has no impact.
I wonder. Oh wow, looks the same. That's weird. I thought they would have souped it up or something. Like maybe the colors are a little bit different. I don't know.
An ECMAScript language value and optional argument preferred type, string or number, and returns either a normal completion containing an ECMAScript language value or a throw completion. It converts its input argument to a non-object type. If an object is capable of converting to more than one primitive type, it may use the optional hint preferred type to favor that type. It performs the following steps when called: field name, value, meaning, body function, an ECMAScript function object, the function object to be called during static initialization of a class. 1. If input is an object, then 2. ECMA International 2024 AB. Let exotic to prim B. Get method, input, add at to primitive. If exotic to prim is not undefined, then I have preferred type is not.
I got the 2005 standard and
Preferred type is string, then 1. Let int be string. 3. Else assert. Preferred type is
the 2020-24. 2024.
result is not an object. Return result. V.
Standard.
Let preferred type be number. D. Return. Ordinary to primitive. Input. Preferred type 2. Return input, comma 1. 1. 1 ordinary to primitive. O. Hint. The abstract.
Yeah, the keyboard's just not working.
Object. And hint. String or number. And returns either a normal completion containing an ECMAScript language.
Okay, the colors, they did change slightly. This one is better, the 2025. This one, the colors are kinda, they clash a bit too much. This is better. I don't know. I like the color palette in the 2025, 2024 spec, whatever. Alright, so I'm gonna look for the word leak.
Argument.
I want to see how many pages it is.
If argument is a boolean, return
Oh, fuck.
null plus
It's only
n
241 pages. Dang it. The new standard's like 801.
turn true, comma 1.3 to numeric value. The abstract operation to numeric takes argument value, an ECMAScript language value, and returns either a normal complete.
The new standard has 804 pages. They added so much more stuff. I should have made this back in 2009. Oh man.
Value and
Okay, so I'm gonna look for the word leak.
a number or a throw completion. It converts argument to a value of type number. It performs the following steps when called. If argument is a number, return argument. If argument is either a symbol or a big int, throw a type error exception. If argument is undefined, return none. When a primitive is called without a hint, then it generally behaves as if the hint were number. Note, however, objects may override this behavior by defining.
The word leak does not appear in the 2005 ECMA 262 standard. Okay, so I would consider this a golden standard. It doesn't have the word leak. But the 2024 ECMA 262 standard has the word leak in it. It does look better color-wise, the color palette, but that's just that's visual. I'm talking about the context of the document, the what's the word?
Specifies how to convert a
I have to stop wasting time.
str white spaciart str white spaciart.
But this has the word leak in it. I do Command F, leak.
White space char str white spaciart str white space char.
And right there, it says the word leak.
Numeric literal str decimal literal. No.
It doesn't only say the word leak. It says unlikely to be collected and could leak memory resources in implementations. This gives an excuse, and it says it's okay. Some JavaScript implementations are going to leak memory. That's not acceptable. I don't know. At some point, whatever standard between 2009,
Grammar for new.
I think 2009, whatever, this standard, and this standard, something, it went to poop.
Literal, a string.
So I'll stop talking about the standards, and
Line terminators, a string numeric literal that
I'll get to dealing with this poop. When I get to this poop,
may include a plus or to indicate its sum.
because it's probably full of poop. And
Infinity are recognized as a string.
I found out that you can do this with constants, whatever, or to make something constant. But
Include a numeric.
I don't want to like type this up and then test it and then see if it works and find out it doesn't work as expected, so I'm not going to do this. And I'm just going to get rid of the blocks and use const. So I didn't waste time because I learned something, but I don't want to implement this right now because I might end up with new issues. So I'm just going to I'm gonna stop getting distracted and keep going or whatever.
1. To runtime semantics. String numeric value. The syntax-directed operation string numeric value takes no arguments and returns a number. It is defined piecewise over the following productions. String numeric literal, str white spaciapt 1. Return +0. String numeric literal, str white spaciapt str numeric literal str white spaciapt 1. Return string numeric value of str numeric literal, non-decimal integer literal 1. Return MV of non-decimal integer literal, str decimal literal, str unsigned decimal literal. Letter B string numeric value of str unsigned decimal literal. If A is +0, return -0. Return A, str unsigned decimal literal, infinity 1.
Now it should build. It's building. Ta-da! Okay, I'm gonna like shut up and do stuff.
Digits. B let n be the number of code points in the second decimal digits. Else a lep 0, b let n 0. If exponent part is present.
I replaced the sign type whatever keyword with whatever keyword I talked about yesterday in the JavaScript file the JavaScript file included in HTML file, and the HTML file makes an output that I paste into the C program for some things, because some things it's a pain to write by hand, so I like used JavaScript as like macro replacement and stuff, because in the C compiler I keep pushing the C compiler to the limit, and it complains and it bitches and it poops out and it can't make the program. So I had to like do some of the work ahead of time by like manually expanding the, some of the data structures, whatever. I use JavaScript to do it, so I have to like run it, copy paste it or whatever, because the C compiler has limits on macro nesting, so I had to like unroll some of the macros and generate them separate to put into the C compiler. And I used the HTML, the browser, whatever, because it's easier than making a C program, because otherwise I'd have to edit the code, I have to compile it to make the program, and then I have to like run this compiler again to compile that compiled program, and that's really annoying. So like I just use the browser for this stuff, and to like make it easier to like tell apart what's actually part of the JavaScript engine and like what files are used to like make some of the files, because the Microsoft Visual Studio compiler, this compiler,
the abstract operation to integer or infinity takes argument in ECMAScript language value and returns either a normal completion containing either an integer, plus, or a throw completion.
Because this compiler, Microsoft Visual Studio, it's a complete piece of trash. It sucks. It wastes time. It gets stuck on files. It locks up the computer. It doesn't work half the time, but when it is working, it does work. But when it doesn't work, it's hell.
Truncate R number, 1.6.
And it's like, I mean like literally hell. It will take a file, it'll change the line ending. It does the stupidest stuff.
Integral number or throw completion. 1 of 232. Integral number values in the inclusive interval from -231 to 231.1. It performs the following.
Okay, so here, whatever. How to fix inconsistent line endings for whole Visual Studio solution. I'll have Siri read this whatever.
2. Event 30. How to fix inconsistent line endings for whole versus solution. Stack Overflow. 5 answers. 13 years ago.
13 years ago? Dang. And it still has problems. That sounds like a bug. I don't know.
Visual Studio will detect inconsistent line endings when opening a file, and there is an option to fix it for that specific file.
Never click that option to fix it for that file, because sometimes the file will like disappear or it'll turn to garbage. Like it'll just like be a bunch of random characters and you'll lose everything inside of that file. You can click it at your own risk, but I never click that again, ever. I don't even use the text editor part inside of Visual Studio. Like, I will never. I did that a couple streams ago. That's probably what caused the later issues. But I will never, ever actually edit code inside of this garbage. Inside of the text editor or whatever. Because when you edit code in here, the files get like tied up with the compiler and it'll completely fuck you over. So I don't edit in here. I use a separate text editor. Okay, I don't know what I'm even. I hate this compiler. It is a piece of garbage. And the whole like line ending thing for files. It's the stupidest fucking thing. It's so annoying. Okay, I'm done. I'm gonna focus now. I don't know. Whatever. Visual Studio sucks. I gotta like reselect and get this thing reading ECMA. I might need to take a break. I can't focus, whatever. One
declarative environment records. Each declarative environment.
I think I compensate focus for complaints.
Module import and.
So I'm like complaining to like, yeah, compensate for focusing. I think the mic was like feeding back into the program that whole time. If it was, I don't know, that wasn't actually on purpose. I don't know. Sometimes I do something to be funny, and sometimes it's just totally on accident. So if it was like feeding back and the voice was doubling, oops, that was whatever.
Return false.
I need to focus or whatever.
Create mutable binding. ND. The create mutable binding concrete method of a declarative.
I need to listen to some loud music and like get in the zone and get to programming.
Containing unused. It creates a new mutable binding for the name and that is uninitialized. A bind.
But I replaced all the stuff. I got a little distracted. And I'm gonna check the output. And I think that all the signed int types were replaced in the JavaScript files. So I'm gonna paste this to the C files. I'll run the compiler, save it back up, and really, really hope that the compiler isn't going to do whatever it did yesterday. So, I don't know. And the screen tearing seems to be getting worse. At some point, I might try to figure out what's going on, but I just went off on a little distraction. So, I'm gonna wait to deal with the screen tearing for later. Unless it kind of like stays as it is and doesn't get worse, I'll just leave it. But if it gets like, I think it's getting worse. I don't know. Yeah, it's getting worse for sure. I'll try to figure out after I try to whatever, do some other stuff. Whatever I said I was doing, I'm gonna try to do that first.
The initialize binding concrete method of a declarative environment record the end.
The freaking keywords. Make sure they're all like replaced. The signed ones, whatever, are tagged with the new tag. I gotta like check this file though to make sure like it's tagged as a number and it is a number. I'm not mixing it up with an address. So I gotta like click through all the places we've placed. And if it's good, it's good. So I'm gonna run the compiler, paste these in, and then I'm gonna get to the C files and then I'll update those where it's using the sign type. I'm gonna just make everything that's size C4 to size C8.
Arguments n, a string, v.
And then later on I'll deal with like compressing some things by using a smaller number where it's like not mixed up, whatever. There are some places where I'm not gonna think ahead. I'm just gonna like identify where it's a number or an address. Use the new type tags to do that. And then after that, I'll go through and try to like sort out where it's not like I need some water. Where the number's not, where it doesn't hold relation to the machine word size C, common register size C, common value size C, address space size C, whatever size C, that's the size C of the build, target build. I gotta like figure out where it's just a number 4 or where it's supposed to be a 4-byte type. Make another tag and then tag those individually to separate them from where it's supposed to match the common value size C. I just want to say like size T again because I said it so many times, size T. So I'm gonna finish up this size T stuff with the signed size T. Then I'm gonna deal with the unsigned size C, which will be more complicated because it's usually generally going to be an address or a number, but the signed size C, I'm like 99% certain that wherever it's used, it doesn't involve an address because yeah, I'll stop talking now and do stuff.
Exception. Return the value currently bound to n in envrec, 1, delete binding, n. The delete binding concrete method of a declarative environment record the envrec takes argument n, a string, and returns a normal completion containing a boolean. It can only delete bindings that have been explicitly designated as being subject to deletion. It performs the following steps when called. Assert. envrec has a binding for n. If the binding for n in envrec cannot be deleted, return false. Remove the binding for n from envrec. Return true, 1, 8 has this binding. That has this binding concrete method of a declarative environment record the envrec takes no arguments and returns false. It performs the following steps when called. Return false, 1. 9 has super binding. That has super binding concrete method of a declarative environment record the envrec takes no arguments and returns false. It performs the following steps when called. Return false, 1. 10 with base object. The with base object concret method of a declarative environment record envrec takes no arguments and returns undefined. It performs the following steps when called.
I don't know, probably not watching, but there's people that I don't have time to like just get your shit together. Just do it. Get your shit. Just put it together. Get your shit together.
Property keys that
I don't have time for like empathy and like being just whatever. Yeah.
neither a function environment record nor a module environment record. Does not provide this binding. Note a regular declarative environment.
Yeah.
It is super binding. 38. Copyright sign. ECMA International 2024. Because properties can be dynamically added and deleted from objects, the set of identifiers bound by an object environment record may potentially change as a side effect of any operation that adds or deletes properties. Any bindings that are created as a result of such a side effect are considered to be a mutable binding, even if the writable attribute.
I'm gonna find all the sign types, whatever.
18.11 can provide the binding object as an implicit this value for use in function calls. The capability is controlled by a Boolean field. Object environment records have the additional state fields listed in table.
Let's check. 2,370, I guess. There's only...
Records is defined by the following algorithms.
There's probably like a couple hundred in the file. Oh wait, hold on.
A string, and returns either a normal completion containing a Boolean or a throw completion. It determines if its associated binding object has a property whose name is n. It performs the following steps when called. Let binding object be envrec. Let found binding be has property.
Okay, there's 20 matches, but only 1, 2, 3, 4. Only 16 of them. I actually like use some of them in like comments, whatever. So 16 of this signed size T type that's a number. I'm tagging it as like a number, not as an address, whatever. There's only 16 of them in the HTML file. And it expands when I make the file, whatever, to 2,370 places, whatever. Oh, it's because I have a table that is loading up and it goes through each one. That's a different file. I'm gonna have to like go through like a whole bunch of files later, JavaScript files. I don't know, I got like the main ones, I think. So I don't know, I'm just gonna like check through all 2,000 of these, so I don't have to find the table, because the table itself that I'm using, it doesn't have a type. It just it has the pre-computed whatever. When yeah, never mind. It's complicated. I'm gonna just check everywhere, whatever, where this sign type comes up, and make sure it's a number, and it's a place where it's actually supposed to be a size T, and not like the number or a 4-byte number, which is 30-bit. So I'm gonna like check this, I guess, and then I'll paste it into the C file. I'll run the compiler, and then I'm gonna I don't know. Save it back or whatever. Then I'll get all the unsigned types. I'm gonna have to get this JavaScript file. I'll probably do this file first for the unsigned types. And I'll remake it, paste in the C program, check it, build it, run it, save it back up. Then I'll get all the unsigned types in the C program, and they're gonna be, or it's gonna be used as a size C number, a 4-byte number, or an address space size T number. And I have to tag the 3 separate ones, but for now I'm just going to tag between the number, the size T number, and the address size T number, and where it has to be a 4-byte number specifically. I'll do that later because I want to tag everything as the bigger type. I kind of like debated this back and forth last stream. Need some water. But I want to expand or define everything as an expanded, the bigger number, that I can go through and fine tune where it's only a 4-byte number, so that there's no data loss. Because if I define things in the first place as a 4-byte number, it's supposed to be a size C number, I'll have data loss. And I really got to kind of like go through the whole thing. I'm starting to like remember how this whole program's set up. I still need to find my notes on this, but I can kind of like remember where lots of stuff is now. So I want to go through, just tag everything as a size C number, and then an unsigned size C number. I still gotta do assigned numbers, whatever. I just want to tag everything as the big type, the larger one, to make sure there's no data loss. And I'm going to go through and get all the places where it's supposed to be 4-byte size C. And I could run it as a 64-bit executable at that point. There'll be less warnings, but there's places where there's address arithmetic, and those will just completely fail because all the offsets will be by 4-byte, but it has to be 8-byte now, so I can't run it yet. And that's what I'm trying to do before, in like 6 days, whatever. I want to be done. So I'm going to try to like focus and do this so I can get to the addressing. I want to try to get to the addressing today. I should be able to get all these signed, unsigned types tagged and using a new keyword. I think in a couple hours, if I just actually focus. And if I get to the addresses, I don't know, that'd be like really nice. And then it's like tomorrow, the next couple days, I could possibly get this thing running in 64-bit mode. And then I gotta like figure out, I don't know, make a little game demo. I think I'll just like let the browser use Canvas or whatever. There's like, I'm gonna figure out whatever the easiest way to like get some little demo running. I'll have like a little cube that like jumps around whatever in like a 3D space. I have like chatbot make it, and I'll like run JavaScript, like a modern JavaScript implementation, and I'll run mine. I don't know, I've said all this before, so I think it's the same plan as yesterday or whatever. So I'm gonna like replace this stuff and stuff.
Its value is undefined. Copyrights.
I try to check this file, whatever.
environment record methods listed in table 16 and
because I can check the file where it's defined that it expands at. I really need some water. I can check that file, those 16 places, but it's really complicated and I don't know what the output looks like, so I'm just going to check the actual output instead of what makes the output, because I don't know what is being like passed to be expanded to make this output, because the table that's used, whatever, it's all logic. There's no like actual data type sizes until it gets popped out as the output. If that whatever makes any sense, I'm just gonna check through this really quick. I don't know. I'm gonna try to like get as much done as possible. This is so boring. If I can like make progress and not get bored, and if I can hydrate, and I don't forget to like drink water. I forgot my train of thought. The train has left the station, so I'm just gonna like whatever, check all these, whatever, and try to make progress. I'm gonna fix the screen tearing, I think, eventually. But that's a distraction. I'm gonna stay on task, I guess.
performs the following steps when called. If the envrec is left,
Instead of complaining from now on, I'll try to do something productive. So I'm gonna stop with my little rants, and I'll fix the screen the next time I need a distraction, instead of compensating for being distracted with complaints.
it performs the following steps.
And it's like a productive use of distraction.
envrec is uninitialized. Throw a reference error exception. Return the envrec. 42. ECMA International 2024. 9. 1. 1. 3. 5. Get superbase. The get superbase concrete method of a function environment record the envrec takes no arguments and returns either a normal completion containing either an object, null, or undefined, or a throw completion. It performs the following steps when called. 1. Let home be envrec. If home is undefined, return undefined. Assert home is an object. Return home, 1. 1. 4 global environment records. A global
I'm gonna have to make all new tables for these stupid new types. It's gonna be work
global
to like update all the stuff.
2. 9. The 8th of February 2011, that occur within a script. A global environment record is logically a single record, but it is specified as a composite encapsulating an object environment record and a declarative environment record. The object environment record has as its base object the global object of the associated realm record. This global object is the value returned by the global environment records. Get this binding concrete method. The object environment record component of a global environment record contains the bindings for all built-in globals, clause 19, and all bindings introduced by a function declaration, generator declaration, async function declaration, async generator declaration, or variable statement contained in global code. The bindings for all other ECMAScript declarations in global code are contained in the declarative environment record component of the global environment record. Properties may be created directly on a global object. Hence, the object environment record component of a global environment record may contain both bindings created explicitly by function declaration, generator declaration, async function declaration, async generator declaration, or variable declaration declarations, and bindings created implicitly as properties of the global object. In order to identify which bindings were explicitly created using declarations, A global environment record maintains a list of the names bound using its create global var binding and create global function binding concrete methods. Global environment records have the additional fields listed in Table 20 and the additional methods listed in Table 21. Table 20.
It's gonna suck to update.
Realm global this value an object the value returned by this in global scope. Hosts may provide any ECMAScript object value. Declarative record. A declarative environment record contains bindings for all declarations in global code for the associated realm code except for function declaration, generator declaration, async function declaration, async generator declaration, and variable declaration bindings. Var names, a list of strings, the str names bound by function declaration, generator declaration, async function declaration, async generator declaration, and variable declaration declarations in global code for the associated realm. Copyright sign, ECMA International 2024.
After I get everything using like these keywords, whatever, like size T number, I'm meant to find everywhere it says like uint 32 and replace it with size T or something. Because now that's gonna be 64-bit or 32-bit. It's not gonna be 64 or 32. It'll be either, depending on the build mode, which is why I made these types, whatever, to tag everything. So everything will be tagged to pick 32 or 64. So I'm gonna have to like, but there are places where it needs to be a 32-bit number specifically, and those are the annoying places because I gotta sort those out after, because not all of the places need to be updated to like the size T, which will be like 32 or 64. So if I do if I drink water, I'd probably be able to talk without my voice scratching, but if I did a Control F on every variable tagged with this, there's probably gonna be a whole lot of them. So I'll deal with that later. All I want to do is get the type tagged, and then later on I'll check to see to find all the places where the type itself, like size T, whatever, if it doesn't match the name, it's like uint32, it needs to be size T now to specify whatever. So like wherever like the type tag doesn't match the name, the variable name, the type that it's tagged with in the name, I'll have to go through and update all of them. That's probably the only good thing that I did when I wrote this originally, is I like named the variables with the type after it. So that's probably the only amount of planning ahead I did. I should have originally wrote it as type tags like this also. But I didn't. So it'll at least be easier to track down where it's a 32-bit number. It needs to be updated to size T. So it could be 64-bit or 32-bit. And I don't have to like physically duplicate code for a 32-bit and 64-bit. It'll just magically be whatever the size T is or whatever. So there's like a whole lot of stuff I gotta do. But I want to just get it running in 6 days. So I'm gonna I'm gonna take a second, whatever, I'll be back. I'm gonna try to check through the rest of this file and replace the rest of these keywords in the JavaScript and then in the C files. I'm gonna build the compiler. I'm gonna try to get this done in 2 hours. And if I get this done, I have to find the address arithmetic, and that's it. And that's not it. I still have to find places where it is actually a uint32. It's not supposed to be updated to size T. But I think I'll do that last. I'm gonna do all the addresses first, and then I'll find all these places where it's a 32-bit, or it's a size T because I make it size T, but it actually needs to be 32-bit. I'll find all this last. That way, I'll go through the program a whole bunch of times. I'll be able to remember where more stuff is at, what does what, and where. And I can then I can save a backup, whatever. And I know there's no 0 data truncation because I didn't pick things to be clamped to 4-byte yet. And I can save a good backup store point. And then later on, or whatever, right after that, then I can risk making things 4-byte where it needs to be 4-byte. And then if I run it later, it's something that's totally screwed up, I have a backup where everything is using the bigger type, and there's no data possible, mangled truncation or data loss, basically. I guess that's what I'm gonna do. I don't know. That makes sense. Then I can save it in a state where nothing could be broken yet because it's just expanded, and then I'll fine tune where it needs to be truncated in only those places. I mean, that sounds like the best idea so far. So I'm gonna get this done hopefully in a couple hours. Getting all these type tags in place. I have Q everywhere. I have to tag it as number or address. And then I have to come up with another tag to use for, I won't get into that. I don't know. I think I covered everything. I'm gonna stop talking for a bit and try to work. I'm gonna stop talking, whatever, so I don't know. If I'm not talking, that's what I would have been saying, whatever. I'm gonna check the rest of these in a minute. Some water. It might be possible to be done in 6 days. I lost the whole day yesterday due to like compiler issues and the text editor. But if this goes quickly and I can get the addresses, and I don't know, I might be able to make it. And then I'll make the demo and stuff.
Global environment record envrec takes no arguments and returns false. It performs the following steps when called. Return false, 1, 1, 4, 1, 0 with base object. The with base object concrete method of a global environment record envrec takes no arguments and returns undefined. It performs the following steps when called. Return undefined 9, 1, 1, 4, 1, 1 get this binding. The get this binding concrete method of a global environment record envrec takes no arguments and returns a normal completion containing an object. It performs the following steps when called. Return envrec 146. ECMA International 2024. Note: global environment records always provide this binding. Note: global environment records do not provide a super binding. 9, 1, 1, 4, 1, 2 has var declaration. N. The has var declaration concrete method of a global environment record envrec takes argument n, a string, and returns a boolean. It determines if the argument identifier has a binding in this record that was created using a variable statement or a function declaration. It performs the following steps when called. Let var declared names be envrec. If var declared names contains n, return true. Return false, 1, 1, 4, 1, 3 has lexical declaration. N. The has lexical declaration concrete method of a global environment record envrec takes argument n, a string, and returns a boolean. It determines if the argument identifier has a binding in this record that was created using a lexical declaration such as a lexical declaration or a class declaration. It performs the following steps when called. Let DCLREC be envrec. Return. DCLREC has binding. N, 1, 1, 4, 1, 4 has restricted global property. N. The has restricted global property concrete method of a global environment record envrec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if the argument identifier is the name of a property of the global object that must not be shadowed by a global lexical binding. It performs the following steps when called. Let objrec be envrec. Let global object be objrec. Let existing prop be global object. N. If existing prop is undefined, return false. If existing prop is true, return false. Return true, 1, 1, 4, 1, 5 can declare global var. N. The can declare global var concrete method of a global environment record envrec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if a corresponding create global var binding call would succeed if called for the same argument n redundant var declarations and var declarations for pre-existing global object properties are allowed. It performs the following steps when called. Let objrec be envrec. Let global object be objrec. Let has property be has own property, global object. N. If his property is true, return true. Return is extensible, global object. Note: properties may exist upon a global object that were directly created rather than being declared using a var or function declaration. A global lexical binding may not be created that has the same name as a non-configurable property of the global object. The global property undefined is an example of such a property. ECMA International 2024 147 9 1 1 4 1 6 can declare global function n. The can declare global function concrete method of a global environment record envrec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if a corresponding create global function binding call would succeed if called for the same argument, and it performs the following steps when called. Let objrec be envrec. Let global object be objrec. CT. Let existing prop be global object. N. If existing prop is undefined, return is extensible, global object. If existing prop is true, return true. If is data descriptor, existing prop is true and existing prop has attribute values. True, enumerable. True, return true, return false, 1, 1, 4, 1, 7. Create global var binding, n, d. The create global var binding concrete method of a global environment record envrec takes arguments n, a string, and e, a boolean, and returns either a normal completion containing unused or a throw completion. It creates and initializes a mutable binding in the associated object environment record and records the bound name in the associated list. If a binding already exists, it is reused and assumed to be initialized. It performs the following steps when called. Let objrec be envrec. Let global object be objrec. Let has property be has own property, global object, n. Let extensible be is extensible, global object. If his property is false and extensible is true, then a perform. Objrec create mutable binding, n, d. B perform. Objrec initialize binding, n, undefined. If envrec does not contain n, then a append n to envrec 7. Return unused, 1, 1, 4, 1, 8. Create global function binding, n, v, d. The create global function binding concrete method of a global environment record envrec takes arguments n, a string, v, an ECMAScript language value, and e, a boolean, and returns either a normal completion containing unused or a throw completion. It creates and initializes a mutable binding in the associated object environment record and records the bound name in the associated list. If a binding already exists, it is 2, 3, 4, 7, 8, replaced. It performs the following steps when called. Let objrec be envrec. Let global object be objrec. Let existing prop be global object, n. If existing prop is undefined or existing prop is true, then a let desc be the property descriptor, v, true, true, d. Else a let desc be the property descriptor, v. Perform. Define property or throw, global object, n, desc. Perform. Set, global object, n, v, false. If envrec does not contain n, then a append n to envrec. Return unused. 48. ECMA International 2024. Note: global function declarations are always represented as own properties of the global object. If possible, an existing own property is reconfigured to have a standard set of attribute values. Step 7 is equivalent to what calling the initialize binding concrete method would do, and if global object is a proxy will produce the same sequence of proxy trap calls, 1, 1. 5 module environment records. A module environment record I, S, a declarative environment record that is used to represent the outer scope of an ECMAScript module. In addition to normal mutable and immutable bindings, module environment records also provide immutable import bindings, which are bindings that provide indirect access to a target binding that exists in another environment record. Module environment records support all of the declarative environment record methods listed in Table 16 and share the same specifications for all of those methods except for get binding value, delete binding, has this binding, and get this binding. In addition, module environment records support the methods listed in Table 22. Table 22. Additional methods of module environment records. The behavior of the additional concrete specification methods for module environment records are defined by the following algorithms, 1, 1, 5, 1 get binding value, n, s. The get binding value concrete method of a module environment record envrec takes arguments n, a string, and s, a boolean, and returns either a normal completion containing an ECMAScript language value or a throw completion. It returns the value of its bound identifier whose name is n. However, if the binding is an indirect binding, the value of the target binding is returned. If the binding exists but is uninitialized, a reference error is thrown. It performs the following steps when called. Assert. S is true. Assert. envrec has a binding for n. If the binding for n is an indirect binding, then a let m and n to be the indirection values provided when this binding for n was created. B let target env be m. C if target env is empty, throw a reference error exception. D return target env get binding value. N2, true, if the binding for n and envrec is an uninitialized binding, Throw a reference error exception. Return the value currently bound to n in envrec. Note S will always be true because a module is always strict mode code 9.1.1.5. To delete binding n, the delete binding concrete method of a module environment record is never used within this specification. Method purpose: create import binding n m n2. Create an immutable indirect binding in a module environment record. The string value n is the text of the bound name. M is a module record, and n2 is a binding that exists in m's module environment record. Get this binding. Return the value of this environment records this binding. Copyright sign, ECMA International 2024 149. Note: module environment records are only used within strict code, and an early error rule prevents the delete operator in strict code from being applied to a reference record that would resolve to a module environment record binding. C135111.1.5.3 has this binding. The has this binding concrete method of a module environment record envrec takes no arguments and returns true. It performs the following steps when called: return true, 1, 1, 5. Forget this binding. The get this binding concrete method of a module environment record envrec takes no arguments and returns a normal completion containing undefined. It performs the following steps when called: return undefined, 1, 1, 5, 5. Create import binding n m n2. The create import binding concrete method of a module environment record envrec takes arguments n, a string, m, a module record, and n2, a string, and returns unused. It creates a new initialized immutable indirect binding for the name n. A binding must not already exist in this environment record, for n. n2 is the name of a binding that exists in m's module environment record. Accesses to the value of the new binding will indirectly access the bound value of the target binding. It performs the following steps when called: assert envrec does not already have a binding for n. Assert: when m is instantiated, it will have a direct binding for n2. Create an immutable indirect binding in envrec for n that references m and n2 as its target binding, and record that the binding is initialized. Return unused, 1.2 environment record operations. The following abstract operations are used in this specification to operate upon environment records. 9.1.2. 1. Get identifier reference, env, name, strict. The abstract operation get identifier reference takes arguments env, an environment record or null, name, a string, and strict, a boolean, and returns either a normal completion containing a reference record or a throw completion. It performs the following steps when called: if env is null, then a return the reference record, unresolvable, name, strict. This value, empty. Let exists be env has been.
I think I'm gonna stop. Like, I shouldn't. There's no point checking these because I need to wait to rename anything to later, like with the unsigned type. So I'm just gonna leave stuff as it is and then just make sure I get rid of all the places where it's tagged with the Q for questionable or whatever. Questionable. I don't know, that's why I use Q. I'm gonna just deal with all those, get them tagged with an N or an A or an A first, and then get the C files once everything's been tagged. Then I'll deal with the addressing or the address arithmetic. This is like a whole lot of stuff I gotta for later though. I'm not going to not get ahead of myself today and only do whatever I'm trying to do. And if, I don't know, if something breaks. It'd be really nice if it was possible. If it's possible to, like, I don't know, whatever. I need to focus. I'm gonna find some music and drink some water. My allergies are killing me. There's so many trees outside squirting pollen into the air. It's just, it's terrible. I hate trees. If I wasn't allergic to like 90% some trees, I wouldn't care. But because I'm allergic, I hate trees. Trees suck. But Visual Studio, this Microsoft compiler, this sucks way more than trees. This is terrible. This compiler. So I'm gonna focus, find some music, and stop talking, and replace all these tags. Then I'll talk some more, whatever, and I'll replace all the address arithmetic. And then it should be able to run as 64-bit. But there's a couple places where I will need to replace the type as a 4-byte type because it's not supposed to be 64-bit, and it could mess stuff up if it was expected to be 4-byte. And there's like some subtraction to cause overflow with the number, or if it's doing right shifts and it's doing like 32-bit right shift. And if it's a 64-bit number, if that top bit is not set to indicate it's a negated signed to complement, or just that it's an unsigned number, the top bit set, that top bit won't be carried during the shift operation to the right. There's no such thing as, at least in C, the standard assigned left shift. So I'm gonna have to like pick out certain bitwise arithmetic operations and it might not run as 64-bit right out of the gate. I'm gonna have to there's a whole lot of things I gotta check that aren't gonna convert straight up. I'm gonna stop thinking ahead and just do this shit. I'm trying for 6 days. That's my goal. It's already been like a week of this. I want to just get to this poopy standard so I can like these 800 pages. I just want to get that done. So I'm gonna focus and replace these tags and stuff for the types.
Realm record with the field specified in Table 24, 52, copyright sign, ECMA International 2024, Table 24, Realm record fields, field name, agent signifier, intrinsics, global object, global env, template map, an object or undefined value, an agent signifier, a record whose field names are intrinsic keys and whose values are objects, a global environment record, a list of records with fields, a template literal parse node, and v, an array, f, the agent that owns this realm, the global object for this realm, the global environment for this realm, meaning the intrinsic values used by code associated with this realm, a list of records with fields are a string and a module record. Note 1: once a parse node becomes unreachable, the corresponding is also unreachable, and it would be unobservable if an implementation removed the pair from the list. Anything default value is undefined. Note 2 as mentioned in host load imported module 16.2.1.8. Note 1. In realm records is only used when running an import expression in a context where there is no active script or module, field reserved for use by hosts that need to associate additional information with a realm record. Template objects are canonicalized separately for each realm using its realm records. Each value is a parse node that is a template literal. The associated ALU is the corresponding template object that is passed to a tag function, a map from the specifier strings imported by this realm to the solved module record. The list does not contain two different records with the same 9.3.1 create realm. The abstract operation create realm takes no arguments and returns a realm record. It performs the following steps when called. Let realm rec be a new realm record. Perform create intrinsics. Realm rec. Set realm rec to agent signifier. Set realm rec to undefined. Set realm rec to undefined. Set realm rec to a new empty list. Return realm rec. ECMA International 2024 153 9.3. 2 create intrinsics. Realm rec. The abstract operation create intrinsics takes argument realm rec, a realm record, and returns unused. It performs the following steps when called. Set realm rec to a new record. Set fields of realm rec with the values listed in table 6. The field names are the names listed in column 1 of the table. The value of each field is a new object value fully and recursively populated with property values as defined by the specification of each object in clauses 19 through 28. All object property values are newly created object values. All values that are built-in function objects are created by performing create built-in function steps, length, name, slots, realm rec, prototype, where steps is the definition of that function provided by this specification. Name is the initial value of the function's name property. Length is the initial value of the function's length property. Slots is a list of the names, if any, of the function's specified internal slots. And prototype is the specified value of the function's internal slot. The creation of the intrinsics and their properties must be ordered to avoid any dependencies upon objects that have not yet been created. Perform capital A, D, D, capital R, E, S, T, R, I, C, T, E, D, capital F, U, N, C, T, I, O, N, capital P, R, O, P, E, R, T, I, E, realm rec, return unused, 3.3 set realm global object, realm rec, global obj, this value. The abstract operation set realm global object takes arguments realm rec, a realm record, global obj, an object or undefined, and this value, an object or undefined, and returns unused. It performs the following steps when called. If global obj is undefined, then a let intrinsics be realm rec, be set global obj to ordinary object create intrinsics. Assert global obj is an object. If this value is undefined, set this value to global obj. Set realm rec to global obj. Let new global env be new global environment. Global obj, this value. Set realm rec to new global env. Return unused, 3.4 set default global bindings. Realm rec. The abstract operation set default global bindings takes argument realm rec, a realm record, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Let global be realm rec for each property of the global object specified in clause 19. Do a let name be the string value of the property name. B let desk be the fully populated data property descriptor for the property, containing the specified attributes for the property. For properties listed in 19.2, 19.3, or 19.4, the value of the attribute is the corresponding intrinsic object from realm rec. See perform. Define property auth row global name desk return global. Point 4 execution contexts. An execution context is a specification device that is used to track the runtime evaluation of code by an ECMAScript implementation. At any point in time, there is at most one execution context per agent that is actually executing code. This is known as the agent's running execution context. All references to the running execution context in this specification denote the running execution context of the surrounding agent. The execution context stack is used to track execution contexts. The running execution context is always the top element of this stack. A new execution context is created whenever control is transferred from the executable code associated with the currently running execution context to an executable code that is not associated with that. 54. Copyright sign, ECMA International 2024. Execution context. The newly created execution context is pushed onto the stack and becomes the running execution context. An execution context contains whatever implementation-specific state is necessary to track the execution progress of its associated code. Each execution context has at least the state components listed in Table 25. Table 25. State components for all execution contexts. Component. Purpose. Code evaluation state. Any state needed to perform, suspend, and resume evaluation of the code associated with this execution context. Function. If this execution context is evaluating the code of a function object, then the value of this component is that function object. If the context is evaluating the code of a script or module, the value is null. Realm. The realm record from which associated code accesses ECMAScript resources. Script or module. The module record or script record from which associated code originates. If there is no originating script or module, as is the case for the original execution context created in initialize host-defined realm, the value is null. Evaluation of code by the running execution context may be suspended at various points defined within this specification. Once the running execution context has been suspended, a different execution context may become the running execution context and commence evaluating its code. At some later time, a suspended execution context may again become the running execution context and continue evaluating its code at the point where it had previously been suspended. Transition of the running execution context status among execution contexts usually occurs in stack-like last-in first-out manner. However, some ECMAScript features require non-LFO transitions of the running execution context. The value of the realm component of the running execution context is also called the current realm record. The value of the function component of the running execution context is also called the active function object. ECMAScript code execution contexts have the additional state components listed in Table 26. Table 26. Additional state components for ECMAScript code execution contexts. Component. Purpose. Lexical environment. Identifies the environment record used to resolve identifier references made by code within this execution context. Variable environment. Identifies the environment record that holds bindings created by variable statements within this execution context. Private environment. Identifies the private environment record that holds private names created by class elements and the nearest containing class null if there is no containing class. The lexical environment and variable environment components of an execution context are always environment records. Execution contexts representing the evaluation of generators have the additional state components listed in Table 27. ECMA International 2024 155. Table 27. Additional state components for generator execution contexts. In most situations, only the running execution context, the top of the execution context stack, is directly manipulated by algorithms within this specification. Hence, when the terms lexical environment and variable environment are used without qualification, they are in reference to those components of the running execution context. An execution context is purely a specification mechanism and need not correspond to any particular artifact of an ECMAScript implementation. It is impossible for ECMAScript code to directly access or observe an execution context. 4.1 Get active script or module. The abstract operation get active script or module takes no arguments and returns a script record, a module record, or null. It is used to determine the running script or module based on the running execution context. It performs the following steps when called. If the execution context stack is empty, return null. Let X be the topmost execution context on the execution context stack whose script or module component is not null. If no such execution context exists, return null. Otherwise, return X script or module, 4.2 resolve binding. Name, env. The abstract operation resolve binding takes argument name, a string, and optional argument env, an environment record or undefined, and returns either a normal completion containing a reference record or a throw completion. It is used to determine the binding of name. Env can be used to explicitly provide the environment record that is to be searched for the binding. It performs the following steps when called. If env is not present or env is undefined, then a set env to the running execution context's lexical environment. Assert env is an environment record if the source text matched by the syntactic production that is being evaluated is contained in strict mode. Code. Let strict be true, else let strict be false. Return. Get identifier reference, env, name, strict, 4.3 get this environment. The abstract.
I want to like do one single thing and get it done with. But like every time I want to do one thing, there's some other thing that has to be done too. And if I put it into a to-do list, it'll never get done. I'm gonna forget to read it. And if I do it now, then I'm gonna do it now. Then I gotta get like back to what I was doing. So I gotta like, I have to put the define guard check at the top of the output JavaScript files for a couple files, whatever. I don't know. I just want to like find and replace some stuff. And now I'm like doing this. I'm probably gonna find like something else I have to like account for so I don't forget to do later. So at some point, possibly in the next couple hours, I don't know if the mic's too loud. I don't know. Eventually, hopefully, I'll get all the keywords placed today in a couple hours so I can like get to the address arithmetic. But there's a couple like cleanup things, whatever, I have to like account for, so I don't forget to do it later and stuff.
It performs the following steps when called. 2.5. Let current realm be the current realm record. Return current realm, jobs and host operations to enqueue jobs. A job is an abstract closure with no parameters that initiates an ECMAScript computation when no other ECMAScript computation is currently in progress. Jobs are scheduled for execution by ECMAScript host environments in a particular agent. This specification describes the host hook's host enqueue generic job. Capital H O S T capital E N Q U E U E capital F I N A L I Z A T I O N capital R E G I S T R host enqueue promise job and host enqueue timeout job to schedule jobs. The host hooks in this specification are organized by the additional constraints imposed on the scheduling of jobs. Hosts may define additional abstract operations which schedule jobs. Such operations accept a job abstract closure and a realm record or null, as parameters. If a realm record is provided, these operations schedule the job to be performed at some future time in the provided realm, in the agent that owns the realm. If null is provided instead for the realm, then the job does not evaluate ECMAScript code. Their implementations must conform to the following requirements. At some future point in time, when there is no running context in the agent for which the job is scheduled and that agent's execution context stack is empty, the implementation must perform any host-defined preparation steps, invoke the job abstract closure, perform any host-defined cleanup steps, after which the execution context stack must be empty. Only one job may be actively undergoing evaluation at any point in time in an agent. Once evaluation of a job starts, it must run to completion before evaluation of any other job starts in an agent. The abstract closure must return a normal completion, implementing its own handling of errors. ECMA International 2024 157. Note 1. Host environments are not required to treat jobs uniformly with respect to scheduling. For example, web browsers and Node.js treat promise handling jobs as a higher priority than other work. Future features may add jobs that are not treated at such a high priority. At any particular time, script or module, a script record, a module record, or null, is the active script or module if all of the following conditions are true. Get active script or module is script or module. If script or module is a script record or module record, let EC be the topmost execution context on the execution context stack whose script or module component is script or module. The realm component of EC is script or module. At any particular time, an execution is prepared to evaluate ECMAScript code if all of the following conditions are true. The execution context stack is not empty. The realm component of the topmost execution context on the execution context stack is a realm record. Particular kinds of jobs have additional conformance requirements. 5.1 Job callback records. A job callback record is a record value used to store a function object and a host-defined value. Function objects that are invoked via a job encoded by the host may have additional host-defined context. To propagate the state, job abstract closures should not capture and call function objects directly. Instead, use host make job callback and host call job callback. Job callback records have the fields listed in Table 28. Table 28. Job callback record fields. 5.2 Host make job callback. Callback, the host-defined abstract operation host make job callback takes argument callback, a function object, and returns a job callback record. An implementation of host make job callback must conform to the following requirements. It must return a job callback record whose field is callback. Note 2 Host environments may prepare an execution to evaluate code by pushing execution contexts onto the execution context stack. The specific steps are implementation defined. The specific choice of realm is up to the host environment. This initial execution context and realm is only in use before any callback function is invoked. When a callback function related to a job, like a promise handler, is invoked, the invocation pushes its own execution context and realm. Note the WHATWG specification, https://html.spec.whatwg.org/ For example, uses the host-defined value to propagate the incumbent settings object for promise callbacks. Field name value meaning callback, a function object, the function to invoke when the job is invoked. Host-defined, anything default value is empty. Field reserved for use by hosts. 158. ECMA International 2024. The default implementation of host make job callback performs the following steps when called. 1. Return the job callback record. Callback empty. ECMAScript hosts that are not web browsers must use the default implementation of host make job callback. 5.3 Host call job callback. Job callback v arguments list. The host-defined abstract operation host call job callback takes arguments job callback, a job callback record, v, an ECMAScript language value, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or a throw completion. An implementation of host call job callback must conform to the following requirements. It must perform and return the result of call. Job callback v arguments list. The default implementation of host call job callback performs the following steps when called. Assert is callable. Job callback is true. Return call job callback v arguments list. ECMAScript hosts that are not web browsers must use the default implementation of host call job callback. 5.4 Host enqueue generic job realm. The host-defined abstract operation host enqueue generic job takes arguments job, a job abstract closure, and realm, a realm record, and returns unused. It schedules job in the realm in the agent signified by realm to be performed at some future time. The abstract closures used with this algorithm are intended to be scheduled without additional constraints, such as priority and ordering. An implementation of host enq generic job must conform to the requirements in 9.5 host enq promise job realm. The host-defined abstract operation host enq promise job takes arguments job, a job abstract closure, and realm, a realm record or null, and returns unused. It schedules job to be performed at some future time. The abstract closures used with this algorithm are intended to be related to the handling of promises, or otherwise, to be scheduled with equal priority to promise handling operations. An implementation of host enq promise job must conform to the requirements in 9.5 as well as the following. If realm is not null, each time job is invoked, the implementation must perform implementation-defined steps such that execution is prepared to evaluate ECMAScript code at the time of job's invocation. Let script or module be get active script or module at the time host enq promise job is invoked. If realm is not null, each time job is invoked, the implementation must perform implementation-defined steps such that script or module is the active script or module at the time of job's invocation. Jobs must run in the same order as the host enq promise job invocations that scheduled them. Note this is called at the time that the callback is passed to the function that is responsible for its being eventually scheduled and run. For example, promise then action, calls make job callback on then action at the time of invoking promise prototype then, not at the time of scheduling the reaction job. Note this requirement means that hosts cannot change the behavior of function objects defined in this specification. ECMA International 2024 159. Note the realm for jobs returned by new promise resolved thenable job is usually the result of calling get function realm on the then function object. The realm for jobs returned by new promise reaction job is usually the result of calling get function realm on the handler if the handler is not undefined. If the handler is undefined, realm is null. For both kinds of jobs, when get function realm completes abnormally, that is called on a revoked proxy, realm is the current realm record at the time of the get function realm call. When the realm is null, no user ECMAScript code will be evaluated and no new ECMAScript objects, for example, error objects, will be created. The WHATWG-HTML specification, https://html.spec.whatwg.org/ for example, uses realm to check for the ability to run script and for the entry, https://html.spec.whatwg.org/#entry concept, 5.6 host enq timeout job, realm, milliseconds. The host-defined abstract operation host enq timeout job takes arguments timeout job, a job abstract closure, realm, a realm record, and milliseconds, a non-negative finite number, and returns unused. It schedules timeout job in the realm in the agent signified by realm to be performed after at least milliseconds. An implementation of host enq timeout job must conform to the requirements in 9.5, 9.6 initialize host-defined realm. The abstract operation initialize host-defined realm takes no arguments and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. Let realm be create realm. Let new context be a new execution context. Set the function of new context to null. Set the realm of new context to realm. Set the script or module of new context to null. Push new context onto the execution context stack. New context is now the running execution context. If the host requires use of an exotic object to serve as realm's global object, let global be such an object created in a host-defined manner. Otherwise, let global be undefined, indicating that an ordinary object should be created as the global object. If the host requires that this binding in realm's global scope return an object other than the global object, let this value be such an object created in a host-defined manner. Otherwise, let this value be undefined, indicating that realm's global this binding should be the global object. Perform set realm global object, realm, global. This value 0. Let global obj be Set default global bindings. Realm 1. Create any host-defined global object properties on global obj. 2. Return unused. Point 7 agents. An agent comprises a set of ECMAScript execution contexts, an execution context stack, a running execution context, an agent record, and an executing thread. Except for the executing thread, the constituents of an agent belong exclusively to that the agent. An agent's executing thread executes algorithmic steps on the agent's execution contexts independently of other agents, except that an executing thread may be used as the executing thread by multiple agents, provided none of the agents sharing the thread have an agent record whose field is true. Note 1. Some web browsers share a single executing thread across multiple unrelated tabs of a browser window. For example, 60. Copyright sign, ECMA International 2024. While an agent's executing thread is executing algorithmic steps, the agent is the surrounding agent for those steps. The steps use the surrounding agent to access the specification level execution objects held within the agent, the running execution context, the execution context stack, and the agent records fields. An agent signifier is a globally unique opaque value used to identify an agent. Table 29. Agent record fields. Field name, value, meaning, little endian, a boolean. The default value computed for the is little endian parameter when it is needed by the algorithm's get value from buffer and set value in buffer. The choice is implementation defined and should be the alternative that is most efficient for the implementation. Once the value has been observed, it cannot change. Can block. A boolean determines whether the agent can block or not. Signifier. An agent signifier uniquely identifies the agent within its agent cluster. Is lock-free 1. A boolean, true if atomic operations on 1 byte values are lock-free. False otherwise. Is lock-free 2. A boolean, true if atomic operations on 2 byte values are lock-free. False otherwise. Is lock-free 8. A boolean, true if atomic operations on 8-byte values are lock-free. False otherwise. Candidate execution. A. Candidate execution record. See the memory model. Kept alive. A list of either objects or symbols. Initially a new empty list, representing the list of objects and or symbols to be kept alive until the end of the current job. Once the values of and have been observed by any agent in the agent cluster, they cannot change. Note 2. The values of and are not necessarily determined by the hardware, but may also reflect implementation choices that can vary over time and between ECMAScript implementations. There is no field. 4-byte atomic operations are always log-free. In practice, if an atomic operation is implemented with any type of lock, the operation is not lock-free. Lock-free does not imply wait-free. There is no upper bound on how many machine steps may be required to complete a lock-free atomic operation. That an atomic access of size n is lock-free does not imply anything about the perceived atomicity of non-atomic accesses of size n. Specifically, non-atomic accesses may still be performed as a sequence of several separate memory accesses. See Read Shared Memory and Write Shared Memory for details. ECMA International 2024 161. 9. 7. One agent signifier. The abstract operation agent signifier takes no arguments and returns an agent signifier. It performs the following steps when called. Let AR be the agent record of the surrounding agent. Return AR, 7.2 agent can suspend. The abstract operation agent can suspend takes no arguments and returns a boolean. It performs the following steps when called. 2.8 Let AR be the agent record of the surrounding agent. Return AR agent clusters. Note, in some environments it may not be reasonable for a given agent to suspend. For example, in a web browser environment, it may be reasonable to disallow suspending a document's main event handling thread, while still allowing workers' event handling threads to suspend. An agent cluster is a maximal set of agents that can communicate by operating on shared memory. Every agent belongs to exactly one agent cluster. All agents within a cluster must have the same value for the field in their respective agent records. All agents within a cluster must have the same values for the field in their respective agent records. Similarly for the field, all agents within a cluster must have different values for the field in their respective agent records. An embedding may deactivate, stop forward progress, or activate, resume forward progress, an agent without the agent's knowledge or cooperation. If the embedding does so, it must not leave some agents in the cluster active while other agents in the cluster are deactivated indefinitely. Note 1. Programs within different agents may share memory by unspecified means. At a minimum, the backing memory for shared array buffers can be shared among the agents in the cluster. There may be agents that can communicate by message passing that cannot share memory. They are never in the same agent cluster. Note 2. The agents in a cluster need not all be alive at some particular point in time. If agent A creates another agent B, after which A terminates and B creates agent C, the three agents are in the same cluster if A could share some memory with B and B could share some memory with C. Note 3. If different agents within an agent cluster have different values of it becomes hard to use shared memory for multi-byte data. 62. Copyright sign, ECMA International 2024. Note 4. The purpose of the preceding restriction is to avoid a situation where an agent deadlocks or starves because another agent has been deactivated. For example, if an HTML shared worker that has a lifetime independent of documents in any windows were allowed to share memory with the dedicated worker of such an independent document, and the document and its dedicated worker were to be deactivated while the dedicated worker holds a lock, say, the document is pushed into its Windows history, and the shared worker then tries to acquire the lock, then the shared worker will be blocked until the dedicated worker is activated again, if ever. Meanwhile, other workers trying to access the shared worker from other windows will starve. The implication of the restriction is that it will not be possible to share memory between agents that don't belong to the same suspend wake collective within the embedding. An embedding may terminate an agent without any of the agent's cluster's other agents' prior knowledge or cooperation. If an agent is terminated not by programmatic action of its own or of another agent in the cluster but by forces external to the cluster, then the embedding must choose one of two strategies: either terminate all the agents in the cluster, or provide reliable APIs that allow the agents in the cluster to coordinate so that at least one remaining member of the cluster will be able to detect the termination, with the termination data containing enough information to identify the agent that was terminated. Each of the following specification values, and values transitively reachable from them, belong to exactly one agent cluster. Candidate execution record, shared data block, waitlist record. Prior to any evaluation of any ECMAScript code by any agent in a cluster, the field of the agent record for all agents in the cluster is set to the initial candidate execution. The initial candidate execution is an empty candidate execution whose field is a list containing, for each agent, an agent events record whose field is that agent's agent signifier, and whose fields are empty lists. Note 5 examples of that type of termination are operating systems or users terminating agents that are running in separate processes, the embedding itself terminating an agent that is running in process with the other agents when per agent resource accounting indicates that the agent is runaway. Note 6 all agents in an agent cluster share the same candidate execution in its agent records field. The candidate execution is a specification mechanism used by the memory model. Note 7 an agent cluster is a specification mechanism and need not correspond to any particular artifact of an ECMAScript implementation. Point 9 forward progress. For an agent to make forward progress is for it to perform an evaluation step according to this specification. An agent becomes blocked when its running execution context waits synchronously and indefinitely for an external event. Only agents whose agent records field is true can become blocked in this sense. An unblocked agent is one that is not blocked. Implementations must ensure that every unblocked agent with a dedicated executing thread eventually makes forward progress. In a set of agents that share an executing thread, one agent eventually makes forward progress. ECMA International 2024 163, an agent does not cause another agent to become BL opt except via explicit APIs that provide blocking. 0.10 Processing model of weak ref and finalization registry targets 9.10. 1 Objectives. This specification does not make any guarantees that any object or symbol will be garbage collected. Objects or symbols which are not live may be released after long periods of time, or never at all. For this reason, this specification uses the term may when describing behavior triggered by garbage collection. The semantics of weak refs and finalization registries is based on two operations which happen at particular points in time. When weak ref prototype deriv is called, the referent, if undefined is not returned, is kept alive so that subsequent synchronous accesses also return the same value. This list is reset when synchronous work is done using the clear-kept objects abstract operation. When an object or symbol which is registered with the finalization registry becomes unreachable, a call of the finalization registry's cleanup callback may eventually be made after synchronous ECMAScript execution completes. The finalization registry cleanup is performed with the cleanup finalization registry abstract operation. Neither of these actions, clear-kept objects or cleanup finalization registry, may interrupt synchronous ECMAScript execution. Because hosts may assemble longer, synchronous ECMAScript execution runs, the specification defers the scheduling of clear-kept objects and cleanup finalization registry to the host environment. Some ECMAScript implementations include garbage collector implementations which run in the background, including when ECMAScript is idle. Letting the host environment schedule cleanup finalization registry allows it to resume ECMAScript execution in order to run finalizer work, which may free up held values, reducing overall memory usage. 10.2 Liveness. For some set of objects and or symbols S a hypothetical weak ref oblivious execution with respect to S is an execution whereby the abstract operation weak ref deriv of a weak ref whose referent is an element of S always returns undefined. This, along with the liveness guarantee in the memory model, ensures that all sexcst writes note eventually become observable to all agents. Note 1 weak ref obliviousness, together with liveness, capture two notions. 1. That a weak ref itself does not keep its referent alive. 2. That cycles in liveness does not imply that a value is live. To be concrete, if determining V's liveness depends on determining the liveness of a weak ref referent, R's liveness cannot assume V's liveness, which would be circular reasoning. Note 2 weak ref obliviousness is defined on sets of objects or symbols instead of individual values to account for cycles. If it were defined on individual values, then a weak ref referent in a cycle will be considered live even though its identity is only observed via other weak ref referents in the cycle. Note 3 colloquially, we say that an individual object or symbol is live if every set containing it is live. At any point during evaluation, a set of objects and or symbols S is considered live if either of the following conditions is met. Any element in S is included in any agents list 164. ECMA International 2024, there exists a valid future hypothetical weak ref oblivious execution with respect to S that observes the identity of any value in S. Note 4 the second condition above intends to capture the intuition that a value is live if its identity is observable via non-weak ref means. A value's identity may be observed by observing a strict equality comparison or observing the value being used as key in a map. Note 5. Presence of an object or a symbol in a field, an internal slot, or a property does not imply that the value is live. For example, if the value in question is never passed back to the program, then it cannot be observed. This is the case for keys in a weak map, members of a weak set, as well as the infields of a finalization registry cell record. The above definition implies that, if a key in a weak map is not live, then its corresponding value is not necessarily live either. Note 6. Liveness is the lower bound for guaranteeing which weak refs engines must not empty. Liveness is defined here as undecidable. In practice, engines use conservative approximations such as reachability. There is expected to be significant implementation leeway. 10.3 Execution. At any time, if a set of objects and/or symbols S is not live, an ECMAScript implementation may perform the following steps atomically. For each element value of S, do a for each weak ref such that ref is value. Do I set ref to empty. B for each finalization registry FG such that FG contains a record cell such that cell is value. Do I set cell to empty. 2. Optionally, perform capital H O S T capital E N Q U E U E capital F I N A L I Z A T I O N capital R E G I S T R F G. C for each weak map such that map contains a record R such that R value. Do I set R to set R to empty. D for each weak set such that set contains value. Do I replace the element of set whose value is value with an element whose value is empty. ECMA International 2024 165. Note 1. Together with the definition of liveness, this clause prescribes optimizations that an implementation may apply regarding weak refs. It is possible to access an object without observing its identity. Optimizations such as dead variable elimination and scalar replacement on properties of non-escaping objects whose identity is not observed are allowed. These optimizations are thus allowed to observably empty weak refs that point to such objects. On the other hand, if an object's identity is observable, and that object is in the internal slot of a weak ref, optimizations such as rematerialization that observably empty the weak ref are prohibited, because calling capital H O S T capital E N Q U E U E capital F I N A L I Z A T I O N capital R E G I S T R is optional. Registered objects in a finalization registry do not necessarily hold that finalization registry live. Implementations may omit finalization registry callbacks for any reason. For example, if the finalization registry itself becomes dead, or if the application is shutting down. Note 2. Implementations are not obligated to empty weak refs for maximal sets of non-live objects or symbols. If an implementation chooses a non-live set S in which to empty weak refs, this definition requires that it empties weak refs for all values in S simultaneously. In other words, it is not conformant for an implementation to empty a weak ref pointing to a value v without emptying out other weak refs that, if not emptied, could result in an execution that observes the value of v, 10.4 host hooks, 1041, capital H O S T capital E N Q U E U E capital F I N A L I Z A T I O N capital R E G I S T R. Finalization registry, the host-defined abstract operation, capital H O S T capital E N Q U E U E capital F I N A L I Z A T I O N capital R E G I S T R takes argument finalization registry, a finalization registry, and returns unused. Let cleanup job be a new job abstract closure with no parameters that captures finalization registry and performs the following steps when called. Let cleanup result be completion, cleanup finalization registry, Finalization registry. If cleanup result is an abrupt completion, perform any host-defined steps for reporting the error. Return unused. An implementation of capital H O S T capital E N Q U E U E capital F I N A L I Z A T I O N capital R E G I S T R schedules cleanup job to be performed at some future time, if possible. It must also conform to the requirements in 9.5.11 clear-kept objects. The abstract operation clear-kept objects takes no arguments and returns unused. ECMAScript implementations are expected to call clear-kept objects when a synchronous sequence of ECMAScript executions completes. It performs the following steps when called. Let agent record be the surrounding agent's agent record. Set agent record to a new empty list. Return unused. 66. ECMA International 2024. 9.12. Add to kept objects. Value. The abstract operation add to kept objects takes argument value, an object or a symbol, and returns unused. It performs the following steps when called. Let agent record be the surrounding agent's agent record. Append value to agent record. Return unused. 0.13 Cleanup finalization registry. Finalization registry. The abstract operation cleanup finalization registry takes argument finalization registry, a finalization registry, and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. Assert. Finalization registry hasn't internal slots. Let callback be finalization registry. While finalization registry contains a record cell such that cell kref target is empty, an implementation may perform the following steps. A choose any such cell. B remove cell from finalization registry. C perform. Host call job callback. Callback. Undefined. Cell. Return unused. 0.14 can be held weakly. V. The abstract operation can be held weakly takes argument V, an ECMAScript language value, and returns a boolean. It returns true if and only if V is suitable for use as a weak reference. Only values that are suitable for use as a weak reference may be a key of a weak map, an element of a weak set, the target of a weak ref, or one of the targets of a finalization registry. It performs the following steps when called. If V is an object, return true. If V is a symbol and key for symbol, V is undefined, return true. Return false. Note when the abstract operation add to kept objects is called with a target, object, or symbol, it adds the target to a list that will point strongly at the target until clear kept objects is called. Note a language value without language identity can be manifested without prior reference and is unsuitable for use as a weak reference. A symbol value produced by symbol 4, unlike other symbol values, does not have language identity and is unsuitable for use as a weak reference. Well-known symbols are likely to never be collected, but are nonetheless treated as suitable for use as a weak reference because they are limited in number and therefore manageable by a variety of implementation approaches. However, any value associated to a well-known symbol in a live weak map is unlikely to be collected and could leak memory resources and implementations. 0. Ordinary and exotic objects behaviors. 0.1 Ordinary object internal methods and internal slots. All ordinary objects have an internal slot called. The value of this internal slot is either null or an object and is used for implementing inheritance. Assume a property named P is missing from an ordinary object O but exists on its object. If P refers to a data property on the object, O inherits it for get access, making it behave as if P was a property of O if P refers to a writable data property on the ECMA International 2024 167 object. Set access of P on O creates a new data property named P on O if P refers to a non-writable data property on the object. Set access of P on O fails. If P refers to an accessor property on the object, the accessor is inherited by O for both get access and set access. Every ordinary object has a Boolean valued internal slot which is used to fulfill the extensibility related internal method invariants specified in 6.1.7.3. Namely, once the value of an object's internal slot has been set to false, It is no longer possible to add properties to the object, to modify the value of the object's internal slot, or to subsequently change the value of to true. In the following algorithm descriptions, assume O is an ordinary object, P is a property key value, V is any ECMAScript language value, and ESC is a property descriptor record. Each ordinary object internal method delegates to a similarly named abstract operation. If such an abstract operation depends on another internal method, then the internal method is invoked on O rather than calling the similarly named abstract operation directly. These semantics ensure that exotic objects have their overridden internal methods invoked when ordinary object internal methods are applied to them. 0, 1, 1. The internal method of an ordinary object O takes no arguments and returns a normal completion containing either an object or null. It performs the following steps when called. Return ordinary get prototype of O10, 1, 1. 1 ordinary get prototype of O. The abstract operation ordinary get prototype of takes argument O, an object, and returns an object or null. It performs the following steps when called. Return O10, 1, 2. V. The internal method of an ordinary object O takes argument V, an object or null, and returns a normal completion containing a boolean. It performs the following steps when called. Return ordinary set prototype of O, V10, 1, 2. 1 ordinary set prototype of O, V. The abstract operation ordinary set prototype of takes arguments O, an object, and V, an object or null, and returns a boolean. It performs the following steps when called. Let current be O if same value, V, current, is true. Return true. Let extensible be O if extensible is false. Return false. Let bev. Let done be false. Repeat. While done is false. If P is null, then I set done to true. B else if same value, P, O, is true, then I return false. C else. I if P is not the ordinary object internal method defined in 10, 1, 1. Set done to true. 2. Else. Set P to P, set O to V, return true. 68. ECMA International 2024. Note the loop in step 7 guarantees that there will be no circularities in any prototype chain that only includes objects that use the ordinary object definitions for and 0, 1, 3. The internal method of an ordinary object O takes no arguments and returns a normal completion containing a boolean. It performs the following steps when called. Return ordinary is extensible. O10, 1, 3. 1 ordinary is extensible. O. The abstract operation ordinary is extensible takes argument O, an object, and returns a boolean. It performs the following steps when called. Return O10, 1, 4. The internal method of an ordinary object O takes no arguments and returns a normal completion containing true. It performs the following steps when called. Return ordinary prevent extensions. O10, 1, 4. 1 ordinary prevent extensions. O. The abstract operation ordinary prevent extensions takes argument O, an object, and returns true. It performs the following steps when called. Set O to false. Return true. 0, 1, 5. P. The internal method of an ordinary object O takes argument P, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. Return ordinary get own property. O. P10, 1, 5. 1 ordinary get own property. O. P. The abstract operation ordinary get own property takes arguments O, an object, and P, a property key, and returns a property descriptor or undefined. It performs the following steps when called. If O does not have a known property with key P, return undefined. Let D be a newly created property descriptor with no fields. Let X be O's own property whose key is P. If X is a data property, then A set D to the value of X's attribute. B set D to the value of X's attribute. Else A assert X is an accessor property. B set D attribute. C set D attribute. ECMA International 2024 169. 6. Set D to the value of X's attribute. Set D to the value of X's attribute. Return D 0, 1, 6. P desk The internal method of an ordinary object O takes arguments P, a property key, and desc, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Return ordinary define own property O P desc 1016 ordinary define own property O P desc. The abstract operation ordinary define own property takes arguments O, an object, P, a property key, and desc, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let current be O P let extensible be is extensible O return capital V A L I D A T E capital A N D capital A P P L Y capital P R O P E R T Y capital D E S C R I O P extensible desc current 0 1 6 2 is compatible property descriptor extensible desc current. The abstract operation is compatible property descriptor takes arguments extensible, a boolean, desc, a property descriptor, and current, a property descriptor or undefined, and returns a boolean. It performs the following steps when called. Return capital V A L I D A T E capital A N D capital A P P L Y capital P R O P E R T Y capital D E S C R I undefined extensible desc current 1016 capital V A L I D A T E capital A N D capital A P P L Y capital P R O P E R T Y capital D E S C R I O P extensible desc current. The abstract operation capital V A L I D A T E capital A N D capital A P P L Y capital P R O P E R T Y capital D E S C R I takes arguments O, an object or undefined, P, a property key, extensible, a boolean, desc, a PR, property descriptor, and current, a property descriptor or undefined, and returns a boolean. It returns true if and only if desc can be applied as the property of an object with specified extensibility and current property current while upholding invariance. When such application is possible and O is not undefined, it is performed for the property named P, which is created if necessary. It performs the following steps when called. Assert is property key, P, is true if current is undefined. Then, if extensible is false, return false. B if O is undefined, return true. C if is accessor descriptor, desc, is true. Then, I create an own accessor property named P of object O whose and attributes are set to the value of the corresponding field in desc if desc has that field, or to the attribute's default value otherwise. Else, I create a known data property named P of object O whose and configurable attributes are set to the value of the corresponding field in desc if desc has that field, or to the attribute's default value, otherwise you return true. Assert current is a fully populated property descriptor. If desc does not have any fields, return true. If current is false, then 70. ECMA International 2024. ABC. If desc has a field and desc is true, return false. If desc has an field and desc is not current, return false. If is generic descriptor, desk, is false and is accessor descriptor, desk, is not is accessor descriptor. Current. Then, if desk has a current 2. Desk has a current else.
I'm gonna need to add const types to my JavaScript engine. And that's gonna be it's gonna be a pain. I thought this would be like fun
with an access
to like pick an old project or whatever and like sell it. This isn't fun though, and it's not gonna be as easy as I thought it would be. So I'm gonna like try to pretend that it is gonna be easy, and this is lots of fun. Because it's slowly starting to sink in how much work it's gonna be to like finish this stuff. I don't know, I was kind of like trying to like avoid work. I'm like, this will be easy, but it's not going to be that easy. So I'm gonna keep like replacing keywords. I have to like add a define guard header check to the output files and check a couple other things that I changed in the C files that need to reflect in the generated JavaScript files.
Completion.
So I'm trying to do that right now, and then I'm gonna get back to the drink some water and then get back to replacing the types. If I can like get started on working with replacing or updating the address arithmetic, that would be like that'd be awesome. That's what my goal is. If I don't make it to that point, tomorrow will be like 5 days. If that's day 6, I don't know. If I don't get to that point, I don't think I'll be able to get this done in the next 5 days. It might take a couple more days to do. I should look up OpenGL or not OpenGL. I think it's OpenGL, the graphics library, or DirectX 11, or what is it, Vulkan? I don't know, for mobile 3D rendering or whatever. I think I'm gonna like get these define guard headers and define guard headers in these JavaScript files that make the output, check the output. I'm gonna replace stuff first too then. So after I get the types replaced, after all that, I'm gonna try to do that. I'm gonna just focus and do that. But then I'll try to get Chatbot to like output something useful to make like we'll figure out whatever to use for rendering graphics. I think I'll just go with the browser for making a little game demo. And I'll have like, I could pull up some stuff, projects, whatever, but they're not going to, they're in C#. C# is like horrible. Anyways, I'm gonna have Chatbot make something so I don't waste time trying to find something and then use it. And I'll have Chatbot make like a square or a cube that moves around on a map. And I'll have Chatbot like make like a controller script or whatever to like get the input from the keyboard and mouse to like move around a little thing. And I'll have Chatbot make some kind of like simple animation where that box or whatever will like lerp from point A to B over a period of time, maybe like a couple different positions, and then I'll have the JavaScript run and then render frame, run, render frame between frames, and then I can like increase the workload of whatever has to be computed using JavaScript in JavaScript to see how it affects the frame rate and see if the browser JavaScript can do more work between frames before it's noticeable that the frames aren't keeping up or it's getting laggy. If the browser is faster than my JavaScript engine, like which one can compute more between frames and stuff. So I'll look that up after I get this stuff done, but before I do the addressing. That way I can start getting ahead on things without actually getting ahead and getting distracted. And yeah, so I'm gonna try to like get these define grid checks, output, finish replacing, then I'll look up, have Chatbot, if it is even gonna save me some time. I hope it'll save me time. I'll have Chatbot output some stuff to use, and then I won't make the demo yet. I'll just like open stuff up, see if it runs, and then I'll like save that to a folder somewhere, back it up, and then I'll do the addressing, arithmetic and stuff, and then after I get all the addresses done, I can get a little demo running or whatever. And then I can also work on that, making a little demo like between, like I can like work on some addresses, address arithmetic, work on the demo, back and forth, whatever. There's I have to make like the JavaScript engine, the JavaScript itself that's passed in. C# does this thing for like it like marshals data, whatever. That's like really stupid, but it's not totally stupid because it kind of separates the program from the data, because you have to pass in the data and that has to be copied, and then what's it called, there's I think it's like observer, object, model or object, subject, something like that. Subject, observer, model. I don't know, there's different like data model types, strategies that people use, whatever. I can't remember what the name is. Or object, observer, I don't know. But that way, like, the subject is like the JavaScript engine, and then the observer, but not really. I'll call it A and B. A is like the external program, and then B is like the JavaScript engine. If the data is marshaled in, then A will set data to pass in, and then B will collect the data and pass it back out, either through what was passed in or like to somewhere else, and then A can specify where the output will go, or pass in what will be assigned to what's passed out. But it'd be better to, okay, basically I want to like separate stuff, so like the internal address of something isn't accessible by the outside program that's passing stuff in. I don't want to pass stuff out that exposes the internals of the engine, because then especially if it's threaded, stuff will break. So I want to like isolate the JavaScript engine from all the programs that like interact with it, and marshalling data kind of makes sense in that case, where it makes copies of the data without using yeah, whatever. So I need to write, basically, I just spent a long time explaining, but I have to write that like interface or whatever to do that stuff. But I can't really start on that now, so I'm gonna wait. And once I get going to the standard, I can do that on the side. Like go back and forth. I have like an actual to-do list of like different things I need. I'm gonna have to like toggle back and forth between different things, so like they all get done at the same time, but some things are done before where other things are needed. But right now I just need to get it running, but I do need that demo now, so I'm gonna try to like do both or whatever, and then later on when I get to the standard or whatever, I'll have a whole bunch of other stuff to do, but then at least I'll have a demo before I do all that other stuff. So I don't know, I'm gonna get back to like getting these define guard headers in the output file, and then replacing all the type names and stuff.
Internal slots of ECMAScript function objects. Internal slot. Type. Description. Environment. An environment record. The environment record that the function was closed over. Used as the outer environment when evaluating the code of the function. Private environment. A. Private environment record or null. The private environment record for private names that the function was closed over null if this function is not syntactically contained within a class. Used as the outer private environment for inner classes when evaluating the code of the function. Formal parameters. A parse node. The root parse node of the source text that defines the function's formal parameter list. ECMAScript code. A parse node. The root parse node of the source text that defines the function's body. Construct kind. Base or derived, whether or not the function is a derived class constructor. Realm. A realm record. The realm in which the function was created and which provides any intrinsic objects that are accessed used when evaluating the function, script or module, a script record or a module record, the script or module in which the function was created. This mode, lexical, strict, or global, defines how this references are interpreted within the formal parameters and code body of the function. Lexical means that this refers to the this value of a lexically enclosing function. Strict means that the this value is used exactly as provided by an invocation of the function. Global means that this value of undefined or null is interpreted as a reference to the global object, and any other this value is first passed to object. Copyright sign, ECMA International 2024, 75. Table 30. Internal slots of ECMAScript function objects. Continued. Internal slot. Type. Description. Strict. A boolean. True if this is a strict function. False if this is a non-strict function. Home object. An object. If the function uses super, this is the object whose provides the object where super property lookups begin. Source text. A sequence of Unicode code points. The source text that defines the function. Fields. A list of class field definition records. If the function is a class, this is a list of records representing the non-static fields and corresponding initializers of the class. Private methods. A list of private elements. If the function is a class, this is a list representing the non-static private methods and accessors of the class. Class field initializer name, a string, a symbol, a private name, or empty. If the function is created as the initializer of a class field, the name to use for named evaluation of the field. Empty otherwise is class constructor. A boolean indicates whether the function is a class constructor. If true, invoking the functions will immediately throw a type error exception. All ECMAScript function objects have the internal method defined here. ECMAScript functions that are also constructors in addition have the internal method 0, 2, 1. This arguments list. The internal method of an ECMAScript function object f takes arguments this argument, an ECMAScript language value, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Let caller context be the running execution context. Let callee context be prepare for ordinary call. F. Undefined. Assert. Callee context is now the running execution context. If f is true, then a let error be a newly created type error object. B note. Error is created in callee context with f's associated realm record. C. Remove callee context from the execution context stack and restore caller context as the running execution context. D. Return throw completion. Error. Perform ordinary call bind this. F. Callee context. This argument. Let result be completion. Ordinary call evaluate body. F. Arguments list. Remove callee context from the execution context stack and restore caller context as the running execution context. If result is a return completion, return result. Return of abrupt. Result 0. Return undefined. 176. ECMA International 2024. Note when callee context is removed from the execution context stack in step 7 it must not be destroyed if it is suspended and retained for later resumption by an accessible generator. 1 0 2 1 1 Prepare for ordinary call. F. New target. The abstract operation prepare for ordinary call takes arguments f, an ECMAScript function object, a new target, an object or undefined, and returns an execution context. It performs the following steps when called. Let caller context be the running execution context. Let callee context be a new ECMAScript code execution context. Set the function of callee context to f. Let callee realm be f. Set the realm of callee context to callee realm. Set the script or module of callee context to f. Let local env be new function environment. F. New target. Set the lexical environment of callee context to local env. Set the variable environment of callee context to local env. 0. Set the private environment of callee context to f. 1. If caller context is not already suspended, suspend caller context. 2. Push callee context onto the execution context stack. Callee context is now the running execution context. 3. Note. Any exception objects produced after this point are associated with callee realm. 4. Return callee context. 0. 2, 1. To ordinary call bind this. F. Callee context. This argument. The abstract operation ordinary call bind this takes arguments F, an ECMAScript function object, callee context, an execution context, and this argument, an ECMAScript language value, and returns a new said. It performs the following steps when called. Let this mode be F. If this mode is lexical, return unused. Let callee realm be F. Let local env be the lexical environment of callee context. If this mode is strict, then let this value be this argument 6. Else, if this argument is either undefined or null, then I let global env be callee realm 2. Assert. Global env is a global environment record. 3. Let this value be global env. Be else, I let this value be. To object. This argument. 2. Note. To object produces wrapper objects using callee realm. Assert. Local env is a function environment record. Assert. The next step never returns an abrupt completion because local env is not initialized. Perform local env bind this value. This value 0. Return unused 0, 2, 1, 3 runtime semantics. Evaluate body. The syntax directed operation evaluate body takes arguments function object, an ECMAScript function object, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It is defined piecewise over the following productions. Function body. Function statement list. Return. Evaluate function body of function body with arguments function object and arguments list. Concise body. Expression body. Return. Evaluate concise body of concise body with arguments function object and arguments list. ECMA International 2024 177. Generator body. Function body. Return. Evaluate generator body of generator body with arguments function object and arguments list. Async generator body. Function body. Return. Evaluate async generator body of async generator body with arguments function object and arguments list. Async function body. Function body. Return. Evaluate async function body of async function body with arguments function object and arguments list. Async concise body. Expression body. Return. Evaluate async concise body of async concise body with arguments function object and arguments list. Initializer. Assignment expression. Assert. Arguments list is empty. Assert. Function object is not empty. If is anonymous function definition, assignment expression, is true, then a let value be. Named evaluation of initializer with argument function object. Else a let RHS be. Evaluation of assignment expression be let value be. Get value RHS. Return completion record. Return value empty. Class static block body. Class static block statement list. Assert. Arguments list is empty. Return. Evaluate class static block body of class static block body with argument function object. 0, 2, 1. For ordinary call evaluate body. F. Arguments list. The abstract operation ordinary call evaluate body takes arguments F, an ECMAScript function object, and arguments list, list of ECMAScript language, age values, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It performs the following steps when called. Return. Evaluate body of F with arguments F and arguments list 1, 0, 2, 2. Arguments list. New target. The internal method of an ECMAScript function object F takes arguments list, a list of ECMAScript language values, a new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Let caller context be the running execution context. Let kind be F if kind is base. Then let this argument be. Ordinary create from constructor. New target. %object prototype %4. Let callee context be prepared for ordinary call. F. New target. 178. ECMA International 2024. Note even though field initializers constitute a function boundary, calling capital F, U, N, C, T I O N capital D E C L A R A T I O N capital I N S T A N T I A T I does not have any observable effect and so is omitted. 5. Assert. Callee context is now the running execution context. If kind is base, then a perform ordinary call bind this. F. Callee context. This argument, B let initialize result be completion, initialize instance elements. This argument, F. See if initialize result is an abrupt completion, then I remove callee context from the execution context stack and restore callee context as the running execution context. 2. Return initialize result. Let constructor env be the lexical environment of callee context. Let result be completion. Ordinary call evaluate body. F. Arguments list. Remove callee context from the execution context stack and restore callee context as the running execution context. 0. If result is a return completion, then if result is an object, return result. B if kind is base, return this argument. C if result is not undefined, throw a type error exception. 1. Else a return if abrupt. Result. 2. Let this binding be constructor env get this binding. 3. Assert. This binding is an object. 4. Return this binding. 0. 2. 3. Ordinary function create. Function prototype. Source text. Parameter list. Body. This mode. env. Private env. The abstract operation ordinary function create takes arguments function prototype. An object. Source text. A sequence of Unicode code points. Parameter list. A parse node. Body a parse node. This mode. Lexical this or non-lexical this. env. An environment record. And private env. A private environment record or null. And returns an ECMAScript function object. It is used to specify the runtime creation of a new function with a default internal method and no internal method, although one may be subsequently added by an operation such as make constructor. Dart source text is the source text of the syntactic definition of the function to be created. It performs the following steps when called. Let internal slots list T be the internal slots listed in table 30. Let F be ordinary object create. Function prototype. Internal slots list. Set F to the definition specified in 10. 2. 1. Set F to source text. Set F to parameter list. Set F to body. If the source text matched by body is strict mode code, let strict be true, else let strict be false. Set F to strict. If this mode is lexical this, set F to lexical. 0. Else if strict is true, set F to strict. 1. Else, set F to global. 2. Set F to false. 3. Set F to env. 4. Set F to private env. 5. Set F to get active script or module. 6. Set F to the current realm record. 7. Set F to undefined. 8. Set F to a new empty list. 9. Set F to a new empty list. 0. Set F to empty. 1. Let len be the expected argument counter parameter list. 2. Perform set function length. F. Len. 3. Return F. ECMA International 2024 179. 10. 2. 4. Capital A. D. D. Capital R. E. S. T. R. I. C. T. E. D. Capital F. U. N. C. T. I. O. N. Capital P. R. O. P. E. R. T. I. E. F. Realm. The abstract operation. Capital A. D. D. Capital R. E. S. T. R. I. C. T. E. D. Capital F. U. N. C. T. I. O. N. Capital P. R. O. P. E. R. T. I. E. Takes arguments F. A function object. and realm, a realm record, and returns unused. It performs the following steps when called. Assert. Realm exists and has been initialized. Let thrower be realm. Perform. Define property or throw. F. Caller. Property descriptor. Thrower. Enumerable. False. True. Perform. Define property or throw. F. Arguments. Property descriptor. Thrower. Enumerable. False. True. Return unused. 0, 2, 4, 1% throw type error percent. This function is the percent throw type error percent intrinsic object. It is an anonymous built-in function object that is defined once for each realm. It performs the following steps when called. Throw a type error exception. The value of the internal slot of this function is false. The length property of this function has the attributes false, false, false. The name property of this function has the attributes false, false, false. 0, 2, 5. Make constructor. F. Writable prototype. Prototype. The abstract operation make constructor takes argument f, an ECMAScript function object or a built-in function object, and optional arguments writable prototype, a boolean, and prototype, an object, and returns unused. It converts f into a constructor. It performs the following steps when called. If f is an ECMAScript function object, then A assert is constructor, f is false. B assert. F is an extensible object that does not have a PR autotype own property. C set f to the definition specified in 1.0.2. 2. Else A set f to the definition specified in 1.0.3. 2. Set f to base. If writable prototype is not present, set writable prototype to true. If prototype is not present, then A set prototype to ordinary object create percent object prototype percent. B perform. Define property or throw prototype constructor property descriptor. F writable prototype false true. Perform. Define property or throw F prototype property descriptor prototype writable prototype false false. Return unused. 80. ECMA International 2024 1.0.2. 6. Make class constructor F. The abstract operation make class constructor takes argument f, an ECMAScript function object, and returns unused. It performs the following steps when called. Assert. F is false. Set f to true. Return unused. 0, 2, 7. Make method f. Home object. The abstract operation make method takes arguments f, an ECMAScript function object, and home object, an object, and returns unused. It configures f as a method. It performs the following steps when called. Set f to home object. Return unused. 0, 2, 8. Define method property. Home object. Key. Closure. Enumerable. The abstract operation define method property takes arguments home object, an object, key, a property key or private name, closure, a function object, and enumerable, a boolean, and returns either a normal completion containing either a private element or unused, or an abrupt completion. It performs the following steps when called. Assert. Home object is an ordinary, extensible object. If key is a private name, then a return private element. Method. Closure 3. Else a let desc be the property descriptor. Closure. True. Enumerable. True. B perform. Define property or throw. Home object. Key. Desk. C note. Define property or throw only returns an abrupt completion when attempting to define a class. Static method whose key is prototype. D return unused. 0, 2, 9. Set function name. F. Name. Prefix. The abstract operation set function name takes arguments f, a function object, a name, a property key or private name, and optional argument prefix, a string, and returns unused. It adds a name property to f. It performs the following steps when called. Assert. F is an extensible object that does not have a name own property. If name is a symbol, then a let description be name's value. B if description is undefined. Set name to the empty string. C else. Set name to the string concatenation of description, and else if name is a private name. then a set name t o name. If f has an internal slot, then a set f to name. If prefix is present, then a set name to the string concatenation of prefix. The code unit 0 times 0020 space and name. B if f has an internal slot, then I optionally set f to name. Perform. Define property or throw f name property descriptor name false enumerable false true return unused. ECMA International 2024 181 the 10th of February 2010. Set function length f length. The abstract operation set function length takes arguments f, a function object, and length, a non-negative int, j or plus, and returns unused. It adds a length property to f. It performs the following steps when called. Assert. F is an extensible object that does not have a length own property. Perform. Define property or throw f length property descriptor length false enumerable false true return unused 0 2 1 1 capital F U N C T I O N capital D E C L A R A T I O N capital I N S T A N T I A T I func arguments list. The abstract operation capital F U N C T I O N capital D E C L A R A T I O N capital I N S T A N T I A T I takes arguments func, an ECMAScript function object, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing unused or an abrupt completion. Func is the function object for which the execution context is being established. Note 1. When an execution context is established for evaluating an ECMAScript function, a new function environment record is created and bindings for each formal parameter are instantiated in that environment record. Each declaration in the function body is also instantiated. If the function's formal parameters do not include any default value initializers, then the body declarations are instantiated in the same environment record as the parameters. If default value parameter initializers exist, a second environment record is created for the body declarations. Formal parameters and functions are initialized as part of capital F U N C T I O N capital D E C L A R A T I O N capital I N S T A N T I A T I. All other bindings are initialized during evaluation of the function body. It performs the following steps when called. Let callee context be the running execution context. Let code be func. Let strict be func. Let formals be func. Let parameter names be the bound names of formals. If parameter names has any duplicate entries, let has duplicates be true. Otherwise, let has duplicates be false. Let simple parameter list be as simple parameter list of formals. Let has parameter expressions be contains expression of formals. Let var names be the var declared names of code. 0. Let var declarations be the var scope declarations of code. 1. Let lexical names be the lexically declared names of code. 2. Let function names be a new empty list. 3. Let functions to initialize be a new empty list. 4. Our each element D of var declarations, in reverse list order, do, if D is neither a variable declaration nor a for binding nor a binding identifier, then, I assert, D is either a function declaration, a generator declaration, an async function declaration, or an async generator declaration. 2. Let fn be the sole element of the bound names of D. 3. If function names does not contain fn, then insert fn as the first element of function names. Note: If there are multiple function declarations for the same name, the last declaration is used. Insert D as the first element of functions to initialize. 5. Let arguments object needed be true. 6. If func is lexical, then a note arrow functions never have an arguments object. B. Set arguments object needed to false. 7. Else if parameter names contains arguments, then a set arguments object needed to false. 82. ECMA International 2024. 18. Else if his parameter expressions is false, then if function names contains arguments or lexical names contains arguments, then I set arguments object needed to false. 9. If strict is true or has parameter expressions is false, then a note only a single environment record is needed for the parameters, since calls to eval in strict mode code cannot create new bindings which are visible outside of the eval. B. Let env be the lexical environment of callee context. 0. Else, a note a separate environment record is needed to ensure that bindings created by direct eval calls in the formal parameter list are outside the environment where parameters are declared. B. Let callee env be the lexical environment of callee context. C. Let env be new declarative environment. Callee env. D. Assert the variable environment of callee context is callee env. E. Set the lexical environment of callee context to env. 1. For each string param name of parameter names, do a let already declared env has binding. Param name, B. Note, early errors ensure that duplicate parameter names can only occur in non-strict functions that do not have parameter default values or rest parameters. See if already declared is false. Then, I perform env create mutable binding. Param name, false. 2. If his duplicates is true, then perform env initialize binding. Param name, undefined. 22. If arguments object needed is true, then if strict is true or simple parameter list is false, then I let AOB create a mapped arguments object, arguments list. B. Else, I note, a mapped argument object is only provided for non-strict functions that don't have a rest parameter, any parameter default value initializers, or any destructured parameters. 2. Let AOB create mapped arguments object, func, formals, arguments list, env. See if strict is true, then I perform env create a mutable binding, arguments, false. 2. Note, in strict mode code, early errors prevent attempting to assign to this binding, so its mutability is not observable. D. Else, I perform env create mutable bindi, ng, arguments, false. E. Perform env initialize binding, arguments, O. F. Let parameter bindings be the list concatenation of parameter names and arguments. 3. Else, a let parameter bindings be parameter names. 4. Let iterator record be create list iterator record, arguments list. 5. If his duplicates is true, then a perform iterator binding initialization of formals with arguments iterator record and undefined. 26. Else, a perform iterator binding initialization of formals with arguments iterator record and env. 27. If his parameter expressions is false, then a note only a single environment record is needed for the parameters and top-level vars. B. Let instantiated var names be a copy of the list parameter bindings. C. For each element n of var names, do I if instantiated var names does not contain n, then append n to instantiated var names. Perform env create mutable binding, n, false. Perform env initialize binding, n, undefined. D. Let var env be env. 28. Else, a note, a separate environment record is needed to ensure that closures created by expressions in the formal parameter list do not have visibility of declarations in the function body. B. Let var env be new declarative environment, env. C. Set the variable environment of callee context to var env. D. Let instantiated var names be a new empty list. E. For each element n of var names, do I if instantiated var names does not contain n, then ECMA International 2024 183. 1. Append n to instantiated var names. Perform var env create mutable binding, n, false. If parameter bindings does not contain n, or if function names contains n, then a let initial value be undefined. 4. Else, a let initial value be env get binding value, n, false. Perform var env initialize binding. N. Initial value. Note. A var with the same name as a formal parameter initially has the same value as the corresponding initialized parameter. 9. Note. An xb 3, 2, 1 adds additional steps at this point. 0. If strict is false, then a let lexi-env be new declarative environment. Var env be note. Non-strict functions use a separate environment record for top-level lexical declarations so that a direct eval can determine whether any var scope declarations introduced by the eval code conflict with pre-existing top-level lexically scoped declarations. This is not needed for strict functions because a strict direct eval always places all declarations into a new environment record. 1. Else, a let lexi-env be var env. 2. Set the lexical environment of callee context to lexi-env. 3. Let lex declarations be the lexically scoped declarations of code. 4. For each element D of lex declarations, do a note. A lexically declared name cannot be the same as a function generator declaration, formal parameter, or a var name. Lexically declared names are only instantiated here but not initialized. B for each element Dn of the bound names of D, do I if this constant declaration of D is true, then perform lexi-env create immutable binding. Dn, true 2. Else, perform lexi-env create mutable binding. Dn, false 5. Let private env be the private environment of callee context. 6. For each parse node f of functions to initialize, do a let fn be the sole element of the bound names of f. B let fo be instantiate function object of f with arguments lexi-env and private env. C perform var env set mutable binding. Fn, fo, false 7. Return unused. 0.3 Built-in function objects. A built-in function object is an ordinary object. It must satisfy the requirements for ordinary objects set out in 10.1. In addition to the internal slots required of every ordinary object, see 10.1, a built-in function object must also have the following internal slots: a realm record that represents the realm in which the function was created, a string that is the initial name of the function. It is used by 20, 2, 3, 5. The initial value of a built-in function object's internal slot is %function prototype %, unless otherwise specified. A built-in function object must have an internal method that conforms to the definition in 103. 1. A built-in function object has an internal method if and only if it is described as a constructor, or some algorithm in this specification explicitly sets its internal method. Such an internal method must conform to the definition in 103. 2. An implementation may provide additional built-in function objects that are not defined in this specification. Note 2b. 3.2 provides an extension to the above algorithm that is necessary for backwards compatibility with web browser implementations of ECMAScript that predate ECMAScript 2015. 84. Copyright sign, ECMA International 2024. 103. 1. This arguments list. The internal method of a built-in function object f takes arguments this argument, an ECMAScript language value, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called: return, built-in call or construct, f, this arguments list, undefined 103. 2. Arguments list, new target. The internal method of a built-in function object f, when the method is present, takes arguments list, a list of ECMAScript language values, a new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called: return, built-in call or construct, f, uninitialized, arguments list, new target 103. 3. Built-in call or construct, f, this arguments list, new target. The abstract operation built-in call or construct takes arguments f, a built-in function object, this argument, an ECMAScript language value, or uninitialized, arguments list, a list of ECMAScript language values, and new target. icon, structure or undefined, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Let caller context be the running execution context. If caller context is not already suspended, suspend caller context. Let callee context be a new execution context. Set the function of callee context to f. Let callee realm be f. Set the realm of callee context to callee realm. Set the script or module of callee context to null. Perform any necessary implementation defined initialization of callee context. Push callee context onto the execution context stack. Callee context is now the running execution context. 0. Let result be the completion record, that is the result of evaluating f in a manner that conforms to the specification of f if this argument is uninitialized, that this value is uninitialized. Otherwise, this argument provides the this value arguments list provides the named parameters new target provides the new target value. 1. Note: if f is defined in this document, the specification of f is the behavior specified for it via algorithm steps or other means. 2. Remove callee context from the execution context stack and restore caller context as the running execution context. 3. Return result 0, 3, 4. Create built-in function, behavior, length, name, additional internal slots list, realm, prototype, prefix. The abstract operation create built-in function takes arguments behavior, an abstract closure, a set of algorithm steps, or some other definition of a function's behavior provided in this specification, length, a non-negative integer or plus, name, a property key or a private name, and additional internal slots list, a list of names of internal slots, and optional arguments realm, a realm record, prototype, an object or null, and prefix, a string. And returns a function object. Additional internal slots list contains the names of additional internal slots that must. Note: when callee context is removed from the execution context stack, it must not be destroyed if it has been suspended and retained by an accessible generator for later resumption. ECMA International 2024 185 be defined as part of the object. This operation creates a built-in function object. It performs the following steps when called. If realm is not present, set realm to the current realm record. If prototype is not present, set prototype to realm. Let internal slots list be a list containing the names of all the internal slots that 10.3 requires for the built-in function object that is about to be created. Append to internal slots list the elements of additional internal slots list. Let fun be a new built-in function object that, when called, performs the action described by behavior, using the provided arguments as the values of the corresponding parameters specified by behavior. The new function object has internal slots whose names are the elements of internal slots list, and an internal slot. Set fun to prototype, set fun to true, set fun to realm, set fun to null. 0. Perform set function length, func, length 1. If prefix is not present, then a perform set function name, func, name 12. Else a perform set function name, func, name, prefix 13. Return func. Each built-in function defined in this specification is created by calling the create built-in function abstract operation. 0.4 Built-in exotic object internal methods and slots. This specification defines several kinds of built-in exotic objects. These objects generally behave similar to ordinary objects except for a few specific situations. The following exotic objects use the ordinary object internal methods except where it is explicitly specified otherwise below. 0, 4, 1 Bound function exotic objects. A bound function exotic object is an exotic object that wraps another function object. A bound function exotic object is callable. It has an internal method and may have an internal method. Calling a bound function exotic object generally results in a call of its wrapped function. An object is a bound function exotic object if its and, if applicable, internal methods use the following implementations, and its other essential internal methods use the definitions found in 10.1. These methods are installed in bound function create. Bound function exotic objects do not have the internal slots of ECMAScript function objects listed in table 30. Instead, they have the internal slots listed in table 31, in addition to and table 31, internal slots of bound function exotic objects, internal slot, type, description, bound target function, a callable object, the wrapped function object, bound this, an ECMAScript language value, the value that is always passed as this value when calling the wrapped function, bound arguments, a list of ECMAScript language values, a list of values whose elements are used as the first arguments to any call to the wrapped function. 186, ECMA International 2024, 10411. This arguments list. The internal method of a bound function exotic object f takes arguments this argument, an ECMAScript language value, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Let target be f, let bound this be f, let bound args be f, let args be the list concatenation of bound args and arguments list. Return. Call. Target. Bound this. Args 0, 4, 1, 2. Arguments list. New target. The internal method of a bound function exotic object f takes arguments list, a list of ECMAScript language values, a new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Let target be f, assert, is constructor, target, is true. Let bound args be f, let args be the list concatenation of bound args and arguments list. If same value, f, new target, is true. Set new target to target. Return. Construct. Target. Args. New target. 0, 4, 1. 3 bound function create. Target function. Bound this. Bound args. The abstract operation bound function create takes arguments target function, a function object. Bound this. An ECMAScript language value. And bound args. A list of ECMAScript language values, and returns either a normal completion containing a function object or a throw completion. It is used to specify the creation of new bound function exotic objects. It performs the following steps when called. Let proto be target function, let internal slots list be the list concatenation of and the internal slots listed in table 31. Let obj be make basic object. Internal slots list. Set obj to proto. Set obj as described in 10411. If this constructor, target function, is true, then as set obj as described in 10412. Set obj to target function. Set obj to bound this. Set obj to bound args 0. Return obj 0, 4. To array exotic objects. An array is an exotic object that gives special treatment to array index property keys, C6, 1, 7. A property whose property name is an array index is also called an element. Every array has a non-configurable length property whose value is always a non-negative integral number whose mathematical value is strictly less than 32. The value of the length property is numerically greater than the name of every own property whose name is an array index, whenever a known property of an array is created or changed. Other properties are adjusted as necessary to maintain this invariant. Specifically, whenever a known property is added whose name is an array index, the value of the length property is changed, if necessary, to be one more than the numeric value of that array index. And whenever the value of the length property is changed, every own property whose name is an array index whose value is not smaller than the new length is deleted. This constraint applies only to own. ECMA International 2024 187. Properties of an array and is unaffected by length or array index properties that may be inherited from its prototypes. An object is an array exotic object, or simply, an array, if its internal method uses the following implementation, and its other essential internal methods use the definitions f and in 10.1. These methods are installed in array create 0, 4, 2, 1, p, desc. The internal method of an array exotic object takes arguments p, a property key, and desc, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If p is length, then a return array set length a desk, else if P is an array index, then a let length desk be ordinary get own property, A, length, B assert, is data descriptor, length desk, is true, C assert, length desk is false, D let length be length desk, E assert, length is a non-negative integral number, F let index be, tween 32, P, G if index length and length desk is false, return false, H let succeeded B, ordinary define own property, A, P, desk, I have succeeded is false, return false, J if index length, then I set length desk to index plus 1, 2, set succeeded to, ordinary define own property, A, length, length desk, 3, assert, succeeded is true, K return true, return, ordinary define own property, A, P, desk, 0, 4, 2, to array create, length, proto, the abstract operation array create takes argument length, a non-negative integer, and optional argument proto an object, and returns either a normal completion containing an array exotic object or a throw completion. It is used to specify the creation of new arrays. It performs the following steps when called. If length 232.1, throw a range error exception. If proto is not present, set proto to %array prototype %. Let A be make basic object. Set A to proto. Set A is specified in 1 0 4 2 1. Perform. Ordinary define own property A, length, property descriptor, length, true, false, false, return A, 0, 4, 2, 3 array species create, original array, length. The abstract operation array species create takes arguments original array, an object, and length, a non-negative integer, and returns either a normal completion containing an object or a throw completion. It is used to specify the creation of a new array or similar object using a constructor function that is derived from original array. It does not enforce that the constructor function returns an array. It performs the following steps when called. Let is array be, is array, original array. If is array is false, return. Array create, length. Let C be, get, original array, constructor. If this constructor, C, is true, then 88. ECMA International 2024. A let this realm be the current realm record. B let realm be. Get function realm. C. See if this realm and realm are not the same realm record. Then I have same value. C. Realm is true. Set C to undefined. If C is an object, then assert CT. O. Get C. At species. B if C is null. Set C to undefined. If C is undefined, return. Array create, length. If this constructor, C, is false, throw a type error exception, return. Construct, C, length, 0, 4, 2, 4 array set length, A, desk. The abstract operation array set length takes arguments A, an array, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If desk does not have a field, then a return. Ordinary define own property A, length, desk. Let new len desk be a copy of desk. Let new len be, tween 32, desk. Let number len be, to number, desk. If same value 0, new len, number len, is false. Throw a range error exception. Set new len desk to new len. Let old len desk be ordinary get own property A, length, assert, is data descriptor. Old len desk is true. Assert, old len desk is false. 0. Let old len be old len desk. 1. If new len old len, then a return. Ordinary define own property A, length, new len desk. 2. If old len desk is false, return false. 3. If new len desk does not have a field or new len desk is true, then a let new writable be true. 4. Else, a note. Setting the attribute to false is deferred in case any elements cannot be deleted. B let new writable be false. C set new len desk to true. 5. Let succeeded be. Ordinary define own property A, length, new len desk. 6. If succeeded is false, return false. 7. For each own property, key P of a such that P is an array index and 32 P new len in descending numeric index order. Do a let delete succeeded B. A P B if delete succeeded is false. Then I set new len desk to 32 P plus 1 2. If new writable is false, set new len desk to false. 3. Perform ordinary define own property A length new len desk I've return false. 8. If new writable is false, then assert succeeded to ordinary define own property A length property descriptor false. B assert succeeded is true. 9. Return true. Note if original array was created using the standard built-in array constructor for a realm that is not the realm of the running execution context, then a new array is created using the realm of the running execution context. This maintains compatibility with web browsers that have historically had that behavior for the array prototype methods that now are defined using array species create. ECMA International 2024 189. Note, in steps 3 and 4, if desk is an object, then its value of method is called twice. This is legacy behavior that was specified with this effect starting with the second edition of this specification. 0, 4, 3 string exotic objects. A string object is an exotic object that encapsulates a string value and exposes S virtual integer index data properties corresponding to the individual code unit elements of the string value. String exotic objects always have a data property named length whose value is the length of the encapsulated string value. Both the code unit data properties and the length property are non-writable and non-configurable. An object is a string exotic object, or simply a string object, if its and internal methods use the following implementations, and its other essential internal methods use the definitions found in 10.1. These methods are installed in string create. String exotic objects have the same internal slots as ordinary objects. They also have internal slot 1 0, 4, 3, 1, P. The internal method of a string exotic object S takes argument P, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. Let desk be ordinary get own property S P. If desk is not undefined, return desk. Return string get own property S P 0, 4, 3, 2 P desk. The internal method of a string exotic object S takes arguments P, a property key, and desk, a property descriptor, and returns a normal completion containing a boolean. It performs the following steps when called. Let string desk be string get own property S P. If string desk is not undefined, then a let extensible be S. P return is compatible property descriptor extensible desk string desk. Return ordinary define own property S P desk 0, 4, 3, 3. The internal method of a string exotic object O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Let keys be a new empty list. Let str be O. Assert str is a string. Let len be the length of str for each integer I such that 0 I len in ascending order. Do a append to string I to keys for each own property key P of O such that P is an array index and to an integer or infinity P len in ascending numeric index order. Do a append P to keys for each own property key P of O such that P is a string and P is not an array index. In ascending chronological order of property creation, do a append P to keys. 90. ECMA International 2024 8. For each own property key P of O such that P is a symbol. In ascending chronological order of property creation, do a append P to keys. 9. Return keys 0, 4, 3, 4 string create value prototype. The abstract operation string create takes arguments value, a string, and prototype, an object, and returns a string exotic object. It is used to specify the creation of new string exotic objects. It performs the following steps when called. Let S be make basic object. Set S to prototype. Set S to value. Set S as specified in 1 0, 4, 3, 1. Set S as specified in 1, 0, 4, 3, 2. Set S as specified in 1, 0, 4, 3, 3. Let length be the length of value. Perform. Define property or throw S, length, property descriptor, length, false, enumerable, false, false. Return S, 0, 4, 3, 5. String get own property, S, P. The abstract operation string get own property takes arguments S, an object that has an internal slot, and P, a property key, and returns a property descriptor or undefined. It performs the following steps when called. If P is not a string, return undefined. Let index be canonical numeric index string, P. If index is undefined, return undefined. If is integral number, int x, is false, return undefined. If index is -0, return undefined. Let str be s. Assert. Str is a string. Let len be the length of str. If r, int x, 0 or len r, int x, return undefined. 0. Let result str be the substring of str from r, int x, to r. Index +1, 1. Return the property descriptor. Result str. False. True, false. 0, 4. 4 arguments exotic objects. Most ECMAScript functions make an arguments object available to their code. Depending upon the characteristics of the function definition, its arguments object is either an ordinary object or an arguments exotic object. An arguments exotic object is an exotic object whose array index properties map to the formal parameters bindings of an invocation of its associated ECMAScript function. An object is an arguments exotic object if its internal methods use the following implementations, with the ones not specified here using those found in 10.1. These methods are installed and create mapped arguments object. Arguments exotic objects have the same internal slots as ordinary objects. They also have an internal slot. Ordinary arguments objects also have an internal slot whose value is always undefined. For ordinary argument objects, the internal slot is only used by object prototype to string 20, 1, 3, 6 to identify them as such. Note 1. While creating mapped arguments object is grouped into this clause, it creates an ordinary object, not an arguments exotic object. ECMA International 2024 191. Note 2. The integer index data properties of an arguments exotic object whose numeric name values are less than the number of formal parameters of the corresponding function object initially share their values with the corresponding argument bindings in the function's execution context. This means that changing the property changes the corresponding value of the argument binding and vice versa. This corresponding E is broken if such a property is deleted and then redefined, or if the property is changed into an accessor property. If the arguments object is an ordinary object, the values of its properties are simply a copy of the arguments passed to the function, and there is no dynamic linkage between the property values and the formal parameter values. Note 3. The parameter map object and its property values are used as a device for specifying the arguments object correspondence to argument bindings. The parameter map object and the objects that are the values of its properties are not directly observable from ECMAScript code. An ECMAScript implementation does not need to actually create or use such objects to implement the specified semantics. Note 4. Ordinary arguments objects define a non-configurable accessor property named callee, which throws a type error exception on access. The callee property has a more specific meaning for arguments exotic objects, which are created only for some class of non-strict functions. The definition of this property in the ordinary variant exists to ensure that it is not defined in any other manner by conforming ECMAScript implementations. Note 5. ECMAScript implementations of arguments exotic objects have historically contained an accessor property named caller. Prior to ECMAScript 2017, the specification included the definition of a throwing caller property on ordinary arguments objects. Since implementations do not contain this extension any longer, ECMAScript 2017 dropped the requirement for a throwing caller accessor. 0, 4, 4, 1. P. The internal method of an arguments exotic object args takes argument P, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. Let desk be ordinary get own property, args, p. If desk is undefined, return undefined. Let map be args. Let is mapped be. Has own property, map, p. If is mapped is true, then a set desk to. Get, map, p6. Return desk 0, 4, 4, 2, p, desk. The internal method of an argument's exotic object args takes arguments p, a property key, and desk, a property descriptor, and returns a normal completion containing a boolean. It performs the following steps when called. Let map be args. Let is mapped be. Has own property, map, p. Let new arg desk be desk. If is mapped is true and is data descriptor, desk, is true. Then, if desk does not have a field, desk has a field, and desk is false, then I set new arg desk to a copy of desk 2. Set new arg desk to. Get, map, p. Let allowed be. Ordinary define own property, args, p. New arg desk 92. ECMA International 2024 6. If allowed is false, return false. If is mapped is true, then if is accessor descriptor, desk, is true, then I perform map, p. Be else. If desk has a field, then assert. The following set will succeed. Since formal parameters mapped by arguments objects are always writable. Perform. Set. Map. P. Desk. False. 2. If desk has a field and desk is false, then perform map. P8. Return true. 0, 4, 4, 3. The let map be args. Let is mapped be. Has own property. Map. P. If is mapped is false, then a return. Ordinary get. Args. P. Receiver 4. Else a assert. Map contains a formal parameter mapping for p. P return. Get. Map. P 0, 4, 4, 4. The if same value, args, receiver, is false, then a let is mapped be false. Else a let map be args. B let is mapped be. Has own property, map, p. If is mapped is true, then a assert. The following set will succeed. Since formal parameters mapped by arguments objects are always writable. B perform. Set. Map. P. V. False. Return. Ordinary set. Args. P. V. Receiver 0, 4, 4, 5. P. The internal method of an argument's exotic object args takes argument p, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let map be args. Let is mapped be. Has own property. Map. P. Let result be. Ordinary delete. Args. P. If result is true and is mapped is true, then a perform map. P5. Return result. ECMA International 2024 193 10 4 4 6. Create and mapped arguments object. Arguments list. The abstract operation create and mapped arguments object takes arguments list, a list of ECMAScript language values, and returns an ordinary object. It performs the following steps when called. Let len be the number of elements in arguments list. Let obj be ordinary object create. %object prototype %set obj to undefined. Perform. Define property or throw. Obj. Length. Property descriptor. Len. True. Enumerable. False. True. Let index be 0. Repeat. While index. Len. A let val be arguments list. Index. Be perform. Create data property or throw. Obj. To string. Index. Val. C set index to index +1. Perform. Define property or throw. Obj. At iterator. Property descriptor. %array prototype values %. True. False. True. Perform. Define property or throw. Obj. Callee. Property descriptor. %throw type error %. False. Return obj. 0, 4, 4, 7. Create mapped arguments object. Func. Formals. Arguments list. Env. The abstract operation create mapped arguments object takes arguments func, an object, formals, a parse node, arguments list, a list of ECMAScript language values, and env, an environment record, and returns an arguments exotic object. It performs the following steps when called. Assert. Formals does not contain a rest parameter, any binding patterns, or any initializers. It may contain duplicate identifiers. Let len be the number of elements in arguments list. Let obj be make basic object. Set obj is specified in 1 0 4 4 1. Set obj is specified in 1 0 4 4 2. Set obj is specified in 1 0 4 4 5. Set obj to percent object prototype percent 0. Let map be ordinary object create null 1. Set obj to map 2. Let parameter names be the bound names of formals 3. Let number of parameters be the number of elements in parameter names 4. Let index be 0 5. Repeat. While int x len let val be arguments list. Index be perform. Create data property or throw obj to string int x val c set index index plus 1 6. Perform. Define property or throw obj length property descriptor len true false true 7. Let map names be a new empty list 8. Set index to number of parameters 1 9. Repeat. While index 0 94. ECMA International 2024 A B C. Let name be parameter names. Index. If map names does not contain name, then I append name to map names 2. If int x len, then let g be make arg getter name env. Let p be make arg setter name env. Perform map to string int x property descriptor get g false true. Set index 1 20. Perform. Define property or throw obj at iterator property descriptor percent array prototype values percent true false true 1. Perform. Define property or throw obj callie property descriptor func true false true 2. Return obj 0 4 4 7 1. Make arg getter name env. The abstract operation make arg getter takes arguments name, a string, and env, an environment record, and returns a function object. It creates a built-in function object t that when executed returns the value bound for name and env. It performs the following steps when called. Let getClosure be a new abstract closure with no parameters that captures name and env and performs the following steps when called. A return env get binding value name false. Let getter be create built-in function getClosure 0. Note: getter is never directly accessible to ECMAScript code. Return getter 0 4 4 7 to make arg setter name env. The abstract operation make arg setter takes arguments name, a string, and env, an environment record, and returns a function object. It creates a built-in function object that when executed sets the value bound for name and env. It performs the following steps when called. Let setClosure be a new abstract closure with parameters value that captures name and env and performs the following steps when called. A return env set mutable binding name value false. Let setter be create built-in function setClosure 1. Note: setter is never directly accessible to ECMAScript code. Return setter 0 4 5 typed array exotic objects. A typed array is an exotic object that performs special handling of integer index property keys. Typed arrays have the same internal slots as ordinary objects and additionally length and internal slots. An object is a typed array if its and internal methods use the definitions in this section, and its other essential internal methods use the definitions found in 10.1. These methods are installed by typed array create 0 4 5 1 p. The internal method of a typed array o takes argument p, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. If P is a string, then a let numeric index be canonical numeric index string P be. If numeric index is not undefined, then I let value be typed array get element. Oh, numeric index. 2. If value is undefined, return undefined. 3. Return the property descriptor value true, true, true. Return ordinary get own property. O. P. ECMA International 2024 195 10452. P. The internal method of a typed array O takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If P is a string, then a let numeric index be canonical numeric index string P be. If numeric index is not undefined, return as valid integer index. O. Numeric index. Return. Ordinary has property O. P 0 4 5 3 P. Desk. The internal method of a typed array O takes arguments P, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If P is a string, then a let numeric index be canonical numeric index string P be. If numeric index is not undefined, then if as valid integer index O. Numeric index is false, return false. 2. If desk has a field and desk is false, return false. 3. If desk has an field and desk is false, return false. 5. If as accessor descriptor desk is true, return false. V. If desk has a field and desk is false, return false. V. If desk has a field, perform typed array set element O. Numeric index desk 7. Return true. Return ordinary define own property O. P. Desk 0 4 5 4. The. If P is a string, then a let numeric index be canonical numeric index string P be. If numeric index is not undefined, then I return typed array get element O. Numeric index 2. Return ordinary get O. P. Receiver 0 4 5 5. The. If P is a string, then a let numeric index be canonical numeric index string P be. If numeric index is not undefined, then I have same value O. Receiver is true, then perform typed array set element O. Numeric index V. Return true. 2. If as valid integer index O. Numeric index is false, return true. Return ordinary set O. P. V. Receiver 96. ECMA International 2024 10456. P. The internal method of a typed array O takes argument P, a property key, and returns a normal completion containing a boolean. It performs the following steps when called. If P is a string, then a let numeric index be canonical numeric index string P be. If numeric index is not undefined, then if as valid integer index O. Numeric index is false, return true, else return false. 2. Return ordinary delete O. P 0 4 5 7. The internal method of a typed array O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Let tar record be capital M A K E capital T Y P E D capital A R R A Y capital W I T H capital B U F F E R capital W I T N E S O sexy ST. Let keys be a new empty list. If this typed array out of bounds tar record is false, then a let length be typed array length tar record be for each integer I such that 0 I length in ascending order do I append to string I to keys. For each own property key P of O such that P is a string and P is not an integer index. In ascending chronological order of property creation, do A append P to keys. For each own property key P of O such that P is a symbol. In ascending chronological order of property creation, do A append P to keys 6. Return keys 0, 4, 5, 8 typed array with buffer witness records. And typed array with buffer witness record is a record value used to encapsulate a typed array along with a cached byte length of the viewed buffer. It is used to help ensure there is a single shared memory read event of the byte length data block when the viewed buffer is a growable shared array buffer. Typed array with buffer witness records have the fields listed in Table 32. Table 32. Typed array with buffer witness record fields 0, 4, 5, 9, capital M, A, K, E, capital T, Y, P, E, D, capital A, R, R, A, Y, capital W, I, T, H, capital B, U, F, F, E, R, capital W, I, T, N, E, S, O, B, J, order. The abstract operation, capital M, A, K, E, capital T, Y, P, E, D, capital A, R, R, A, Y, capital W, I, T, H, capital B, U, F, F, E, R, capital W, I, T, N, E, S, takes arguments obj, a typed array, and order, sexcst or unordered, and returns a typed array with buffer witness record. It performs the following steps when called. Let buffer be obj if is detached buffer, buffer, is true. Then, a let byte length be detached. Field name, value, meaning, object, a typed array, the typed array whose buffer's byte length is loaded. Cached buffer byte length, a non-negative integer or detached. The byte length of the objects when the record was created. Copyright sign, ECMA International 2024 197. 3. Else, a let byte length be array buffer byte length, buffer, order, return the typed array with buffer witness record. OBJ, byte length 0, 4, 5, 1 0 typed array create, prototype. The abstract operation typed array create takes argument prototype, an object, and returns a typed array. It is used to specify the creation of new typed arrays. It performs the following steps when called. Let internal slots list be. Let A be make basic object. Internal slots list. Set A is specified in 1 0, 4, 5, 1. Set A is specified in 1 0, 4, 5, 2. Set A is specified in 1 0, 4, 5, 3. Set A is specified in 1 0, 4, 5, 6. Set A is specified in 1 0, 4, 5, 7, 0. Set A to prototype 1. Return A 0, 4, 5, 1 1 typed array byte length. tar record. The abstract operation typed array byte length takes argument tar record, a typed array with buffer witness record, and returns a non-negative integer. It performs the following steps when called. If this typed array out of bounds, tar record, is true, return 0. Let length be typed array length, tar record. If length equals 0, return 0. Let O be tar record. If O is not auto, return O. Let element size be typed array element size. O. Return length element size 0, 4, 5, 1 2 typed array length, tar record. The abstract operation typed array length takes argument tar record, a typed array with buffer witness record, and returns a non-negative integer. It performs the following steps when called. Assert is typed array out of bounds, tar record is false. Let O be tar record. If O is not auto, return O. Assert is fixed length array buffer. O is false. Let byte offset be O. Let element size be typed array element size. O. Let byte length be tar record. Assert byte length is not detached. Return floor byte length byte offset element size 0, 4, 5, 1, 3 is typed array, out of bounds, tar record. The abstract operation is typed array, out of bounds takes argument tar record, a typed array with buffer witness record, and returns a boolean. It checks if any of the object's numeric properties reference a value at an index not contained within the underlying buffer's bounds. It performs the following steps when called. 2. Let O be tar record. Let buffer byte length be tar record. 98. ECMA International 2024. 3. Assert. Is detached buffer O is true if and only if buffer byte length is detached. If buffer byte length is detached, return true. Let byte offset start be O if O is auto. Then, a let byte offset end be buffer byte length. Else, a let element size be typed array element size. O, be let byte offset end be byte offset start plus O element size. If byte offset start, buffer byte length or byte offset end, buffer byte length, return true. Note: 0 length typed arrays are not considered out of bounds. 0. Return false. 0, 4, 5, 1, 4 is valid integer index. O. Index. The abstract operation is valid integer index takes arguments so, a typed array, and an x, a number, and returns a boolean. It performs the following steps when called. If is detached buffer, O, is true, return false. If is integral number, int x, is false, return false. If index is -0, return false. Let tar record be capital M, A, K, E, capital T, Y, P, E, D, capital A, R, R, A, Y, capital W, I, T, H, capital B, U, F, F, E, R, capital W, I, T, N, E, S, O, unordered. Note: bounds checking is not a synchronizing operation when O's backing buffer is a growable shared array buffer. If is typed array out of bounds, tar record is true, return false. Let length be typed array length, tar record. If R, int x, 0 or R, int x, length, return false. Return true. 0, 4, 5, 1, 5 typed array get element. O. Index. The abstract operation typed array get element takes arguments so, a typed array, and an x, a number, and returns a number, a big int, or undefined. It performs the following steps when called. If is valid integer index, O, int x, is false, return undefined. Let offset be O. Let element size be typed array element size. O. Let byte index in buffer be R, int x, element size plus offset. Let element type be typed array element type. O. Return get value from buffer. O. Byte index in buffer. Element type. True. Unordered. 0, 4, 5, 1, 6 typed array set element. O. Int x. Value. The abstract operation typed array set element takes argument so, a typed array, int x, a number, and value, an ECMAScript language value, and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. If O is bigint, let num value be. To bigint, value. Otherwise, let num value be. To number, value. If is valid integer index, O, int x, is true, then a let offset be O, be let element size be typed array element size. O, C let byte index in buffer be R, int x, element size plus offset. D let element type be typed array element type. O, E perform set value in buffer. O, byte index in buffer, element type, num value. True, unordered, return unused. ECMA International 2024 199, 10, 4, 5, 1, 7 is array buffer view out of bounds. O. The abstract operation is array buffer view out of bounds takes argument O, a typed array or a data view, and returns a boolean. It checks if either any of a typed array's numeric properties or a data view object's methods can reference a value at an index not contained within the underlying data block's bounds. This abstract operation exists as a convenience for upstream specifications. It performs the following steps when called. If O has an internal slot, Then, a let view record B, capital M, A, K, E, capital D, A, T, A, capital V, I, E, W, capital W, I, T, H, capital B, U, F, F, E, R, capital W, I, T, N, E, S, S, capital R, O, sexy S, T, B. Return is view out of bounds. View record. Let tar record be capital M, A, K, E, capital T, Y, P, E, D, capital A, R, R, A, Y, capital W, I, T, H, capital B, U, F, F, E, R, capital W, I, T, N, E, S, O, sexy S, T. Return is typed array out of bounds. Tar record 0, 4, 6 module namespace exotic objects. A module namespace exotic object is an exotic object that exposes the bindings exported from an ECMAScript module. C16, 2, 3. There is a one-to-one correspondence between the string key-down properties of a module namespace exotic object and the binding names exported by the module. The exported bindings include any bindings that are indirectly exported using export items. Each string value down property key is the string value of the corresponding exported binding name. These are the only string keyed properties of a module namespace exotic object. Each such property has the attributes true, true, false. Module namespace exotic objects are not extensible. An object is a module namespace exotic object if its T and internal methods use the definitions in this section, and its other essential internal methods use the definitions found in 10.1. These methods are installed by module namespace create. Module namespace exotic objects have the internal slots defined in Table 33. Table 33. Internal slots of module namespace exotic objects. Internal slot. Type. Description. Module A. Module record. The module record whose exports this namespace exposes. Exports. A list of strings. A list whose elements are the string values of the exported names exposed as own properties of this object. The list is ordered as if an array of those string values had been sorted using %array prototype sort % using undefined as compare FN 1 0 4 6 1. The internal method of a module namespace exotic object takes no arguments and returns a normal completion containing null. It performs the following steps when called. Return null. 00 ECMA International 2024. Note this operation always appears to succeed, but it has no effect when attempting to write past the end of a typed array or to a typed array which is backed by a detached array buffer. 1 0 4 6 2. V. The internal method of a module namespace exotic object O takes argument V, an object or null, and returns a normal completion containing a boolean. It performs the following steps when called. 1. Return. Set immutable prototype O. V 0 4 6 3. The internal method of a module namespace exotic object takes no arguments and returns a normal completion containing false. It performs the following steps when called. Return false. 0 4 6 4. The internal method of a module namespace exotic object takes no arguments and returns a normal completion containing true. It performs the following steps when called. Return true. 0 4 6 5. P. The internal method of a module namespace exotic object O takes argument P, a property key, and returns either a normal completion containing either a property descriptor or undefined, or a throw completion. It performs the following steps when called. If P is a symbol, return ordinary get-own property O. P. Let exports be O. If exports does not contain P, return undefined. Let value be O. Return property descriptor value true, true, false. 0 4 6 6. P. Desk. The internal method of a module namespace exotic object O takes arguments P, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If P is a symbol, return ordinary define own property O P desk. Let current be O P. If current is undefined, return false. If desk has a field and desk is true, return false. If desk has an field and desk is false, return false. If is access a descriptor, desk is true, return false. If desk has a field and desk is false, return false. If desk has a field, return same value, desk, current, return true. 0, 4, 6, 7, P. The internal method of a module namespace exotic object O takes argument P, a property key, and returns a normal completion containing a boolean. It performs the following steps when called. If P is a symbol, return ordinary has property O P. Let exports be O. If exports contains P, return true, return false. ECMA International 2024 201 10 4 6 8. The if P is a symbol, then a return ordinary get O P. Receiver. Let exports be O. If exports does not contain P, return undefined. Let M be O. Let binding be M. Resolve export P. Assert binding is a resolved binding record. Let target module be binding. Assert target module is not undefined. If binding is namespace, then a return get module namespace target module 0. Let target env be target module 1. If target env is empty, throw a reference error exception. 2. Return target env get binding value, binding, true 0, 4, 6, 9. The return false 1, 0, 4, 6, 1, 0, P. The internal method of a module namespace exotic object O takes argument P, a property key, and returns a normal completion containing a boolean. It performs the following steps when called. If P is a symbol, then a return ordinary delete O P. Let exports be O. If exports contains P, return false, return true 0, 4, 6, 1, 1. The internal method of a module namespace exotic object O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Let exports be O. Let symbol keys be ordinary own property keys. O. Return the list concatenation of exports and symbol keys. Note resolve export is SID effect free. Each time this operation is called with a specific export name, resolve set pair as arguments, it must return the same result. An implementation might choose to pre-compute or cache the resolve export results for the of each module namespace exotic object. 02. ECMA International 2024 10 4 6 1 2 module namespace create module exports. The abstract operation module namespace create takes arguments module, a module record, and exports a list of strings, and returns a module namespace exotic object. It is used to specify the creation of new module namespace exotic objects. It performs the following steps when called. Assert module is empty. Let internal slots list be the internal slots listed in table 33. Let M be make basic object internal slots list. Set M's essential internal methods to the definitions specified in 10 4 6. Set M to module. Let sorted exports be a list whose elements are the elements of exports ordered as if an array of the same values had been sorted using %array prototype sort % using undefined as compare fn. Set M to sorted exports. Create own properties of M corresponding to the definitions in 28.3. Set module to M 0. Return M 0, 4, 7 immutable prototype exotic objects. An immutable prototype exotic object is an exotic object that has an internal slot that will not change once it is initialized. An object is an immutable prototype exotic object if its internal method uses the following implementation. Its other essential internal methods may use any implementation, depending on the specific immutable prototype exotic object in question. 0, 4, 7, 1. V. The internal method of an immutable prototype exotic object O takes argument V, an object or null, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Return Set immutable prototype O v10 4 7 to set immutable prototype O v. The abstract operation set immutable prototype takes arguments O, an object, and v, an object or null, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let current be O if same value v current is true. Return true, return false. 0.5 Proxy object internal methods and internal slots. A proxy object is an exotic object whose essential internal methods are partially implemented using ECMAScript code. Every proxy object has an internal slot called the value of is an object, called the proxy's handler object, or null. Methods, see Table 34, of a handler object may be used to augment the implementation for one or more of the proxy object's internal methods. Every proxy object also has an internal. Note, unlike other exotic objects, there is not a dedicated creation abstract operation provided for immutable prototype exotic objects. This is because they are only used by %object prototype % and by host environments. And in host environments, the relevant objects are potentially exotic in other ways and thus need their own dedicated creation operation. ECMA International 2024 203. Slot called whose value is either an object or the null value. This object is called the proxy's target object. An object is a proxy exotic object if its essential internal methods, including and, if applicable, use the definitions in this section. These internal methods are installed in proxy create. Table 34. Proxy handler methods. Internal method. Handler method. Get prototype of set prototype of is extensible. Prevent extensions. Get own property descriptor. Define own property. Has get set delete property. Own property keys. Call apply construct. When a handler method is called to provide the implementation of a proxy object internal method, the handler method is passed the proxy's target object as a parameter. A proxy's handler object does not necessarily have a method corresponding to every essential internal method. Invoking an internal method on the proxy results in the invocation of the corresponding internal method on the proxy's target object if the handler object does not have a method corresponding to the internal trap. The and internal slots of a proxy object are always initialized when the object is created and typically may not be modified. Some proxy objects are created in a manner that permits them to be subsequently revoked. When a proxy is revoked, its and internal slots are set to null, causing subsequent invocations of internal methods on that proxy object to throw a type error exception. Because proxy objects permit the implementation of internal methods to be provided by arbitrary ECMAScript code, it is possible to define a proxy object whose handler methods violates the invariants defined in 6.1.7.3. Some of the internal method invariants defined in 6.1.7.3 are essential integrity invariants. These invariants are explicitly enforced by the proxy object internal methods specified in this section. An ECMAScript implementation must be robust in the presence of all possible invariant violations. In the following algorithm descriptions, assume O is an ECMAScript proxy object, P is a property key value, V is any ECMAScript language value, and desc is a property descriptor record. O4 copyright sign. ECMA International 2024 1051. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing either an object or null, or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Get prototype of. If trap is undefined, then a return target. Let handler proto be. Call. Trap. Handler. Target. If handler proto is not an object and handler proto is not null, throw a type error exception. Let extensible target be. Is extensible. Target 0. If extensible target is true, return handler proto 1. Let target proto be target 2. If same value, handler proto target prota is false. Throw a type error exception. 3. Return handler prota 0, 5, 2. V. The internal method of a proxy exotic object O takes argument V, an object or null, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Set prototype of if trap is undefined. Then a return target. V. Let boolean trap result be to boolean. Call. Trap. Handler. Target. V. If boolean trap result is false, return false. Let extensible target be. Is extensible. Target 0. If extensible target is true, return true. 1. Let target prota be target. 2. If same value, V, target prota, is false, throw a type error exception. 3. Return true. Note for proxy objects enforces the following invariants. The result of must be either an object or null. If the target object is not extensible, applied to the proxy object must return the same value as applied to the proxy object's target object. Note for proxy objects enforces the following invariants. The result of is a boolean value. If the target object is not extensible, the argument value must be the same as the result of get prototype of applied to target object. ECMA International 2024 205 1053. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler is extensible. If trap is undefined, then a return is extensible. Target. Let boolean trap result be to boolean. Call. Trap. Handler. Target. Let target result be is extensible. E. Target. If boolean trap result is not target result, throw a type error exception. 0. Return boolean trap result. 0, 5, 4. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Prevent extensions. If trap is undefined, then a return target. Let boolean trap result be to boolean. Call. Trap. Handler. Target. If boolean trap result is true, then a let extensible target be is extensible. Target be. If extensible target is true, throw a type error exception. Return boolean trap result. 0, 5, 5. P. The internal method of a proxy exotic object O takes argument P, a property key, and returns either a normal completion containing either a property descriptor or undefined, or a throw completion. It performs the following steps when called. Note for proxy objects enforces the following invariants. The result of is a boolean value. Applied to the proxy object must return the same value as applied to the proxy object's target object with the same argument. Note for proxy objects enforces the following invariants. The result of is a boolean value. Applied to the proxy object only returns true if applied to the proxy object's target object is false. 2. Perform. Validate non-revoke proxy O. Let target be O. 06. ECMA International 2024. 3. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Get own property descriptor. If trap is undefined, then a return target. P. Let trap result obj be. Call. Trap. Handler. Target. P. If trap result obj is not an object, result obj is not undefined, throw a type error exception. Let target.
I forgot about the keyword int. When there's a no signed or unsigned before it, and it's just a int, and it's like assumed to be signed if there's no sign or unsigned specifier attribute, whatever, in front of the type, whatever. So after I replace all these, I think I'm done with the JavaScript files. I'm gonna have to like find everywhere, see if there's any place where it's an int, just without the sign in front of it. This would be really like annoying to find, because looking for like unsigned or signed in, there's like a space between, so you do Control F, it's easier to find. But if it's int, you might have to do like Control F on the word int, and then a space, and then also int, and then a tab, and then int, and then some other like, maybe like a / in case like I type somewhere the word int, and then there's like a comment after it. So I'm gonna have to like search for all those after I don't know, I'm trying to like replace stuff now. And it didn't build. Oh, I like missed something in the define guard. I have to like toggle whatever. It's not a issue, it's whatever. I'll like do that to build. Get it to build, and then I'll place the types, and I'll check for where it's just in without a sign and sign.
P, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Define property. If trap is undefined, then a return target. P. Desk. Let desk obj be from property descriptor. Desk. Let boolean trap result be to boolean. Call. Trap. Handler. Target. P. Desk obj. If boolean trap result is false, return false. 0. Let target desk be target. P. ECMA International 2024 207. 11. Let extensible target be. Is extensible target 2. If desk has a field and desk is false, then a let setting config false be true. 13. Else a let setting config false be false. 4. If target desk is undefined, then A. If extensible target is false, throw a type error exception. B. If setting config false is true, throw a type error exception. 5. Else A. If is compatible property descriptor, extensible target, desk, target desk, is false, throw a type error exception. B. If setting config false is true and target desk is true, throw a type error exception. C. If is data descriptor, target desk, is true, target desk is false, and target desk is true, then I. If desk has a field and desk is false, throw a type error exception. 6. Return true. Note for proxy objects enforces the following invariants. The result O. F is a Boolean value. A property cannot be added. If the target object is not extensible, a property cannot be non-configurable, unless there exists a corresponding non-configurable own property of the target object. A non-configurable property cannot be non-writable, unless there exists a corresponding non-configurable non-writable own property of the target object. If a property has a corresponding target object property, then applying the property descriptor of the property to the target object using will not throw an exception. 0, 5, 7. P. The internal method of a proxy exotic object O takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler has. If trap is undefined, then a return target. P. Let boolean trap result be to boolean. Call. Trap. Handler. Target. P. If boolean trap result is false, then a let target desk be target. P. If target desk is not undefined, then I. If target desk is false, Throw a type error exception. 2. Let extensible target be. Is extensible target. 3. If extensible target is false, throw a type error exception. Return Boolean trap result. 08. ECMA International 2024. Note for proxy objects enforces the following invariance. The result of is a Boolean value. A property cannot be reported as non-existent if it exists as a non-configurable own property of the target object. A property cannot be reported as non-existent if it exists as a known property of the target object, and the target object is not extensible. 0, 5, 8. The perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Get. If trap is undefined, then a return target. Let trap result be. Call. Trap. Handler. Target. P. Receiver. Let target desk be target. P. If target.
Now it's rebuilding. It's rebuilding. And I'm gonna like replace whatever, all the unsigned types in the JavaScript files first. And then I'll do the C files.
The corresponding target object property if the target object property is a non-writable, non-configurable own data property. The value reported for a property must be undefined if the corresponding target object property is an unconfigurable own accessor property that has undefined as its 0, 5, 9. The perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Set. If trap is undefined, then a return target. Let Boolean trap result be to Boolean. Call. Trap. Handler. Target. P. V. Receiver. If Boolean trap result is false, return false. Let target desk be target. P. 0. If target desk is not undefined and target desk is false, then ECMA International 2024 209. If is data descriptor, target desk, is true and target desk is false, then I if same value, V, target desk, is false. Throw a type error exception. B if is accessor descriptor, target desk, is true, then I if target desk 1. Return true. Note, the result of cannot change the value of a property to be different from the value of the corresponding target object property if the corresponding target object property is a non-writable, non-configurable own data property. Cannot set the value of a property if the corresponding target object property is a non-configurable own accessor property that has undefined as its 0, 5, 1, 0. P. The internal method of a proxy exotic object O takes argument P, a property key, and returns either a normal completion containing a Boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Delete property. If trap is undefined, then a return target. P. Let Boolean trap result be to Boolean. Call. Trap. Handler. Target. P. If Boolean trap result is false, return false. Let target desk be target, comma P. 0. If target desk is undefined, return true. 1. If target desk is false, throw a type error exception. 2. Let extensible target be. Is extensible target. 3. If extensible target is false, throw a type error exception. 4. Return true. Note for proxy objects enforces the following invariance. The result of is a Boolean value. A property cannot be reported as deleted if it exists as a non-configurable own property of the target object. A property cannot be reported as deleted if it exists as a known property of the target object and the target object is non-extensible. 0, 5, 1, 1. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing a list of property keys or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Own keys. 10. ECMA International 2024. 6. If trap is undefined, then a return target. Let trap result array be. Call. Trap. Handler. Target. Let trap result be. Create list from array like trap result array, string, symbol. If trap result contains any duplicate entries, throw a type.
This finding and replacing is getting really old. Like, really old. I'm tired of doing this. This is so boring.
Keys. 3. Assert. Target keys contains no duplicate entries. 4. Let target configurable keys be a new empty list. 5. Let target non-configurable keys be a new empty list. 6. For each element key of target keys, do a let desk be target key be if desk is not undefined and desk is false. Then I append key to target non-configurable keys CL.
There's 1024 and I gotta sort out in this file. I'll be back. I can't. This is so boring.
Checked result keys does not contain key. Throw a type error exception. Be remove key from unchecked result keys. 0. If extensible target is true, return trap result. 1. For each element key of target configurable keys, do. If unchecked result keys does not contain key, throw a type error exception. Be remove key from unchecked result keys. 2. If unchecked result keys is not empty, throw a type error exception. 3. Return trap result. Note for proxy objects enforces the following invariance. The result of is a list. The returned list contains no duplicate entries. The type of each result list element is either string or symbol. The result list must contain the keys of all non-configurable own properties of the target object. If the target object is not extensible, then the result list must contain all the keys of the own properties of the target object and no other values. 0, 5, 1, 2. This arguments list. The internal method of a proxy exotic object O takes arguments this argument, an ECMAScript language value, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Apply. If trap is undefined, then a return. Call. Target. This argument. Arguments list. Let array be create array from list. Arguments list. Return. Call. Trap. Handler. Target. This argument. Array. Note a proxy exotic object only has an internal method if the initial value of its internal slot is an object that has an internal method. ECMA International 2024 211. The 10th of May 2013. Arguments list. New target. The internal method of a proxy exotic object O takes arguments list. A list of ECMAScript language values. A new target. A constructor. And returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let target be O. Assert. Is constructor. Target. Is true. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Construct. If trap is undefined, then a return. Construct. Target. Arguments list. New target. Let array be create array from list. Arguments list. Let new obj be. Call. Trap. Handler. Target. Array. New target. 0. If new obj is not an object, throw a type error exception. 1. Return new obj. Note 2 for proxy objects enforces the following invariance. The result of must be an object. 0. 5. 1 for validate non-revoke proxy. Proxy. The abstract operation validate non-revoke proxy takes argument proxy, a proxy exotic object, and returns either a normal completion containing unused or a throw completion. It throws a type error exception if proxy has been revoked. It performs the following steps when called. If proxy is null, throw a type error exception. Assert proxy is not null. Return unused. 0, 5, 1, 5 proxy create. Target handler. The abstract operation proxy create takes arguments target, an ECMAScript language value, and handler, an ECMAScript language value, and returns either a normal completion containing a proxy exotic object or a throw completion. It is used to specify the creation of new proxy objects. It perfo RMS the following steps when called. If target is not an object, throw a type error exception. If handler is not an object, throw a type error exception. Let P be make basic object. Set P's essential internal methods, except friend, to the definitions specified in 10.5. If is callable, target, is true, then A set P is specified in the 10th of May 2012. B if is constructor, target, is true, then I set P is specified in the 10th of May 2013. Set P to target, set P to handler, return P, 12, ECMA International 2024. Note 1 A proxy exotic object only has an internal method if the initial value of its internal slot is an object that has an internal method. 11 ECMAScript language. Source text. 1.1 Source text syntax. Source character. Any Unicode code point. ECMAScript source text is a sequence of Unicode code points. All Unicode code point values from U+0000 to U+10FF, including surrogate code points, may occur in ECMAScript source text where permitted by the ECMAScript grammars. The actual encodings used to store and interchange ECMAScripts.
I've been like finding replacing stupid type words for like however many days.
Performing ECMAScript implement.
I think it was like sorting folders too before that. I don't remember. Whatever for the last 7 days. It's so boring. I can't take it. I'm going to try to like focus and just get this done real fast, but this is just so boring. So freaking boring. I'm just gonna keep going. I'm so bored though. Like, I'm so freaking bored. Back to finding and replacing. I go. Take this. This is so repetitive. It's the most repetitive thing ever. Alright, I think I'm done complaining for now. I'll complain later. I think got that on my system. It doesn't make any difference. I still have to physically go through and find and replace these all still. I should like go over the last file again and tag the ones that are comments as comments, so like the list of how many there are will be smaller. So I'll do that and then I'll get back to this file. There's 1024. It's like nice power of 2 number. Pretty sure it's power of 2. I'm too tired. I just don't even know I'm so tired. Ask chatbot. I'm so bored. hate this stupid zoom tool. No, 1024. I'm listening on the right screen. Right here. I only have this valves button. It's 1024. I hate this magnifier. Cheese and rice. I can't even get it. There we go. Oh, no. It moved again. Doesn't really. This tool sucks really bad. It sucks, you know, it just freaking sucks. I need to get it together and finish this stuff up.
String, a string, and position, a non-negative integer, and returns a record with fields, a code point, a positive integer, and a boolean. It interprets string as a sequence of UTF-16 encoded code points, as described in 6.1.4, and reads from it a single code point starting with the code unit at index position. It performs the following steps when called. Let size be the length of string. Assert position 0 and position size. Let first be the code unit at index position within string. Let CP be the code point whose numeric value is the numeric value of first. If a first is neither a leading surrogate nor a trailing surrogate, then I return the record CP1.
Okay, so AI. Does Google call their AI BART still or something? Was it BERT? I don't know, stupid. I guess generative AI says 1024. It's power of 2. I think my brain's gonna shut down. I'm so bored. Oh, I'm so bored. Okay, I'm gonna shut up and keep finding and replacing.
A string, and returns a list of code points. It returns the sequence of Unicode code points that results from interpreting string as UTF-16 encoded Unicode text as described in 6.1.4. It performs the following steps when called. Let code points be a new empty list. Let size be the length of string. Let position be 0. Repeat. While position, size. Let CP be code point at string. Position be append CP to code points. C set position to position plus CP. Return code points. 14. ECMA International 2024. 111. 6 static semantics. Parse text. Source text. Goal symbol. The abstract operation parse text takes arguments source text, a sequence of Unicode code points, and goal symbol, a non-terminal in one of the ECMAScript grammars, and returns a parse node or a non-empty list of syntax error objects. It performs the following steps when called. Attempt to parse source text using goal symbol as the goal symbol, and analyze the parse result for any early error conditions. Parsing and early error detection may be interleaved in an implementation-defined manner. If the parse succeeded and no early errors were found, return the parse node, an instance of goal symbol, at the root of the parse tree resulting from the parse. Otherwise, return a list of one or more syntax error objects representing the parsing errors and/or early errors. If more than one parsing error or early error is present, the number and ordering of error objects in the list is implementation defined, but at least one must be present. Note to see also clause 17. 1.2 Types of source code. There are 4 types of ECMAScript code. Global code is source text that is treated as an ECMAScript script. The global code of a particular script does not include any source text that is passed as part of a function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, async arrow function, class declaration, or class expression. Eval code is the source text supplied to the built-in eval function. More precisely, if the parameter to the built-in eval function is a string, it is treated as an ECMAScript script. The eval code for a particular invocation of eval is the global code portion of that script. Function code is source text that is parsed to supply the value of the and internal slots, C 10.2, of an ECMAScript function object. The function code of a particular ECMAScript function does not include any source text that is parsed as the function code of a nested function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, async arrow function, class declaration, or class expression. In addition, if the source text referred to above is parsed as the formal parameters and function body of a function declaration or function expression, the formal parameters and generator body of a generator declaration or generator expression, the formal parameters and async function body of an async function declaration or async function expression, or the formal parameters and async generator body of an async generator declaration or async generator expression, then the source text matched by the binding identifier, if any of that declaration or expression is also included in the function code of the corresponding function. Module code is source text that is code that is provided as a module body. It is the code that is directly evaluated when a module is initialized. The module code of a particular module does not include any source. Note 1. Consider a text that has an early error at a particular point, and also a syntax error at a later point. An implementation that does a parse followed by an early errors parse might report the syntax error and not proceed to the early errors parse. An implementation that interleaves the two activities might report the early error and not proceed to find the syntax error. A third implementation might report both errors. All of these behaviors are conformant. Copyright sign, ECMA International 2024 215. Text that is parsed as part of a nested function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, async arrow function, class declaration, or class expression. Note 1. Function code is generally provided as the bodies of function definitions, 15.2, arrow function definitions, 15.3, method definitions, 15.4, generator function definitions, 15.5, async function definitions, 15.8, async generator function definitions, 15.6, and async arrow functions, 15.9. Function code is also derived from the arguments to the function constructor, 20, 2, 1, 1, the generator function constructor, 27, 3, 1, 1, and the async function constructor, 27, 7, 1, 1. Note 2. The practical effect of including the binding identifier in function code is that the early errors for strict mode code are applied to a binding identifier that is the name of a function whose body contains a use strict directive, even if the surrounding code is not strict mode code. 1, 2, 1 directive prologues and the use strict directive. A directive prologue is the longest sequence of expression statements occurring as T. The initial statement list items or module items of a function body, a script body, or a module body, and where each expression statement in the sequence consists entirely of a string literal token followed by a semicolon. The semicolon may appear explicitly or may be inserted by automatic semicolon insertion. 12.10. A directive prologue may be an empty sequence. A use strict directive is an expression statement in a directive prologue whose string literal is either of the exact code point sequences use strict or use strict. A use strict directive may not contain an escape sequence or line continuation. A directive prologue may contain more than one use strict directive. However, an implementation may issue a warning if this occurs. 1, 2. Strict mode code. An ECMAScript syntactic unit may be processed using either unrestricted or strict mode syntax and semantics. 4, 3, 2. Code is interpreted as strict mode code in the following situations. Global code is strict mode code if it begins with a directive prologue that contains a use strict directive. Module code is always strict mode code. All parts of a class declaration or a class expression are strict mode code. Eval code is strict mode code if it begins with a directive prologue that contains a use strict directive, or if the call to eval is a direct eval that is contained in strict mode code. Function code is strict mode code if the associated function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, or async arrow function is contained in strict mode code, or if the code that produces the value of the function's internal slot begins with a directive prologue that contains a use strict directive. Function code that is supplied as the arguments to the built-in function, generator, async function, and async generator constructors is strict mode code if the last argument is a string that, when processed, is a function body that begins with a directive prologue that contains a use strict directive. ECMAScript code that is not strict mode code is called non-strict code. 16. Copyright sign. ECMA International 2024. Note the expression statements of a directive prologue are evaluated normally during evaluation of the containing production. Implementations may define implementation-specific meanings for expression statements which are not a use strict directive and which occur in a directive prologue. If an appropriate notification mechanism exists, an implementation should issue a warning if it encounters in a directive prologue an expression statement that is not a use strict directive and which does not have a meaning defined by the implementation. 1, 2, 3 non-ECMAScript functions. An ECMAScript implementation may support the evaluation of function exotic objects whose evaluative behavior is expressed in some host-defined form of executable code other than ECMAScript source text. Whether a function object is defined within ECMAScript code or as a built-in function is not observable from the perspective of ECMAScript code that calls or is called by such a function object. 2. ECMAScript language. Lexical grammar. The source text of an ECMAScript script or module is first converted into a sequence of input elements, which are tokens, line terminators, comments, or white space. The source text is scanned from left to right, repeatedly taking the longest possible sequence of code points as the next input element. There are several situations where the identification of lexical input elements is sensitive to the syntactic grammar context that is consuming the input elements. This requires multiple goal symbols for the lexical grammar. The input element #bang or regexp goal is used at the start of a script or module. The capital I, N, P, U, T, capital E, L, E, M, E, N, T, capital R, E, G, capital E, X, P, capital O, R, capital T, E, M, P, L, A, T, E, capital T, A. Goal is used in syntactic grammar contexts where a regular expression literal, a template middle, or a template tail is permitted. The input element regexp goal symbol is used in all syntactic grammar contexts where a regular expression literal is permitted but neither a template middle nor a template tail is permitted. The input element template tail goal is used in all syntactic grammar contexts where a template middle or a template tail is permitted but a regular expression literal is not permitted. In all other contexts, input element div is used as the lexical goal symbol. Note the use of multiple lexical goals ensures that there are no lexical ambiguities that would affect automatic semicolon insertion. For example, there are no syntactic grammar contexts where both a leading division or division assignment and a leading regular expression literal are permitted. This is not affected by semicolon insertion, see 12.10, in examples such as the following. App equals b high g exec, c map, d, where the first non-white space, non-comment code point after a line terminator is u plus 002f, solidus, and the syntactic context allows division or division assignment. No semicolon is inserted at the line terminator. That is, The above example is interpreted in the same way as up equals b high g exec, CMAP, d syntax, input element div, white space, line terminator comment token div punctuator right brace punctuator, input element regi xp, white space, line terminator comment token right brace punctuator regular expression literal, ECMA International 2024 217, capital I, N, P, U, T, capital E, L, E, M, E, N, T, capital R, E, G, capital E, X, P, capital O, R, capital T, E, M, P, L, A, T, E, capital T, A, white space, line terminator comment token regular expression literal template substitution tail, input element template tail, white space, line terminator comment token div punctuator template substitution tail, input element hashbang or regi xp, white space, line terminator comment token hashbang comment regular expression literal 2.1 Unicode format control characters. The Unicode format control characters, that is, the characters in category CF in the Unicode character database such as left to right mark or right to left mark control codes used to control the formatting of a range of text in the absence of higher level protocols for this, such as markup languages. It is useful to allow format control characters in source text to facilitate editing and display. All format control characters may be used within comments, and within string literals, template literals, and regular expression literals, U plus 200C, 0 width non-joiner, and U plus 200D, 0 width joiner, are format control characters that are used to make necessary distinctions when forming words or phrases in certain languages. In ECMAScript source text, these code points may also be used in an identifier name after the first character. U plus F, 0 width no break space, is a format control character used primarily at the start of a text to mark it as Unicode and to allow detection of the text's encoding and byte order. ZWMBSP. Characters intended for this purpose can sometimes also appear after the start of a text. For example, as a result of concatenating files. In ECMAScript source text, ZWMBSP, code points are treated as white space characters. See 12.2. The special treatment of certain format control characters outside of comments, string literals, and regular expression literals is summarized in Table 35. Table 35. Format control code point usage. Code point name abbreviation usage U plus 200C 0 width non-joiner ZWNJ identifier part U plus 200D 0 width joiner ZWJ identifier part U plus FF 0 width no break space ZWNBSP white space 218. ECMA International 2024. 12.2 white space code points are used to improve source text readability and to separate tokens, indivisible lexical units, from each other, but are otherwise insignificant. White space code points may occur between any two tokens and at the start or end of input. White space code points may occur within a string literal, a regular expression literal, a template, or a template substitution tail where they are considered significant code points forming part of a literal value. They may also occur within a comment, but cannot appear within any other kind of token. The ECMAScript white space code points are listed in Table 36. Table 36. White space code points. Code points. Name. Abbreviation. U plus 0009. Character tabulation. Tab. U plus 000B. Line tabulation. VT. U plus 000C. Form feed. FF, U plus FF, 0 width no break space, ZWNBSP, any code point in general category space separator, USP, note 1 U plus 0020, space, and U plus 00A0, no break space. Code points are part of USP syntax. Note 2, other than for the code points listed in Table 36. ECMAScript white space intentionally excludes all code points that have the Unicode white space property but which are not classified in general category space separator. ZEDS 2.3 white space tab VT FF ZWMBSP OSP line terminators like white space code point TS. Line terminator code points are used to improve source text readability and to separate tokens, indivisible lexical units, from each other. However, unlike white space code points, line terminators have some influence over the behavior of the syntactic grammar. In general, line terminators may occur between any two tokens, but there are a few places where they are forbidden by the syntactic grammar. Line terminators also affect the process of automatic semicolon insertion. 12.10. A line terminator cannot occur within any token except a string literal, template, or template substitution tail, LF. And CR line terminators cannot occur within a string literal token except as part of a line continuation. A line terminator can occur within a multi-line comment but cannot occur within a single line comment. Line terminators are included in the set of white space code points that are matched by the S-class in regular expressions. ECMA International 2024-219. The ECMAScript line terminator code points are listed in Table 37. Table 37. Line terminator code points. Code point. Unicode name. Abbreviation. U+000. Line feed. LF. U+000D. Carriage return CR. U+2028. Line separator. LS. U+2029. Paragraph separator. PS. Only the Unicode code points in Table 37 are treated as line terminators. Other new line or line breaking Unicode code points are not treated as line terminators but are treated as white space if they meet the requirements listed in Table 36. The sequence CR, LF, is commonly used as a line terminator. It should be considered a single source character for the purpose of reporting line numbers. Syntax: line terminator, LF, CRLS, PS, line terminator sequence, LF, CR look ahead, LF. LS, PS, CRLF. 2.4 comments. Comments can be either single or multi-line. Multi-line comments cannot nest, because a single line comment can contain any Unicode code point except a line terminator code point, and because of the general rule that a token is always as long as possible. A single line comment always consists of all code points from the marker to the end of the line. However, the line terminator at the end of the line is not considered to be part of the single line comment. It is recognized separately by the lexical grammar and becomes part of the stream of input elements for the syntactic grammar. This point is very important because it implies that the presence or absence of single line comments does not affect the process of automatic semicolon insertion. See 12.10. Comments behave like white space and are discarded except that if a multi-line comment contains a line terminator code point, then the entire comment is considered to be a line terminator for purposes of parsing by the syntactic grammar. Syntax: comment, multi-line comment, single line comment. 20. ECMA International 2024. Multi-line comment charsopt, multi-line comment chars, multi-line not ast, risk char multi-line comment charsopt, post asterisk comment charsopt, post asterisk comment chars, capital M, U, L, T, I, capital L, I, N, E, capital N, O, T, capital F, O, R, W, A, R, D, capital S, L, A, S, H, capital O, R, capital A, S, T, E, multi-line comment charsopt post asterisk comment charsopt, multi-line not asterisk char, source character but not, capital M, U, L, T, I, capital L, I, N, E, capital N, O, T, capital F, O, R, W, A, R, D, capital S, L, A, S, H, capital O, R, capital A, S, T, E, source character but not one of all, single line comment charsopt, single line comment chars, single line comment char, single line comment char sopt, single line comment char, source character but not line terminator. A number of productions in this section are given alternative definitions in section B. 1.112.5 Hashbang comments. Hashbang comments are location sensitive and like other types of comments are discarded from the stream of input elements for the syntactic grammar. Syntax. Hashbang comment. Single line comment charsoft. 2.6 tokens syntax. Common token. Identifier name. Private identifier punctuator numeric literal string literal template. Note the div punctuator. Regular expression literal. Right brace punctuator. And template substitution. Tail productions derive additional tokens that are not included in the common token production. ECMA International 2024 221. 12.7 Names and keywords. Identifier name and reserved word are tokens that are interpreted according to the default identifier syntax given in Unicode Standard Annex number 31. Identifier and pattern syntax, with some small modifications. Reserved word is an enumerated subset of identifier name. The syntactic grammar defines identifier as an identifier name that is not a reserved word. The Unicode identifier grammar is based on character properties specified by the Unicode standard. The Unicode code points in the specified categories in the latest version of the Unicode standard must be treated as in those categories by all conforming ECMAScript implementations. ECMAScript implementations may recognize identifier code points defined in later editions of the Unicode standard. Syntax. Private identifier. Identifier name. Identifier name. Identifier start. Identifier name. Identifier part. Identifier start. Identifier start char. Unicode escape sequence. Identifier part. Identifier part char. Unicode escape sequence. Identifier start char. Unicode ID start. Underscore identifier part char. Unicode ID continue. ZWNJ. ZWJ. Assign letter. One of A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z, capital A, capital B, capital C, capital D, not but Gustavwexes. Unicode ID start. Any Unicode code point with the Unicode property ID start. Unicode ID continue. Any Unicode code point with the Unicode property ID continue. The definitions of the non-terminal Unicode escape sequence is given in 1.2.9.4. Note 1. This standard specifies specific code point additions. U+0024, $, and U+005F. Low line are permitted anywhere in an identifier name, and the code points U+200C, 0 width non-joiner, and U+200D, 0 width joiner. Are permitted anywhere after the first code point of an identifier name. 22. Copyright sign. ECMA International 2024. Note 2. The non-terminal identifier part derives via Unicode ID continue. 2.7. 1. Identifier names. Unicode escape sequences are permitted in an identifier name, where they contribute a single Unicode code point equal to the identifier code point of the Unicode escape sequence. The preceding the Unicode escape sequence does not contribute any code points. A Unicode escape sequence cannot be used to contribute
out of 1024. I replaced ones that are like in comments, whatever.
character it contributes.
So I got 481 left to check. I don't think any of these relate to the address, whatever. So I think I can just go through and like replace them all with the number tag type. So I'm gonna like check each of them one by one, and then I'll do like replace all, so I don't have to click on every single one of them. I still have to check because there could be like one or two of them possible places where it's actually an address and not a number that needs to be replaced with that type tag, whatever. And then I gotta like rebuild the 4 files, paste them back, run the compiler, if it's good, I don't have to like undo everything I did. I won't undo. I'm gonna close everything, use a backup. I'm not even gonna bother to like find the one file or two files I did. I'll just find all the files, paste again, restart, whatever. So after this, all I got is the C files. I'm gonna have to go through those. I'm gonna look up the OpenGL stuff later for like, or I might not, I don't know. I'm gonna tag these for and then do whatever else. I'm so bored.
Piecewise over the following productions. Identifier start. Identifier start char. Return the code point matched by identifier start char. Note 3. The sets of code points with Unicode properties ID start and ID continue include, respectively, the code points with Unicode properties other ID start and other ID continue. ECMA International 2024 223. Identifier part. Identifier part char. Return the code point matched by identifier part char. Unicode escape sequence. U hex 4 digits. Return the code point whose numeric value is the NV of hex 4 digits. Unicode escape sequence. U code point. Return the code point whose numeric value is the NV of code point. 2, 7. 2 keywords and reserved words. A keyword D is a token that matches identifier name, but also has a syntactic use. That is, it appears literally, in a fixed-width font, in some syntactic production. The keywords of ECMAScript include if, while, async, await, and many others. A reserved word is an identifier name that cannot be used as an identifier. Many keywords are reserved words, but some are not, and some are reserved only in certain contexts. If and while a reserved word's await is reserved only inside async functions and modules, async is not reserved. It can be used as a variable name or statement label without restriction. This specification uses a combination of grammatical productions and early error rules to specify which names are valid identifiers and which are reserved words. All tokens in the reserved word list below, except for await and yield, are unconditionally reserved. Exceptions for await and yield are specified in 13.1, using parameterized syntactic productions. Lastly, several early error rules restrict the set of valid identifiers. C13, 1, 1, 1, 4, 3, 1, 1, 1, 4, 7, 5, 1, and 1, 5, 7, 1. In summary, there are 5 categories of identifier names: those that are always allowed as identifiers, and are not keywords, such as math, window, to string, and those that are never allowed as identifiers, namely the reserved words listed below except await and yield. Those that are contextually allowed as identifiers, namely await and yield. Those that are contextually disallowed as identifiers, in strict mode code. Let, static, implements, interface, package, private, protected, and public. Those that are always allowed as identifiers, but also appear as keywords within certain syntactic productions, at places where identifier is not allowed, as async.
I have reference counters, whatever, some things, and I don't know. I don't know, I'm like hoping there's no addresses in this file. If there is, it makes stuff more complicated later. I think it's all like number types, but there's macros that access the address. I'm hoping all of them, or most of the address accesses are through macros, so I don't have to pick through the code line by line, which I have to anyways. But if it's all like wrapped, most of it, it's at least less in the code or whatever. I have a feeling that most of it might be, but there's like probably like a couple exceptions where I don't know. Just gotta make sure I don't miss any of those like couple places where it's like an address and not a number. Because I like most of the time I like in this program at least I just like cast the address as a number and then use it as a number. And it's hard to like tell the difference because it doesn't have a type at that point. It's just like a number or whatever. I don't know, it's something I look out for. This is so boring.
One of, comma equals, equals 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 plus, percent plus plus, and equals plus equals 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 percent equals 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 and equals 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 and equals 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 equals. Div punctuator equals sign right brace punctuator 2.9 literals 2 9 1 null literals syntax null literal null ECMA International 2024 225 1 2 9 2 Boolean literals syntax Boolean literal true false 2 9 3 numeric literals syntax numeric literal separator numeric literal decimal big integer literal non-decimal integer literal plus sep non-decimal integer literal plus sep begin literal suffix legacy octal integer literal decimal big integer literal 0 big int literal suffix non-zero digit decimal digits plus sep oct begin literal suffix non-zero digit numeric literal separator decimal digits plus sep begin literal suffix non-decimal integer literal sep binary integer literal sep octal integer literal sep hex integer literal sep begin literal suffix n decimal literal decimal integer literal decimal digits plus sep opt exponent part plus sep opt decimal digits plus sep exponent part plus sep.
It's going to be brutally painful to figure out where it's an integer and where it's an address. Oh my god. Everything is a macro. I don't even know what type things are. I think I'm gonna like skip all the ones I'm not sure of to get them later or whatever. This is a lot more difficult to convert than I was assuming it would be.
Sep binary digit sep binary digit plus sep binary digits plus sep numeric literal separator binary digit 1 of 0 1 octal integer literal sep 0 octal digits sep 0 octal digits sep octal digits sep octal digit sep octal digit.
A lot more difficult as in like I should probably like just rewrite the whole thing. It doesn't take that much work to like I'm just whatever. I'm not gonna rewrite it. I just gotta carefully update it.
Capital I N T E G E R capital L non-octal digit non-octal decimal integer literal decimal digit capital L E G A C Y, capital O, C, T, A, L, capital L, I, K, E, capital D, E, C, I, M, A, L, capital I, N, T, E, G, E, R, capital L, 0 octal digit, capital L, E, G, A, C, Y, capital O, C, T, A, L, capital L, I, K, E, capital D, E, C, I, M, A, L, capital I, N, T, E, G, E, R, capital L, octal digit, 1 of 1,234,567, non-octal digit, 1 of 89, ECMA International 2024 227, hex integer literal, SEP, 0x hex digits SEP, 0x hex digits SEP, hex digits, SEP, hex digit SEP, hex digit, plus SEP, hex digits, plus SEP, numeric literal separator hex digit, 1 of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, abdef A, B, C, D, E, F. The source character immediately following a numeric literal must not be an identifier start or decimal digit. 2, 9.
Oh, this is so complicated. This sucks. Oh my god, this is work. It's all bit shift operations. Why the fuck did I do that? The compiler is absolute garbage. If I multiply something by 2, the compiler will like put multiply by 2. It'll use a multiply instruction. So I like use the left shift to multiply by 2 and like whatever it is, like if it's like a simple number, I just did bit operations. It made a huge difference in speed. I'm not gonna like sort through I'm probably gonna have to like make comments in between to like say like this left shift is multiplying, this right shift is dividing, this is doing this. That's what I'll do. Later on I'll go through line by line. I'll tag it like that. That way I don't change the code. I don't add any parentheses, so nothing will break. I'll just I'll mark up the whole thing as little comments, and then I can go through later and try to make sense of it easier. Because it's like macro. It's just freaking. And it looks like. I hate void pointers. I don't know. It's not gonna be fun to organize this. And the stupid sign that stuff is gonna break when it's a 32-bit casted, or it'll be 64-bit now. If I'm gonna end up with some broken stuff because it doesn't just straight up convert to 64-bit. I'm gonna like pretend that after I get all these types in place, it's gonna magically work. I'm gonna like mentally think that, but then when I'm done, I'll be like, okay, now I have to like go through and check things line by line. I'm gonna like trick myself though into thinking that I'll be done sooner than I actually will, and that there's not that much stuff to do. So I'm gonna try to trick myself into thinking that and keep going, I guess. There's like a memory access that calls function the access address that returns there's file descriptors too. So like the file descriptor, it's not an address, it's not a pointer. I have to make a type for file descriptors. This is so annoying. Now there's a couple other types like API calls that use I'll just like make a note of that. And, whatever. Figure out later. So I'm gonna skip. There's no point in replacing if I skip 100 of them, because I gotta like figure out them anyways. But I don't want to freaking actually use my head and think this stuff through. I'm not in the mood to think. I don't want to replace either. So I'm gonna skip them for now, and then I'll just deal with whatever later. I gotta like the obvious things that are like a number. I gotta like make another type for file descriptors, because the file descriptor isn't an address. It's not a number. You need to tag it different, so it's easier to tell. I need a pet monkey to do this for me. I'm gonna stop stalling. I'm just gonna do whatever.
T E G E R capital L times 10 plus the MV of non-octal digit. The MV of non-octal decimal integer literal. Non-octal decimal integer literal decimal digit is the MV of non-octal decimal integer literal times 10 plus the MV of decimal digit. The MV of capital L E G A C Y capital O C T A L capital L I K E capital D E C I M A L capital I N T E G E R capital L E G A C Y capital O C T A L capital L I K E capital D E C I M A L capital I N T E G E R capital L octal digit is the MV of capital L E G A C Y capital O C T A L capital L I K E capital D E C I M A L capital I N T E G E R capital L times 10 plus the MV of octal digit. The MV of hex digits. Hex digits is the MV of hex digits 16 plus the MV of hex digit. The MV of hex digits. Hex digits numeric literal separator hex digit is the MV of hex digits 16 plus the MV of hex digit 2, 9, 3, 3 static semantics. Numeric value. The syntax-directed operation numeric value takes no arguments and returns a number or a big int. It is defined piecewise over the following productions. Numeric literal, decimal literal. Return round MV result, MV of decimal literal. Numeric literal, non-decimal integer literal. Return, MV of non-decimal integer literal. Numeric literal, legacy octal integ literal. Return, MV of legacy octal integer literal. Numeric literal, non-decimal integer literal big int literal suffix. Return the big int value for the MV of non-decimal integer literal. ECMA International 2024 229. Decimal big integer.
A reference is something that holds reference to another thing. An address is a location in memory that something holds to get to that location through that address or whatever. A reference and address are kind of like the same thing. A file descriptor is a file descriptor. It's like called FD whatever. And then a file starts with the letter F, and then data starts with D. And I have this thing called reference FDAT, so I don't know if that's a reference file data or a reference file descriptor at, or there's like several possible combination of possible like meanings that it could have, and it's all in capital letters, so I don't know what the fuck the type is, and I'm gonna have to go through like 20 macros because I clicked on a couple of them and I can tell that they just keep going deeper and deeper. Not 20, maybe like 8. 20 is overly dramatic. There's probably like 8 macros I gotta go through. And those macros are used for other macros that do almost the same thing for different data types. Naming something is like the most important thing. And some of these names that I picked for some of the stuff, it wasn't the most easily identifiable name to pick based on what it represents. I'm gonna have to skip a whole lot of these and only get like the obvious ones, I guess. This sucks. Oh, this will take forever.
But not one of escape character or line terminator. Escape character. Single escape character. Decimal digit. XU. Legacy octal escape sequence. 0. Look ahead. 8. 9. Non-zero octal digit. Look ahead octal digit. 0 to 3 octal digit. Look ahead octal digit. 4 to 7 octal digit. 0 to 3 octal digit. Non-zero octal digit. Octal digit but not 0.
I have places where I said something equal to -1, and that's clearly a file descriptor. So there's a teeny bit of hope that I'll be able to find or figure out easier now based off this one spot where I see a -1 after like 30 of them. So I'm gonna like make a copy of this to my notes, whatever. So I have a teeny bit of hope that it won't be as difficult as I was just thinking it would be. And I'm gonna use that tiny itsy bit of hope to like get me through the rest of this file. I'm gonna stop overthinking and click replace on only the things that are a peer number type. I wrote this program, whatever, and I set the file descriptor to 0 instead of -1 before I knew about file descriptors, whatever. There's a standard in, standard out. I don't know, whatever. But it would like output to one of those. I don't know which one 0 is by default. I could guess, but I don't want to be wrong. And it was screwing up stuff because I had like I don't know, whatever. No, this is so complicated. I'm just gonna get back to replacing and stop stalling.
The SV of double string character, ls, is the string value consisting of the code unit 0 times 2028. Line separator. The SV of double string character, ps, is the string value consisting of the code unit 0 times 2029. Paragraph separator. The SV of double string character, line continuation is the empty string. The SV of single string character, source character but not one of or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The SV of single string character, ls, is the string value consisting of the code unit 0 times 2028. Line separator. The SV of single string character, ps, is the string value consisting of the code unit 0 times 2029. Paragraph separator. The SV of single string character, line continuation is the empty string. The SV of escape sequence, 0 is the string value consisting of the code unit 0 times 0000. Null. The SV of character escape sequence, single escape character is the string value consisting of the code unit whose numeric value is determined by the single escape character according to table 38. Note to it is possible for string literals to precede a use strict directive that blah says the enclosing code in strict mode, and implementations must take care to enforce the above rules for such literals. For example, the following source text contains a syntax error, function invalid. 7. Use strict. 32. Copyright sign, ECMA International 2024. Table 38. String single character escape sequences. Escape sequence. Code unit value. Unicode character name. Symbol B 0 times 0008. Backspace BS T 0 times 0009. Character tabulation. HT N 0 times 000 line feed. LF V 0 times 000B. Line tabulation. VT F 0 times 000C. Form feed. FF R 0 times 0.
I think on 64-bit that file descriptors are 4 bytes, even though it's a 64-bit. I'm gonna check out or whatever.
Character but not one of escape.
Which means that I can't just like replace it because it depends, because -1 will fill up the whole register or whatever. But if it's -1 assigned to a 4-byte type, and then it gets assigned to a long type or a 64-bit long one, then those top bits will be 0, they won't be negative. So any places where I check for the sign bit, it's wrong. So I gotta I'm gonna have to carefully sort out the file descriptors also, as a type whatever apart from the numbers and the address to avoid truncation or sign extension or missing sign extension. So if it does have to sign extend to a bigger type, that it does sign extend. Which it won't by default, because in C, you either just cut off the top of the value or you set it to value and it's all zeros, unless you manually set it yourself, the upper bits or whatever.
The MV of the first octal digit plus the MV of the second octal digit. The MV of 0 to 3. 0 is 0. The MV of 0 to 3. 1 is 1. The MV of 0 to 3. 2 is 2. The MV of 0 to 3. 3 is 3. The MV of 4 to 7. 4 is 4. The MV of 4 to 7. 5 is 5. The MV of 4 to 7. 6 is 6. The MV of 4 to 7. 7 is 7, the MV of hex escape sequence, X hex digit.
Yeah, see, on a 64-bit computer, the file descriptor is only 4 bytes. I don't know, Chatbot's gonna say why. Have Siri read it. I need some water, I'm dying.
233. Yes, on most 64-bit systems, a file descriptor, FD, is still typically 4 bytes. 32 bits. Here's why. Is a FD still 4 bytes on 64-bit? Yes, on most 64-bit systems, a file descriptor, FD, is still typically 4 bytes, 32 bits.
I don't like this part.
On most 64-bit systems.
The on most part.
On most 64-bit systems.
That makes it more complicated because now I'm gonna have to define at the top, check the fucking compiler. Is this a 64-bit system that has a 4-byte file descriptor? Or is this a 64-bit system that has an 8-byte file descriptor? And it's just I'll make note of that, I guess, in my notes that I'm not going to read, I'm going to forget about, but I'll make note of it. So I got note of it, and yeah. Here's whatever chatbot says, whatever, as to why they don't update from 4-byte to 8-byte on 64-bit on most 64-bit.
Here's why. A file descriptor in Unix-like systems is just an integer typically of type int, used as an index into the processor's file descriptor table. Even on 64-bit systems, the int type usually remains 32 bits, so FDs are usually 4 bytes.
This pisses me off.
The int type usually remains 32 bits. Even on 64-bit systems.
They literally didn't even update the code in at like OS level. They just left it. That's why it's not been updated. So whenever they decide to update it and make it 64-bit, everyone that assumes it's 4-byte is fucked, which is why they probably didn't make it 64-bit in the first place. It's also probably why there's such an overhead when accessing files, because they want you to not just have a whole bunch of open files, so they penalize that with the timeout, and they group them up with the time scheduler to try to well, it is effective because people will stop accessing files at a higher request rate, because you know that the operating system is going to give you access to those files with the time penalty of 10 milliseconds or something. This sounds like a them problem, and they're doing whatever they have to so they don't have to update the code, because it would break tons of compatibility. Because the pointers are 64-bit. The file descriptors should be 64-bit too. And lots of programs access files. That's literally what the program does. It usually starts up, you open a file. So that way, existing programs, only the pointers have to be updated. The pointers would have to be updated, not the file descriptors too. And that takes time and money to do. And Microsoft cares so much about time and money. That's why they make this garbage compiler, because they want to make sure to waste the consumer's time and money on the consumer's back. I don't even know. I don't think Windows makes a lot of money now, because it's so easy to get a hold of, I guess, is a nice way to put it. Or 5-finger discount, that means steal, right? So I wouldn't say that, but I don't know. Windows sucks.
So to clarify, FD size, value passed around. 4 bytes, int, system architecture, like x86-64. 64-bit, but that doesn't automatically mean all integers are 8 bytes. So FD size, value passed around. 4 bytes, int, system architecture. So to clarify,
I like how it says on 64-bit, it doesn't mean all integers are 8 bytes. That's a lazy way, or a creative way to say that 64-bit, not all 64-bit operating systems have been updated to use a larger type size that is 8 bytes. So it says here,
extremely high performance or custom OS setup. Extremely high performance or custom OS setups might do things differently. But for all mainstream OSs like Linux, Mac OS, and Windows, for handles, this 4 byte size holds true.
oh yeah, it's a handle Windows, which means you lose. Okay, I don't know, Windows uses handles for everything. It's so stupid.
Extremely high performance or custom OS.
I don't know, maybe a new OS operating system that's extremely high performant will come out one day. That'd be great, you know, I don't know. Maybe one day that'll happen. But until then, I guess I'll just use Windows or whatever. I'm gonna like find and replace whatever file I was working on. I'm whatever. I'm so bored. There's just like more and more little things to like keep track of as I go and check. It's getting annoying. I'm gonna like replace some more shit and then take a break, come back, try to replace shit in the C files. Maybe I can get done. I want it to be done a couple hours ago. Maybe it could be done in a couple hours. Right. I don't even know. I'm gonna replace some more stuff. And I'm gonna get some water. And then replace some more stuff. And then figure out from there. I shouldn't have used the word reference so usually. I should have only used the word reference when it's an address, not like as in reference to a file descriptor. It is really difficult to figure out what's what.
It is a strict mode code. The early 3. If class element kind of class element is construct a method, return class element, return empty. 5. 7. For static semantics, is static. The syntax directed operation is static, takes no arguments and returns a boolean. It is defined piecewise over the following productions: class element, method definition, return false, class element, static method definition, return true, class element, field definition, return false, class element, static field definition, return true, class element, class static block, return true, class element, return false, 5, 7, 5 static semantics, non-constructor elements. The syntax-directed operation non-constructor elements takes no arguments and returns a list of class element parse nodes. It is defined piecewise. Class element list, class element. If class element is non-constructor method, then a return class element. Return a new empty list. Named constructor and that it is not an accessor property.
Testing.
National 2024 345 157 6 static semantics. Prototype property name list. The syntax-directed operation prototype property name list takes no arguments and returns a list of property keys. It is defined piecewise over the following productions: class element list, class element. Let prop name be prop name of class element. If prop name is empty, return a new empty list.
I have a type called int_int. I don't know why I needed that. Doesn't mean it's a file descriptor that's 4-byte type, and I'm signing an integer which has assign integer, because after this is some macro operation. It's not even readable. This will be a lot of fun trying to decode whatever this is later.
With argument names, return false, optional chain. Private identifier. If names contains the string value of private identifier, return true, return false, optional chain. Optional chain. Private identifier. If names contains the string value of private identifier, then a return all private identifiers valid of optional chain with argument names, return false. Class body, class element list. 2. Let new names be the list concatenation of names and private bound identifiers of class body. Return all private identifiers valid of class element list with argument new names. 46. ECMA International 2024. Relational expression. Private identifier in shift expression. If names contains the string value of private identifier, then a return all private identifiers valid of shift expression with argument names. Return false. 5, 7, 8 static semantics. Private bound identifiers. The syntax-directed operation private bound identifiers takes no arguments and returns a list of strings. It is defined piecewise over the following productions: field definition, class element name initializer opt. Return private bound identifiers of class element name. Class element name, private identifier. Return a list whose sole element is the string value of private identifier. Class element name, property name. Class element. Class static block. Return a new empty list. Class element list. Class element list. Class element. Let names 1 be private bound identifiers of class element list. Let names 2 be private bound identifiers of class element. Return the list concatenation of names 1 and names 2. Method definition. Class element name. Unique formal parameters. Function body, get class element name. Function body, set class element name. Property set parameter list. Function body, generator method, class element name, unique formal parameters, generator body.
I'm gonna have to just replace them all and then sort it out later. So I'm gonna like check all these, make sure like they look okay, and I'll do like mass replace. Run the compiler, save it back up, the JavaScript files are done, then I'll go through the C files. I'm not even gonna look at it, think about it, I'm just gonna make sure it looks okay. Separate the comments from the, like, where it's actually in use. Rename it. I'll like go through, get the comments first, and then I'll check them all one by one, and then do a mass rename on whatever 141 files. And then I can get to the address arithmetic. And then I'll save making things to like a specific like type for like the file descriptor, or I have double pointers too, and triple pointers and quadruple pointers. I'm gonna need to carefully replace the type name. So I'm gonna do that. I'm gonna get this done first, and I'm gonna get some water, whatever.
Generator body, async generator expression, async function binding identifier opt. Formal parameters, async generator body, async function declaration, async function binding identifier. Formal parameters, async function body, async function. Formal parameters, async function body, async function expression, async function binding identifier opt. Formal parameters, async function body, return false, method definition, class element name, unique formal parameters, function body, get class element name, function body, set class element name.
This is only 500.
Body, generator method, class element name, unique formal parameters, generator body, async generator method, async class element name, unique formal parameters, async generator body, async method, async class element name, unique formal parameters, async function body, return contains arguments of class element name. The 5th of July to
I have string types too.
evaluation takes argument home object, turns completion containing a class field definition record or an abrupt completion. It is defined piecewise over the following productions. Field definition, class element name initializer opt. 2. Let name be. Evaluation of class element name. If initializer is present, then 48. ECMA International 2024. ABCDE. Let formal parameter list be an instance of the production formal parameters. Empty. Let env be the lexical environment of the running execution context. Let private env be the running execution context's private environment. Let source text be the empty sequence of Unicode code points. Let initializer be ordinary function create. Percent function prototype percent. Source text. Formal parameter list. Initializer. Non-lexical this. env. Private env. F perform make method. Initializer. Home object, G set initializer to name, else, a let initializer be empty, return the class field definition record, name, initializer. Note the function created for initializer is never directly accessible to ECMAScript code. The 5th of July 2011 runtime semantics, capital C, L, A, S, S, capital S, T, A, T, I, C, capital B, L, O, C, K, capital D, E, F, I, N, I, T, I, O, N, capital E, V, A, L. The syntax directed operation, capital C, L, A S S capital S T A T I C capital B L O C K capital D E F I N I T I O N capital E V A L takes argument home object, an object, and returns a class static block definition record. It is defined productions.
I think I found a type, whatever. Called string underscore int, which looks like an int, and then I also have a string, and then over here I have a constant char pointer. So I'm pretty sure that a string means that it's a string, which is a constant char pointer. That's a constant char pointer for when it's a string int. I didn't copy the whole line of code, but I think it means that I have an integer and I will be making it into a string, which means this is like just a normal integer. It has no way to know if it's an address. It could be any number. It could be an invalid number as an address, out of range or whatever. So these addresses, they get converted to just plain numbers all over the place. It runs without any errors. I have to be really careful to not make errors. If it has an error, it'd be really obvious right away. So I think I figured out why I have int. So now I have to remember that. I'm gonna go on, find something else odd. I have to memorize that. Go on the next thing. It's not fun. And I have to be careful not to name things that overlap with these things, whatever. I don't know, I'm gonna keep replacing. I'm gonna get this one file done, save it, back up, run it, check. I'm gonna try to go through the C files as fast as possible to get this over with.
Or unused, or in abrupt completion. It is defined piecewise over the following productions: class element, field definition, static field definition, return, class field definition, evaluation of field definition with argument object, class element, method definition, static method definition, return, method definition, evaluation of method definition with arguments object and false, class element, class static block, return, capital C L A S S capital S T A T I C capital B L O C K capital D E F I N I T I O N capital E V A L of class static block with argument object. Copyright sign ECMA International 2024 349. Class element 1. Return unused. The 5th of July 2014. Runtime semantics. Class definition evaluation. The syntax-directed operation class definition evaluation takes arguments class binding, a string or undefined, and class name, a property key or a private name, and returns either a normal completion containing a function object or an abrupt completion. Note: freeze of specification. Private methods and accessors are included alongside private fields in the slot of class instances. However, any given object has either all or none of the private methods and accessors defined by a given class. This feature has been designed so that implementations may choose to implement private methods and accessors using a strategy which does not require tracking each method or accessor individually. For example, an implementation could directly associate instance private methods with their corresponding private name and track, for each object, which class constructors have run with that object as their this value. Looking up an instance private method on an object then consists of checking that the class constructor which defines the method has been used to initialize the object, then returning the method associated with the private name. This differs from private fields, because field initializers can throw during class instantiation. An individual object may have some proper subset of the private fields of a given class, and so private fields must in general be tracked individually. It is defined piecewise over the following productions: class tail, class heritage art, class body opt. Let env be the lexical environment of the running execution context. Let class env be new declarative environment, env. If class binding is not undefined, then a perform class env create immutable binding, class binding. True, let outer private environment be the running execution context's private environment. Let class private environment be new private environment, outer private environment. If class body is present, then a for each string dn of the private bound identifiers of class body. Do I if class private environment contains a private name pn such that pn is dn, then assert. This is only possible for getter setter pairs too. Else, let name be a new private name whose is dn. Append name to class private environment. If class heritage is not present, then a let protoparent be %object prototype %. Let constructor parent be %function prototype %. Else. 50. ECMA International 2024. A B C D E F. Set the running execution context's lexical environment to class env. Note: the running execution context's private environment is outer private environment when evaluating class heritage. Let superclass ref be completion. Evaluation of class heritage. Set the running execution context's lexical environment to env. Let superclass be get value superclass ref. If superclass is null, then I2. Let protoparent be null. Let constructor parent be %function prototype %. Else if is constructor superclass.
It just keeps getting more complicated the further down I go in this file.
Class prototype 2. If protoparent.
I'm just gonna replace them all and say they're good. They're all good. I'm gonna just replace everything as a number type. Then later on, not today, like another day, I'm gonna start converting things to address, the address of arithmetic first, and then I'll come back to replacing where the type is whatever type. So I'm gonna make everything a number for now, and then later on I will go through, have to think about every little place and identify if it's a number type, which is going to be named as by default because I'm just going to name these all numbers, or if it's a valid descriptor type, or if it's a address type, and then there's a couple other, I won't get into it, so I'm going to rename this whole file. I'm going to go get some water, then I'm going to do the C files. I'm just going to get done. This is complicated.
F if this constructor func is full.
I don't want to deal with this right now, but I have to get something done, otherwise nothing will get done.
Else note.
And I can't get anything else done until I get the foundation needs to be done, and then later on I'll have more stuff to do so I can pick through and do different things. I can't just stay pigeonholed on this one thing, finding and replacing. This is so boring.
Constructor parent 5. Else a let constructor info be Define method of constructor with arguments proto and constructor parent. B let f be constructor info. C perform make class constructor. F d perform set function name. F class name. 6. Perform make constructor. F false. Proto 7. If class heritage is present, set f to derived. 8. Perform. Define method property. Proto constructor. F false. 9. If class body is not present, let elements be in new empty list. 0. Else, let elements be non-constructor elements of class body. 1. Let instance private methods be in new empty list. 2. Let static private methods be in new empty list. 3. Let instance fields be in new empty list. 4.
Okay, so I replaced all. But the positive is at least I got the comments. So that means next time I go through this file, instead of 1024 that I have to click through to check, I only have to check 481, which is less than 1024. So that's positive. I'm gonna rebuild the JavaScript file.
It contains a private element pay such that pay. Then, ECMA International 2024.
Okay, all the whatever, the files that make files in HTML, they're all tagged with number type or a signed number, either an unsigned number or a signed number. I didn't tag anything as an address type because I'm gonna do that after I do the address arithmetic, because by the time I sort through places where there's address arithmetic, it'll be easier to tell what's an address and what's not, because right now I don't know what I named things back then. I can't remember until I find a couple examples and I can compare them. I can figure out whatever I did or whatever I was naming it, how or whatever, how and why I named whatever based on what it was named in relative relative to that thing it was related to. Yeah, whatever. But I'm gonna just run this now. Paste the output, run the compiler, save back up, take a break, get some water, and then get the C files. I just want to get to doing the addresses. This way at least there's no more types with the queue. So all the other files that aren't part of this build, they have a queue, so at least I can identify later on those files from these files to tell oh, I have to update this stuff in this file. And that'll be fun. I hate this.
I-O-N capital E-V-A-L-U-A-T. The syntax directed operation. Capital B-I-N-D-I-N-G. Capital C-L-A-S-S. Capital D-E-C-L-A-R-A-T-I-O-N. Capital E-V-A-L-U-A-T. Takes no arguments and returns either a normal completion containing a function object or an abrupt completion. It is defined piecewise over the following productions. Class declaration. Class binding identifier. Class tail. Let class name be string value of binding identifier. Let value be Class definition evaluation of class tail with arguments class name and class name. Set value to the source text match by class declaration. Let env be the running execution context's lexical environment. Perform. Initialize bound name, class name, value, env, return value, class declaration, class tail. Let value be. Class definition evaluation of class tail with arguments undefined and default. Set value to the source text match by class declaration. Return value 352. ECMA International 2024. Class declaration. Class tail only occurs as part of an export declaration and note, establishing its binding is handled as part of the evaluation action for that production. C16.2.3. 7. The 15th of July 2016 Runtime Semantics. Evaluation. Class declaration. Class binding identifier class tail. Perform. Capital B I N D I N G. Capital C L A S S. Capital D E C L A R A T I O N, capital E V A L U A T of this class declaration. Return empty. Class expression. Class tail. Let value be. Class definition evaluation of class tail with arguments undefined and set value to the source.
I also want to tag one first. I want to tag all the types in the generated file with like GE or something in front of the type, so when I'm looking through the files I can tell when it's a generated file or when it's just a normal file, because it's hard to tell the difference. It's gonna take 2 minutes. I'm gonna like get some water. It'll probably take me 2 minutes to find my way back because I'm gonna get distracted, check my phone along the way. I don't even know. This is like a mini break. I'll be back in another minute for a real break.
Formal parameter.
This compiler sucks.
Body plus default. Async. No line terminator here. Function. Formal parameters. Yield plus await. Class declaration. Class tail only occurs as part of an export declaration and is never, note, directly evaluated. Async function body. Async function expression. Async. No line terminator here. Function binding identifier. Yield plus await opt. Formal parameters. Yield plus await. Async function body. Async method. Yield await. Async. No line terminator here. Class element name yield await. Unique formal parameters. Yield plus await. Async function body. Async function body. Function body. Yield plus await. ECMA International 2024. 53. Await expression. Yield await unary expression yield plus await. Note 1. Await is passed as a keyword of an await expression when the await parameter is present. The await parameter is present in the top level of the following contexts. Although the parameter may be absent in some contexts depending on the non-terminals, such as function body, in an async function body, in the formal parameters of an async function declaration, async function expression, async generator declaration, or async generator expression. Await expression in this position is a syntax error via static semantics. In a module, when script is the syntactic goal symbol, await may be parsed as an identifier when the await parameter is absent. This includes the following contexts. Anywhere outside of an async function body or formal parameters of an async function declaration, async function expression, async generator declaration, or async generator expression, in the binding identifier of a function expression, generator expression, or async generator expression. 158. 1 static semantics. Early errors. Async method. Async class element name. Unique formal parameters. Async function body. It is a syntax error if function body contains use strict if async function body is true and is simple parameter list of unique formal parameters is false. It is a syntax error if has direct super of async method is true. It is a syntax error if unique formal parameters contains await expression is true. It is a syntax error if any element of the bound names of unique formal parameters also occurs in the lexically declared names of async function body, async function declaration, async function binding identifier, formal parameters, async function body, async function, formal parameters, async function body, async function expression, async function binding identifier, formal parameters, async function body. It is a syntax error if function body contains use strict if async function body is true and is simple parameter list of formal parameters is false.
it looks like it built. But looks can be deceiving because this compiler is garbage. So I don't know if it is really working or not. Maybe the compiler ran off an old copy. Maybe it missed a couple files. But it looks, appears. All I can do is assume that I replaced some stuff and it probably is okay and works. Because the compiler said, here you go. But I don't know if the compiler is working or not, because 30% of the time the compiler does what the compiler does, and it's not build what you gave it. So I'm gonna run it, check it, save it back up, take a break, and then continue on. If at some point this god-forsaken compiler screws up, it throws an error, I have a backup from earlier today that I can go to. I guess I could just redo everything I did again. It'd be easier to do again because I've done it once, and I'll just repeat what I did. So I hope the compiler is not lying to me when it says it compiled and it completed and it was successful and it only took 2 minutes, 1 second, and 32 milliseconds to compile. So I'm gonna run it, check it, save it back up, reopen this stupid compiler, and then I'll BRB. And then I got the C files, and I'm gonna just rename everything as a number from this point on, and then after that I'll have to pick out a whole bunch of different types. There's more than just an address. So file descriptor and the string, and I named some things reference, but I don't know what it holds reference to. What the reference is relative to what type, because I use reference. I don't know, whatever. I'm just gonna do what I just said. Run the compiler. It's running. Not run the compiler. I already ran the compiler. Run the executable. This takes a minute to run. Now I'm going to check the output. I think Sublime Text uses floating point for the positioning of the the cursor, or when you reposition with the minimap. It's the most frustrating thing. Things will be lined up exactly. I want to like see if they're matched exactly, but it's like off by like a smidgen, just a little bit. Floating point sucks. I don't know. It's like indecisive. Like you don't know how big something wants to be, or you want something to be, and you don't know how small. So you use floating point as like an excuse to like get an integer and then fudge it up a little bit higher and lower to get like a little bit above some integer or a little bit below. There's a min and a max with the number. There's a min and a max with the floating point number. There's no need for a floating point. If you're using floating point, you shouldn't need a floating point if you know how numbers work. I won't, whatever. Floating point is stupid. I'm gonna save it back up, and Visual Studio will be back. And floating point isn't even accurate. And they have these stupid explanations for loss of precision. Oh, it can't be stored exactly the same way because it's binary, not decimal. That has nothing to do with it. It's just stupid. Copied, haircut made. Compiler. Now I need to go think because it keeps getting more and more complicated. So all I got left is the C files, luckily. So I'm gonna get back and pick out where it's a comment first, get all those, then go back through. I'm gonna read all of them that pop up and just click them. I'm gonna read it because I wanna try to like read what macros I use and stuff, so I can like try to piece together as I go what does what and where. So if I replace all, I'm not gonna, I gotta visually look at shit, and this will force me to like fucking read the code because I don't want to program. I'm not in the mood. I also don't want to find and replace. This way I get to find and replace, and I force myself to read the code. I don't know how much I'm going to remember, but I'll remember something after reading through like 20,000 of these to go. If there's 20,000, there might only be 10,000. I don't know. There's thousands though. So I'll be back. I'm gonna go think. Lots of fun. remember when things like used to be like new, like cell phones were like a gray screen, and then they had color screens, and then they had flip phones, and they had fold phones, and you're like, oh, what's coming out next? And then like YouTube music videos were a thing, whatever. But then YouTube, people started putting them on YouTube, and then YouTube was like the place for music videos, and like you go to YouTube to watch music videos because that's what you did if you were cool. And now it's like everything's like stagnant, just everything is what it is. Everyone like not everyone, the companies, whatever, such as YouTube, they grab control. They're like, oh, music videos, they gotta be on YouTube, because if they're not, what's YouTube without music videos? It seems like, I don't know, everything's been boring the last 10-15 years. I don't know, I have a feeling like things are gonna be changing. I don't know. That'd be great though. Who knows? Anyways, I'm really bored, so I'm gonna like replace the rest of this shit and see if I can make some progress. I'm not even gonna do like control find to figure out how many are left to replace. I'm just gonna one by one, whatever, and not even look at the number. I'm just gonna try to like zone out, get this over with, and when this is done, then I can get to the 32-bit address arithmetic and get I gotta make defines to the byte size and stuff. I'm just gonna focus on replacing this shit and then reading through, trying to absorb some information on it as I go through 10,000, not 10,000. There was 30,000, then 20,000, I think 10,000-ish left maybe. Whatever things to types to replace. I'll try to like retain some information. It's a whole lot of little things I gotta like check and figure out. So I'm gonna do that and I'm gonna stop talking. I don't have anything to complain about right now, but when I do, I'll try to not complain. I can try. It's the best I can do. The button for this to talk, whatever, I think it's breaking. It doesn't hold when I press it. I tried to like stop drinking soda / pop, or whatever you want to call it, caffeinated sugar drinks, and I was making it. It was difficult. I had like pop withdrawals, soda withdrawals. Because caffeine, or what, it has cocaine in it. It has spent coca leaves, technically, because illegally they can't put cocaine in food and sell it for redistribution, but they can use crunched coca leaves, which is the leaves that are crunched and broken up, and they extract the cocaine from the coca leaves at the, like, I think there's one place, one company in the United States. I don't know about other countries. Or at least this is what I think Wikipedia, a couple of websites said, whatever. So there's cocaine in Coca-Cola and I would assume Pepsi. Maybe not Pepsi, but definitely Coca-Cola. I think Pepsi. So that's like brain food. It helps me think or whatever. And the caffeine and the sugar, but my teeth. I have to stop drinking pop. I don't want to lose my teeth. But I almost got off pop, and I started drinking pop again. And now I'm relying on pop to think. And everything's like foggy when I'm not on caffeine or sugar, soda, whatever. So I need to stop drinking pop again. I can't even find a replacement for pop / soda, whatever you want to call it. And I can't find a replacement for sugar. All these things rot your teeth. I'm not gonna inject stuff into my body. I can't eat chocolate, because chocolate, I don't like chocolate. That has sugar in it, that's natural. I don't even know what I'm saying. I don't know, I have some pop. It's gonna help me think, but it's only gonna last so long. So I'm hoping that this glass of soda / pop will get me through the next couple hours. And then I'm gonna like have brain fog again because I'm having withdrawal from drinking caffeine, soda, pop, sugar, all the stuff in it. So I'm gonna start drinking pop. I'm gonna try to get to replacing, and I hope that this caffeine, whatever else is in it, crunched coca leaves, that I'll be able to focus for long enough to get this over with. Like replacing and stuff. I saved it back up, I ran it. I'm assuming it works. I don't know if it works. The compiler doesn't work half the time. 30% of the time. It works half the time. It's like a little bit under half the time. It's not working, to be fair. It's statistically better than 50%. But Visual Studio, the compiler still sucks. I'm wasting time. I'm gonna just find a replace now. And drink some caffeine. I'm so freaking dry. I'm gonna stop drinking water and just drink only pop. I don't want to have like a sugar crash too. I don't know. I'm gonna have a sugar crash. I'm gonna have brain fog. I'm gonna try to like, I hope I can make it through the rest of this before that happens. I have to stop drinking pop again. Okay, I lied. Again, I searched to find out how many things I have to, keywords for the types that I have to replace. I drank some pop, it's kicking in, my brain is it's thinking again, it's great. No more brain fog, no more sugar crash. I'm gonna try to get as much done before the pop, soda. I'm just gonna say pop, soda all the time because I can. That's why. There's well, what I lied about is that I searched to find out how many because I kind of want to know. So I did search, and there is only only 16,000. So because this is 100, in the hundreds, whatever. This is in the thousands in the decimal system. So I'm gonna go through these 16,000 and replace. I'm gonna try to like memorize as much as I can and try to like whatever familiarize myself with whatever code I wrote like 7 years ago. I'm gonna try to do all these in like before this pop wears off. This sucks. Oh wait, I think I searched for the wrong one. There's a capital Q. Okay, this is all 300 something files, but only 124, I think, are used. And I put a lowercase q. Okay, now it's not so bad. Okay, so like, I search for this, and it has 16,000 whatever messages. He's here. What I meant to search for was this. So, however many of this are the ones I have to replace, because I found out which files the other day that are being used, and then I replaced inside of them this now, so I can find only the files that I'm working on by the lowercase q, but later on when I change the build options, things that are tagged as this will need to be updated. So whatever I'm doing now, I'm going to have to repeat this whole process on other files later if I change the build mode, and different parts of the code are included for the target build, which is going to suck, but it'll probably only be like 4 or 5 files that change between different modes. So it's not going to be like 200 files I gotta do every time. It'll be easier to manage, but it'll suck to do. So I'm gonna look for how many times this shows up. I need to get working before the pop / soda wears off. Oh shit. Never mind, it's not that freaking... There's 12,000 of them. It's like the same amount, basically, as 16,000. It's like 4,000-ish less. It's still 12,000 that I gotta go through. So I'm gonna get this done before the pop/soda wears off. This is so difficult to stream this. I have to just keep working and working and working and making progress. Oh, I'm gonna crack. Okay, I'm gonna keep going. I'll just crack my knuckles or something. It's like safer than snapping. Sing it. I'm so bored. Okay, I'm gonna get through this time. I'm gonna try. I can't make any promises. Don't make promises. You can't really promise anything. So like, don't tell people. Or you can do whatever you want. Tell people, make promises. It doesn't matter. Just when you can't keep a promise, that's on you. And it's like, replace all this shit. I keep stalling. I need to stop. I need to just keep going. I can only take so many breaks for so long until it's like I'm not even here. So I gotta just sit here and fucking get done. Did I mention that this sucks? I thought it would be easier than this. It's not. I thought like I wrote this 8 years ago, 7 years ago, however long, 2018. I thought I'll just open up the program, I'll be able to remember everything, and then I'll just change a couple things and update it. That's what I thought. And I thought it for a while, because I spent a year writing another program to attach to this program, to merge them together. I was gonna not do this, but like 7 months in to the other program, I'm like, I gotta commit to doing this, because it took 7 months to do the other program. I was planning on 4 months for that program, but it took a freaking 12 months. So, I have to do this. Otherwise, that's a whole year wasted. Oh, I'm so pissed. This is so much work. A year is a long time. I have to stop stalling. I don't want to do this, but I'm gonna do it. Here I go. Oh my god. Okay, I'm actually do this now. I'm gonna need some more pop. I'm just gonna like, I don't care about my teeth. I don't need teeth. Who needs teeth? I'll just drink milkshakes and shit. Milkshakes are good. I don't care if my teeth rot out. I don't know how expensive dentures are though, but I would want those fancy new teeth with the bowls in. I'm gonna do this now. I'm gonna shut up. The pops, I think it's starting to wear off. So I'm gonna drink some more, I guess. I want to take a break, but if I take a break, I'm not gonna be back. I know the pop's working because I have like a sugar rush, so I'm gonna get going before the sugar rush wears off. I do have to stop drinking pop though. I'm actually gonna take a break. I'm gonna be back. I can't. This is so much work.
One five seven for static semantics. Is static. The syntax-directed operation is static, takes no arguments and returns a boolean. It is defined piecewise over the following productions. Class element. Method definition. Return false. Class element. Static method definition. Return true. Class element. Field definition. Return false. Class element. Static field definition. Return true. Class element. Class static block. Return true. Class element. Return false. 5 7 5 static semantics. Non-constructor elements. The syntax-directed operation non-constructor elements takes no arguments and returns a list of class element parse nodes. It is defined piecewise over the following productions. Class element list. Class element. If class element kind of class element is non-constructor method, then a return class element. Return a new empty list. Class element list. Class element list. Class element. Let list be non-constructor elements of class element list. If class element kind of class element is non-constructor method, then a append class element to the end of list 3. Return list. Note early error rules ensure that there is only one method definition named constructor and that it is not an accessor property or generated definition. ECMA International 2024 345 157 6 static semantics. Prototype property name list. The syntax-directed operation prototype property name list takes no arguments and returns a list of property keys. It is defined piecewise over the following productions. Class element list. Class element. Let prop name be prop name of class element. If prop name is empty, return a new empty list. If a static of class element is true, return a new empty list. Return prop name. Class element list. Class element list. Class element. Let list be prototype property name list of class element list. Let prop name be prop name of class element. If prop name is empty, return list. If a static of class element is true, return list. Return the list concatenation of list and prop name. 5 7 7 static semantics. All private identifiers valid. The syntax-directed operation all private identifiers valid takes argument names, a list of strings, and returns a boolean. Every grammar production alternative in this specification which is not listed below implicitly has the following default definition of all private identifiers valid. For each child node child of this parse node, do A if child is an instance of a non-terminal, then I if all private identifiers valid of child with argument names is false. Return false 2. Return true. Member expression. Member expression. Private identifier. If names contains the string value of private identifier, then a return all private identifiers valid of member expression with argument names. Return false. Call expression. Call expression. Private identifier. If names contains the string value of private identifier, then a return all private identifiers valid of call expression with argument empty names. Return false. Optional chain. Private identifier. If names contains the string value of private identifier, return true. Return false. Optional chain. Optional chain. Private identifier. If names contains the string value of private identifier, then a return all private identifiers valid of optional chain with argument names. Return false. Class body. Class element list. 2. Let new names be the list concatenation of names and private bound identifiers of class body. Return all private identifiers valid of class element list with argument new names. 46. ECMA International 2024. Relational expression. Private identifier in shift expression. If names contains the string value of private identifier, Then, a return all private identifiers valid of shift expression with argument names. Return false. 5, 7, 8 static semantics. Private bound identifiers. The syntax-directed operation private bound identifiers takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Field definition. Class element name initializer return private bound identifiers of class element name. Class element name. Private identifier. Return a list whose sole element is the string value of private identifier. Class element name. Property name. Class element. Class static block. Return a new empty list. Class element list. Class element list. Class element. Let names 1 be private bound identifiers of class element list. Let names 2 be private bound identifiers of class element. Return the list concatenation of names 1 and names 2. Method definition. Class element name. Unique formal parameters. Function body. Get class element name. Function body. Set class element name. Property set parameter list. Function body. Generator method. Class element name. Unique formal parameters. Generator body. Async method. Async class element name. Unique formal parameters. Async function body. Async generator method. Async class element name. Unique formal parameters. Async generator body. Return private bound identifiers of class element name. 5, 7, 9 static semantics. Contains arguments. The syntax-directed operation contains arguments, takes no arguments and returns a boolean. Every grammar production alternative in this specification which is not listed below implicitly has the following default definition of contains arguments. For each child node child of this parse node. Do a if child is an instance of a non-terminal. Then, if contains arguments if child is true. Return true to. Return false. ECMA International 2024 347. Identifier reference. Identifier. If the string value of identifier is arguments. Return true. Return false. Function declaration. Function binding identifier. Formal parameters. Function body. Function. Formal parameters. Function body. Function expression. Function binding identifier. Formal parameters. Function body. Generator declaration. Function bindi. Ng identifier. Formal parameters. Generator body. Function. Formal parameters. Generator body. Generator expression. Function binding identifier. Formal parameters. Generator body. Async generator declaration. Async function binding identifier. Formal parameters. Async generator body. Async function. Formal parameters. Async generator body. Async generator expression. Async function binding identifier. Formal parameters. Async generator body. Async function declaration. Async.
Okay, so it's the year 2025. I'm programming on the modern operating system in a text editor, because that's how you write code in year 2025 on the modern operating system on a potato, a 15-year-old computer. And why can a 15-year-old computer run the modern operating system? Because nothing is all too modern. Anyways, I'm gonna get to programming and I'm gonna focus. I'm gonna have to go through this. So I'm gonna get all the comments first. I'm gonna check everything, like look at it visually, try to pick up what info I can. Like earlier, I don't know, like have macros that are like int string, int fd, int whatever, like try to figure out what's where, what does what, as I'm trying to go through all these. So I'm gonna go through, I'm gonna skip all of them unless it's a comment. but I also have to I'm just gonna do this and get done. I need to find all the places where I tag things with.
Code. The 5th of July 2000.
And then replace them, or everything with
S, capital S, T.
and then replace it with
O, C.
because I did this to be clever, so the compiler would highlight different cases, and I could put stuff in different parts and focus on whatever I'm doing. So like, I do like 0, 1 or 1, 1. Otherwise, the compiler shows like both cases as being true. So I need to find all the places with the 0 or 1 and replace it with this, whatever, parentheses, 0 or space, 1 space, parentheses. I think I said this before, whatever. So I'm gonna do that first. I'm gonna drink some pop. I'm not drinking water. I'm trying to get a sugar rush. I'm gonna do that, whatever. And then I will know all the cases where it's true or false, but I need to keep both code cases. I won't accidentally mark it as a comment because I'll be able to see visually that it's not grayed out. So I'm gonna do that first, and then I'm gonna do the types. There's a couple other things that I gotta do, but I'm gonna skip that. I'm just gonna try to do this and get done.
Runtime semantics. Evaluate class static block body. The syntax-directed operation evaluate class static block body takes argument function object, an ECMAScript function object, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It is defined piecewise over the following productions: class static block body, class static block statement list, assert. Function object is a synthetic function created by capital C, L, A, S, S, capital S, T, A, T, I, C, capital B, L, O, C, K, capital D, E, F, I, N, I, T, I, O, N, capital E, V, A, L. Step 5. Perform. Capital F, U, N, C, T, I, O, N, capital D, E, C, L, A, R, A, T, I, O, N, capital I, N, S, T, A, N, T, I, A, T, I. Function object. Return. Evaluation of class static block statement list. The 5th of July 2013 runtime semantics. Class element evaluation. The syntax-directed operation class element evaluation takes argument object, an object, and returns either a normal completion containing either a class field definition record, a class static block definition record, a private element, or unused, or an abrupt completion. It is defined piecewise over the following productions: class element, field definition, static field definition, return. Class field definition evaluation of field definition with argument object, class element. Method definition, static method definition, return. Method definition evaluation of method definition with arguments, object and false, class element. Class static block, return. Capital C, L, A, S, S, capital S, T, A, T, I, C, capital B, L, O, C, K, capital D, E, F, I, N, I, T, I, O, N, capital E, V, A, L, of class static block with argument object. Copyright sign, ECMA International 2024 349. Class element 1. Return unused. The 5th of July 2014 Runtime Semantics. Class definition evaluation. The syntax-directed operation class definition evaluation takes arguments class binding, a string or undefined, and class name, a property key or a private name, and returns either a normal completion containing a function object or an abrupt completion. Note: freeze of specification. Private methods and accessors are included alongside private fields in the slot of class instances. However, any given object has either all or none of the private methods and accessors defined by a given class. This feature has been designed so that implementations may choose to implement private methods and accessors using a strategy which does not require tracking each method or accessor individually. For example, an implementation could directly associate instance private methods with their corresponding private name and track. For each object, which class constructors have run with that object as their this value. Looking up an instance private method on an object then consists of checking that the class constructor which defines the method has been used to initialize the object, then returning the method associated with the private name. This differs from private fields, because field initializers can throw during class instantiation. An individual object may have some proper subset of the private fields of a given class, and so private fields must in general be tracked individually. It is defined piecewise over the following productions: class tail, class heritage art, class body opt. Let env be the lexical environment of the running execution context. Let class env be new declarative environment, env. If class binding is not undefined, then a perform class env create immutable binding, class binding, true. Let outer private environment be the running execution context's private environment. Let class private environment be new private environment, outer private environment. If class body is present, then a for each string dn of the private bound identifiers of class body. Do I if class private environment contains a private name pn such that pn is dn, then assert this is only possible for getter setter pairs. 2. Else, let name be a new private name whose is dn. Append name to class private environment. If class heritage is not present, then a let protoparent be percent object prototype percent b let constructor parent be percent function prototype percent else. 50. ECMA International 2024. A B C D E F. Set the running execution context's lexical environment to class CNV. Note: the running execution context's private environment is outer private environment when evaluating class heritage. Let superclass ref be completion. Evaluation of class heritage. Set the running execution context's lexical environment to env. Let superclass be get value superclass ref. If superclass is null, then I2. Let protoparent be null. Let constructor parent be percent function prototype percent g. Else if is constructor superclass is false, then I throw a type error exception. H. Else I let protoparent be get superclass prototype. 2. If protoparent is not an object and protoparent is not null, throw a type error exception. 3. Let constructor parent be superclass. Let proto be ordinary object create protoparent. 0. If class body is not present, let constructor be empty. 1. Else, let constructor be constructor method of class body. 2. Set the running execution context's lexical environment to class CNV. 3. Set the running execution context's private environment to class private environment. 4. If constructor is empty, then a let default constructor be a new abstract closure with no parameters that captures nothing and performs the following steps when called. I let args be the list of arguments that was passed to this function by or I if new target is undefined. Throw a type error exception. 3. Let f be the active function object. If f is derived, then note this branch behaves similarly to constructor args super args The most notable distinction is that while the aforementioned ECMAScript source text observably calls the @iterator method on %array prototype %, this function does not. Let func be f if this constructor func is false. Throw a type error exception. Let result be construct func args new target v else. Note, this branch behaves similarly to constructor. Let result be ordinary create from constructor new target %object prototype %v perform initialize instance elements result f7 return result b. Let f be create built-in function default constructor 0 class name the current realm record constructor parent 5 else a. Let constructor info be define method of constructor with arguments proto and constructor parent b. Let f be constructor info c. Perform make class constructor f d. Perform set function name f class name 6 perform make constructor f false proto 7 if class heritage is present set f to derived 8 perform define method property proto constructor f false 9 if class body is not present let elements be new empty list 0 else let elements be non-constructor elements of class body 1 let instance private methods be new empty list 2 let static private methods be new empty list 3 let instance fields be new empty list 4 let static elements be new empty list 5 for each class element of elements do if is static of e is false then I let element be completion class element evaluation of e with argument proto b. Else I let element be completion class element evaluation of e with argument f. See if element is an abrupt completion, then I set the running execution context's lexical environment to env2. Set the running execution context's private environment to outer private environment. 3. Return element d. Set element to an element e. If element is a private element, then I assert element is either method or accessor. V is false. Let container be instance private methods. 3. Else let static private methods.
I don't know, I'll try to find a good example of it.
24.3.
I'm gonna replace these and then I'm gonna actually do the types. I can kind of focus.
Append element to container. If else if element is a class field definition record, then if a static of e is false, append element to instance fields. 2. Else append element to static elements. G. Else if element is a class static block definition record, then I append element to static elements. 6. Set the running execution context's lexical environment to env7. If class binding is not undefined, then I perform class env initialize binding. Class binding f8. Set f to instance private methods. 9. Set f to instance fields. 0. For each private element method of static private methods, do a perform private method or accessor add f method 31. For each element record of static elements, do if element record is a class field definition record, then I let result be completion. Define field f element record b. Else I assert element record is a class static block definition record. 2. Let result be completion. Call element record f. See if result is an abrupt completion, then I set the running
like this, whatever I like. I tagged it here with a 0 or 1. It's not gonna highlight because this program, this zoom tool, is garbage. So I ignore the spelling, it doesn't matter. I'm gonna have to go through and spell check stuff. Can I get the cursor closer to where I want? If I move the mouse, it just bounces back. I can't even. This is so difficult to work with. So like this one is 0 or 1. I did it on purpose so it'd be gray, but that code is still being used. But I did that so like as I was working on whatever, I would be like, okay, I can't touch that because it's grayed out. Either because it's being used and I want to not see it, or I want to like make a reminder like I shouldn't modify this, and then the code that's in use, whatever it looks like, this one here or whatever, this is code that's in use, it's like not grayed out, and it's because whenever it's like a parenthesis to the left next to the if, this text editor or whatever, it treats it as a truthy case or possibly truthy, so the inside is not commented out. So right now I'm like replacing all the ones above this one to look like this one. It's just not going to highlight. That's great. There's only like 150 of these, I think. And then that way, when I go through, I'll be able to see like what's actually in use, so I won't accidentally mark things as a comment when it's being used. So I'm gonna mark everything that's a comment that I'll master place, assuming their own numbers, and then I am on to address arithmetic, and then I'm not even gonna think about all the other stuff that I have to whatever. So I'm gonna get back to this. I feel like the pop's wearing off, so I'm gonna drink some more pop.
Value of binding identifier. Let value be. Class definition evaluation of class tail with arguments class name and class name. Set value to the source text match by class expression. Return value. Class element name. Private identifier. Let private identifier be string value of private identifier. Let private envrec be the running execution context's private environment. Let names be private envrec. Assert. Exactly one element of names is a private name whose is private identifier. Let private name be the private name in names whose is private identifier. Return private name. Class static block statement list. Empty. 1. Return undefined. 5.8 Async function definitions syntax. Async function declaration. Yield. Await. Default. Async. No line terminator here. Function binding identifier yield await. Formal parameters. Yield plus await. Async function body plus default. Async. No line terminator here. Function. Formal parameters. Yield plus await. Class declaration. Class tail only occurs as part of an export declaration and is never, note, directly evaluated. Async function body. Async function expression. Async. No line terminator here. Function binding identifier. Yield plus await opt. Formal parameters. Yield plus await. Async function body. Async method. Yield await. Async. No line terminator here. Class element name yield await. Unique formal parameters. Yield plus await. Async function body. Async function body. Function body. Yield plus await. ECMA International 2024. 53. Await expression. Yield. Await unary expression yield plus await. Note 1. Await is passed as a keyword of an await expression when the await parameter is present. The await parameter is present in the top level of the following contexts. Although the parameter may be absent in some contexts depending on the non-terminals, such as function body in an async function body, in the formal parameters of an async function declaration, async function expression, async generator declaration, or async generator expression. Await expression in this position is a syntax error via static semantics. In a module, when script is the syntactic goal symbol, await may be parsed as an identifier when the await parameter is absent. This includes the following contexts: anywhere outside of an async function body or formal parameters of an async function declaration, async function expression, async generator declaration, or async generator expression in the binding identifier of a function expression, generator expression, or async generator expression. 158. 1 static semantics, early errors, async method, async class element name, unique formal parameters, async function body. It is a syntax error if function body contains use strict of async function body is true and is simple parameter list of unique formal parameters is false. It is a syntax error if has direct super of async method is true. It is a syntax error if unique formal parameters contains await expression is true. It is a syntax error if any element of the bound names of unique formal parameters also occurs in the lexically declared names of async function body, async function declaration, async function binding identifier, formal parameters, async function body, async function, formal parameters, async function body, async function expression, async function binding identifier, formal parameters, async function body. It is a syntax error if function body contains use strict of async function body is true and is simple parameter list of formal parameters is false. It is a syntax error if formal parameters contains await expression is true, if the source text match by formal parameters is strict mode code. The early error rules for unique formal parameters. Formal parameters are applied if binding identifier is present and the source text match by binding identifier is strict mode code. It is a syntax error if the string value of binding identifier is either eval or arguments. It is a syntax error if any element of the bound names of formal parameters also occurs in the lexically declared names of async function body. It is a syntax error if formal parameters contain super property is true. It is a syntax error if async function body contains super property is true. It is a syntax error if formal parameters contain super call is true. It is a syntax error if async function body contains super call is true. 54. ECMA International 2024. Note to unlike yield expression, it is a syntax error to omit the operand of an await expression. You must await something. 158. To runtime semantics. Instantiate async function object. The syntax-directed operation instantiate async function object takes argument env, an environment record, and private env, a private environment record or null, and returns an ECMAScript function object. It is defined piecewise over the following productions: async function declaration, async function binding identifier, formal parameters, async function body. Let name be string value of binding identifier. Let source text be the source text match by async function declaration. Let f be ordinary function create. Async function prototype source text. Formal parameters. Async function body. Non-lexical this. env. Private env. Perform cert function name. F. Name. Return f. Async function declaration. Async function. Formal parameters. Async function body. Let source text be the source text match by async function declaration. Let f be ordinary function create. Async function prototype source text. Formal parameters. Async function body. Non-lexical this. env. Private env. Perform cert function name. F. Default. Return f. 5, 8, 3 runtime semantics. Capital I, N, S, T, A, N, T, I, A, T, E, capital A, S, Y, N, C, capital F, U, N, C, T, I, O, N, capital E, X, P, R, E, S. The syntax-directed operation. Capital I, N, S, T, A, N, T, I, A, T, E, capital A, S, Y, N, C, capital F, U, N, C, T, I, O, N, capital E, X, P R E S takes optional argument name, a property key or a private name, and returns an ECMAScript function object. It is defined piecewise over the following productions: async function expression, async function, formal parameters, async function body. If name is not present, set name to. Let env be the lexical environment of the running execution context. Let private env be the running execution context's private environment. Let source text be the source text matched by async function expression. Let closure be ordinary function create. %async function prototype %source text formal parameters async function body non-lexical this env private env perform set function name closure name return closure async function expression async function binding identifier formal parameters async function body assert name is not present. Set name to string value of binding identifier. Let outer env be the lexical environment of the running execution context. Let funky env be new declarative environment. Outer env perform funky env create immutable binding. Name false. Let private env be the running execution context's private environment. Let source text be the source text matched by async function expression. Let closure be ordinary function create. %async function prototype source text formal parameters async function body non-lexical this funcs env private env perform set function name closure name 0 perform func env initialize binding name closure 1 return closure. Note the binding identifier in an async function expression can be referenced from inside the async function expression's async function body to allow the function to call itself recursively. However, unlike in a function declaration, the binding identifier in an async function expression cannot be referenced from and does not affect the scope enclosing the async function expression. ECMA International 2024 355 158 for runtime semantics. Evaluate async function body. The syntax-directed operation evaluate async function body takes arguments function object, an ECMAScript function object, and arguments list, a list of ECMAScript language values, and returns a return completion. It is defined piecewise over the following productions: async function body. Function body. Let promise capability be new promise capability. %promise %. Let dec result be completion. Function declaration instantiation. Function object. Arguments list. If dec result is an abrupt completion, then a perform. Call. Promise capability. Undefined. Dec result 4. Else. A perform async function start. Promise capability. Function body. Return completion record. Return. Promise capability. Empty. 5. 8. 5 runtime semantics. Evaluation. Async function expression. Async function binding identifier opt. Formal parameters. Async function body. Return. Capital I N S T A N T I A T E capital A S Y N C capital F U N C T I O N capital E X P R E S of async function expression. Await expression. Await unary expression. Let expref be. Evaluation of unary expression. Let value be. Get value. Expref. Return. Await. Value. 5.9 async RO. W function definitions syntax. Here. Equals. Async concise body in capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R yield await async concise body in async concise body in look ahead expression body in plus await async function body async arrow binding identifier yield, binding identifier yield, plus await, capital C O V E R, capital C A L L, capital E X P R E S S I O N, capital A N D, capital A S Y N C, capital A R R, yield, await, member expression yield await, arguments yield await, supplemental syntax. When processing an instance of the production, async arrow function, capital C O V E R, capital C A L L, capital E X P R E S S I O N, capital A N D, capital A S Y N C, capital A R R, equals async concise body. The interpretation of capital C O V E R, capital C A L L, capital E X P R E S S I O N, capital A N D, capital A S Y N C, capital A R R, is refined using the following grammar. Async arrowhead, async, no line terminator here, arrow formal parameters, yield, plus await. 56. ECMA International 2024. Async arrow function, in, yield, await, async, no line terminator here, async arrow binding identifier yield, no line terminator here, equals 159. 1 static semantics, early errors, async arrow function, async arrow binding identifier equals, async concise body. It is a syntax error if any element of the bound names of async arrow binding identifier also occurs in the lexically declared names of async concise body. Async arrow function, capital C O V E R, capital C A L L, capital E X P R E S S I O N, capital A N D, capital A S Y N C, capital A R R, equals async concise body, capital C O V E R, capital C A L L, capital E X P R E S S I O N, capital A N D, capital A S Y N C, capital A R R, must cover an async arrowhead. It is a syntax error if capital C O V E R, capital C A L L, capital E X P R E S S I O N, capital A N D, capital A S Y N C, capital A R R, contains yield expression is true. It is a syntax error if capital C O V E R, capital C A L L, capital E X P R E S S I O N, capital A N D, capital A S Y N C, capital A R R, contains await expression is true. It is a syntax error if any element of the bound names of capital C O V E R, capital C A L L, capital E X P R E S S I O N, capital A N D, capital A, S, Y, N, C, capital A, R, R, also occurs in the lexically declared names of a concise body. It is a syntax error if capital A, S, Y, N, C, capital C, O, N, C, I, S, E, capital B, O, D, Y, capital C, O, N, T, A, I, N, S, capital U, S, E, capital S, T, R, of a concise body is true and is simple parameter list of capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R, is false. 5, 9, to static semantics, capital A, S, Y, N, C, capital C, O, N, C, I, S, E, capital B, O, D, Y, capital C, O, N, T, A, I, N, S, capital U, S, E, capital S, T, R, the syntax directed operation, capital A, S, Y, N, C, capital C, O, N, C, I, S, E, capital B, O, D, Y, capital C, O, N, T, A, I, N, S, capital U, S, E, capital S, T, R, takes no arguments and returns a boolean. It is defined piecewise over the following productions: a concise body, expression body, return false, a concise body, a function body, return function body contains use strict of a function body 1 5 9 3 runtime semantics, evaluate a concise body. The syntax directed operation evaluate a concise body takes arguments function object, an ECMAScript function object, and arguments list, a list of ECMAScript language values, and returns a return completion. It is defined piecewise over the following productions: a concise body, expression body, let promise capability be, new promise capability, %promise %, let decl result be completion, function declaration instantiation, function object, arguments list. If decl result is an abrupt completion, then a perform, call, promise capability, undefined, decl result 4, else a performance and function start, promise capability, expression body, return completion record, return, promise capability, empty, 5, 9, for runtime semantics, capital I, N, S, T, A, N, T, I, A, T, E, capital A, S, Y, N, C, capital A, R, R, O, W, capital F, U, N, C.
Well, that took too long. There's a bunch of other spots I gotta possibly tag, or like, there's an echo.
N, T, I, A, T, E, capital A.
I don't know, I'm just gonna go through and start marking things as what looks to be like a comment, and then I'll master place the rest as a number, type, whatever.
I, O, N, capital E, takes optional argument name, a property key or a private name, and
it'll take too long to like pick through and organize before just master placing. And I don't want to risk making a syntax error in some place or whatever. So if I don't modify it, that decreases my odds of getting a syntax error on accident. And I had another thing that was gone.
Concise body. Lexical this. env. Private env. Perform cert function name. Closure. Name. Return closure. ECMA International 2024 357. Async arrow function. Capital C O V E R. Capital C A.
I don't know if I mark something as a comment and it's not a comment. It's not the end of the world. It'll just show up as a syntax error or whatever, or a type error, because it's not defined for a comment. So it should catch. I don't know, this compiler sucks. If I miss it, I can tag it later. It's not the end of the world. It will feel like the end of the world because it's like, oh fuck, I gotta like edit this shit again. But it's not really the end of the world. It'll just be annoying to do. So I'm gonna, I don't know, I gotta like the obvious spots. So I still gotta like check, be careful, I'm gonna read through all of them, mark the comments, the master place, the rest as a assumed number type, even though there's like several other types it could be that I have to mark as after I get done. And then after this I'm gonna do the address arithmetic or start that very 64-bit address arithmetic. I need to drink some water. So try.
Private env. Perform cert function name. Closure. Name. Return closure. 5. 9. 5 runtime semantics. Evaluation. Async arrow function. Async arrow binding identifier equals. Async concise body. Capital C O V E R. Capital C A L L. Capital E X P R E S S I O N. Capital A N D. Capital A S Y N C. Capital A R R equals. Async concise body. Return. Capital I N S T A N T I A T E. Capital A S Y N C. Capital A R R O W. Capital F U N C T I O N. Capital E. Of async arrow function 15.10 tail position calls 5.1.0.1 static semantics is in tail position call. The abstract operation is in tail position takes argument call, a call expression parse node, a member expression parse node, or an optional chain parse node, and returns a boolean. It performs the following steps when called. If the source text matched by call is non-strict code, return false. If call is not contained within a function body, a concise body, or an async concise body, return false. Let body be the function body, concise body, or async concise body that most closely contains call. If body is the function body of a generator body, return false. If body is the function body of an async function body, return false. If body is the function body of an async generator body, return false. If body is an async concise body, return false. Return the result of has call in tailed position of body with argument call. 5.1.0.2 static semantics has call in tail position. The syntax directed operation has call in tail position takes argument t call, a call expression parse node, a member expression parse node, or an optional chain parse node, and returns a boolean. Note tailed position calls are only defined in strict mode code because of a common non-standard language extension, C10.2.4, that enables observation of the chain of caller contexts. Note one call is a parse node that represents a specific range of source The following algorithm.
So,
It is a test of whether they represent.
we got 12,000
It is immediately
12,800 feet to go. Starting, I'm gonna get back.
the same value as the actual function call result. 58. Copyright sign. ECMA International 2024. It is defined piecewise over the following productions. Statement list. Statement list. Statement list item. Let his be has call entail position of statement list with argument call. If his is true, return true. Return has call entail position of statement list item with argument call. Function statement list. Empty. Statement list item. Declaration. Statement. Variable statement, empty statement, expression statement, continue statement, break statement, throw statement, debugger statement, block, return statement, return, labeled item, function declaration, foreign of statement, 4, left-hand side expression of assignment, expression statement 4, var for binding of assignment, expression statement 4, for declaration of assignment, expression statement, case block, return false, if statement, if, expression statement else statement. Let his be has call entail position of the first statement with argument call. If his is true, return true. Return has call entail position of the second statement with argument call. If statement, if, expression statement, do while statement, do statement while, expression, while statement, while, expression statement for statement, 4, expression not, expression not, expression not statement, 4, var variable declaration list, expression not statement 4, lexical declaration expression not statement foreign of statement 4, left-hand side expression in expression statement 4, var for binding in expression statement 4, for declaration in expression statement, ECMA International 2024 359, with statement, with expression statement, return has call entail position of statement with argument call. Labeled statement, label identifier, labeled item, return has call entail position of labeled item with argument call. Return statement, return expression, return has call entail position of expression with argument call. Switch statement, switch, expression, case block, return has call entail position of case block with argument call. Case block, case clause assopt, default clause case clause assopt. Let has be false. If the first case clauses is present, set has to has call entail position of the first case clauses with argument call. If his is true, return true. Set has to has call entail position of default clause with argument call. If his is true, return true. If the second case clauses is present, set has to has call entail position of the second case clauses with argument call. Return has case clauses. Case clauses case clause. Let his be has call entail position of case clauses with argument call. If his is true, return true. Return has call entail position of case clause with argument call. Case clause, case expression, statement list opt, default clause, default, statement list opt. If statement list is present, return has call entail position of statement list with argument call. Return false. Try statement, try block catch. Return has call entail position of catch with argument call. Try statement, try block finally, try block catch finally. Return has call entail position of finally with argument call. Catch, catch, catch parameter, block. Return has call entail position of block with argument call. 60. ECMA International 2024. Assignment expression, yield expression, arrow function, async arrow function. Left-hand side expression equals assignment expression, left-hand side expression assignment operator assignment expression, left-hand side expression and equals assignment expression, left-hand side expression equals assignment expression, left-hand side expression equals assignment expression, bitwise and expression and equality expression, bitwise or expression, bitwise or expression, bitwise and expression, bitwise or expression, bitwise or expression, bitwise or expression, equality expression. Equality expression equals relational expression, 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 relational expression, relational expression, shift expression, relational expression, shift expression relational expression equals shift expression relational expression equals shift expression relational expression instance of shift expression relational expression in shift expression. Private identifier in shift expression, shift expression, shift expression, additive expression, shift expression, additive expression, shift expression, additive expression, additive expression, additive expression plus multiplicative expression, additive expression, multiplicative expression, multiplicative expression, multiplicative expression, multiplicative operator, exponentiation expression, exponentiation expression, update expression, exponentiation expression, update expression, left-hand side expression plus plus, left-hand side expression, plus plus unary expression, unary expression, unary expression, delete unary expression, void unary expression, type of unary expression plus unary expression, unary expression, unary expression, unary expression, await expression, ECMA International 2024 361, call expression, sue, per call import call expression, expression, call expression, identifier name call expression, private identifier, new expression, new expression, member expression, expression, member expression, identifier name super property, meter property, new member expression, arguments member expression, private identifier, primary expression, this identifier reference, literal, array literal, object literal function expression class expression generator expression async function expression async generator expression regular expression literal template literal return false expression assignment expression expression assignment expression return has call entail position of assignment expression with argument call conditional expression short circuit expression assignment expression assignment expression. Let his be has call entail position of the first assignment expression with argument call. If his is true, return true. Return has call entail position of the second assignment expression with argument call. Logical and expression and bitwise or expression 1. Return has call entail position of bitwise or expression with argument call. Logical or expression logical and expression. Return has call entail position of logical and expression with argument call. Coalesce expression head. Bitwise or expression 1. Return has call entail position of bitwise or expression with argument call. 62. ECMA International 2024. Call expression, capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R, call expression arguments call expression template literal. If this call expression is call, return true, return false, optional expression, member expression, optional chain, call expression, optional chain, optional expression, optional chain. Return has call entail position of optional chain with argument call, optional chain, expression, identifier name, private identifier, optional chain, expression, optional chain, identifier name, optional chain, private identifier, return false, optional chain, arguments, optional chain arguments. If this optional chain is call, return true, return false, member expression template literal. If this is call, return true, return false, primary expression, capital C, O, V, E, R, capital P, A, R, E, N, T, H, E, S, I, Z, E, capital E.
Okay, so 12,800 to go, and I guess if I back up, I'm gonna do it.
Sized expression that is covered by capital C, O, V, E, R, capital P, A, R, E, N, T, H, E, S, I, Z, E, D, capital E, X, P.
This computer is very laggy.
Return has call and tail position of exp with argument call. Parenthesized expression. Expression. Return has call and tail position of expression with argument call. ECMA International 2020.
I'm very slow. Very slow.
Call. The abstract operation prepare for tail call takes no arguments and returns unused. It performs the following steps when called. Assert. The current execution context will not subsequently be used for the evaluation of any ECMAScript code or built-in functions. The invocate, ion of call subsequent to the invocation of this abstract operation will create and push a new execution context before performing any such.
Okay. Okay, I'm good now. I don't know, I gotta back up. I think that's about it. There's other things I could. But 12,808 to go. So then, I'm not that excited. I'm gonna check it quickly though. Oh, I need some water.
Return 6 1 1 static semantics. Early errors. Script body. It is a syntax error if the lexically declared names of script body contains any duplicate entries. It is a syntax error if any element of the lexically declared names of script body also occurs in the are declared names of script body. Script body. Statement list. It is a syntax error if statement list contains super unless the source text containing super is eval code that is being processed by a direct eval. Additional early error rules for super within direct eval are defined in 1.9.2.1.1. It is a syntax error if statement list contains new target unless the source text containing new target is eval code that is being processed by a direct eval. Additional early error rules for new target in direct eval are defined in 1.9.2.1.1. It is a syntax error if contains duplicate labels of statement list with argument is true. It is a syntax error if contains undefined break target of statement list with argument is true. It is a syntax error if capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of statement list with arguments and is true. It is a syntax error if all private identifiers valid of statement list with argument is false unless the source text containing script body is eval code that is being processed by a direct eval. Note, for example, a tail position call should only grow an implementation's activation record stack by the amount that the size of the target function's activation record exceeds the size of the calling function's activation record. If the target function's activation record is smaller, then the total size of the stack should decrease. 64. ECMA 4.1.6.1. 2 static semantic.
I got one file done, so
It is defined.
I have this ready to go.
Script body opt. If script body is present in the directive prologue of script body contains a use strict directive, return true. Otherwise, return false. 6. 1. 3 runtime semantics. Evaluation. Script. Empty. Return undefined. 6. 1. 4 script.
So I only have now 12,800 left and only 75 files left to go to replace this with this. I feel like I'm making progress here, so I'm just gonna keep going. I'm on a streak.
By this script to the resolved module record. The list does not contain two different.
I mean, like, it's all positive, uphill, sunshines, rainicorns. I'm mixing up all of the words. Butterflies and rainbows, unicorns. I don't know. It's all positive. I know from here. This is 12,800 left to go.
And returns a script record or a non-empty list of syntax error objects. It creates a script record based upon the result of parsing source text as a script. It performs the following steps when called. Let script be parse text, source text, script. If script is a list of errors, return script record, realm, script, host defined. Note an implementation may parse script source text and analyze it for early error conditions prior to evaluation of parse script for that script source text. However, the reporting of any errors must be deferred until the point where this specification actually performs parse script upon that source text. ECMA International 2024 365 16 Script evaluation, script record. The abstract operation script evaluation takes argument script record, a script record, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It performs the following steps when called. Let global env be script record. Let script context be a new ECMAScript code execution context. Set the function of script context to null. Set the realm of script context to script record. Set the script or module of script context to script record. Set the variable environment of script context to global env. Set the lexical environment of script context to global env. Set the private environment of script context to null. Suspend the running execution context. 0. Push script context onto the execution context stack. Script context is now the running execution context. 1. Let script be script record. 2. Let result be completion. Global declaration instantiation. Script. Global env. 3. If result is a normal completion, then set result to completion. Evaluation of script. B. If result is a normal completion and result is empty, then I set result to normal completion, undefined. 4. Suspend script context and remove it from the execution context stack. 5. Assert. The execution context stack is not empty. 6. Resume the context. That is now on the top of the execution context stack as the running execution context. 7. Return result. 6. 1. 7. Global declaration instantiation. Script. env. The abstract operation global declaration instantiation takes argument script, a script parse node, and env, a global environment record, and returns either a normal completion containing unused or a throw completion script as the script for which the execution context is being established. env is the global environment in which bindings are to be created. It performs the following steps when called. Let lex names be the lexically declared names of script. Let var names be the var declared names of script. For each element name of lex names, do if env has var declaration, name is true. Throw a syntax error exception. B. If env has lexical declaration, name is true. Throw a syntax error exception. C. Let has restricted global. B. env has restricted global property, name. D. If his restricted global is true, throw a syntax error exception. For each element name of var names, do if env has lexical declaration, name is true. Throw a syntax error exception. Let var declarations be the var scope declarations of script. Let functions to initialize be a new empty list. Let declared function names be a new empty list. For each element d of var declarations, in reverse list order, do 366. ECMA International 2024. Note 1. When an execution context is established for evaluating scripts, declarations are instantiated in the current global environment. Each global binding declared in the code is instantiated. A. If D is not either a variable declaration, a for binding, or a binding identifier, then I. 2. 3. Assert. D is either a function declaration, a generator declaration, an async function declaration, or an async generator declaration. Note: if there are multiple function declarations for the same name, the last declaration is used. Let fn be the sole element of the bound names of D. If declared function names does not contain fn, then let fn definable be env can declare global function fn. 2. If fn definable is false, Throw a type error exception. Append fn to declared function names. Insert d as the first element of functions to initialize. Let declared var names be a new empty list. 0. For each element d of var declarations, do if d is either a variable declaration, a for binding, or a binding identifier. Then I for each string vn of the bound names of d, do if declared function names does not contain vn, then a let vn definable be env can declare global var vn b if vn definable is false. Throw a type error exception. See if declared var names does not contain vn, then I append vn to declared var names. 1. Note: no abnormal terminations occur after this algorithm step if the global object is an ordinary object. However, if the global object is a proxy exotic object, it may exhibit behaviors that cause abnormal terminations in some of the following steps. 12. Note: an xb 3 2 2 adds additional steps at this point. 3. Let lex declarations be the lexically scoped declarations of script. 4. Let private env be null. 5. For each element d of lex declarations, do a note: lexically declared names are only instantiated here but not initialized. B for each element dn of the bound names of d, do I if this constant declaration of d is true, then perform env create immutable binding. dn true 2. Else perform env create mutable binding. dn false. 6. For each parse node f of functions to initialize, do a let fn be the sole element of the bound names of f. B let fo be instantiate function object of f with arguments env and private env. C perform env create global function binding. fn fo false. 7. For each string vn of declared var names, do a perform env create global var binding. vn false. 8. Return unused. Note 2. Early errors specified in 1.6. 1. 1. Prevent name conflicts between function var declarations and let const class declarations, as well as redeclaration of let const class bindings for declaration contained within a single script. However, such conflicts and redeclarations that span more than one script are detected as runtime errors during global declaration instantiation. If any such errors are detected, no bindings are instantiated for the script. However, if the global object is defined using proxy exotic objects, then the runtime tests for conflicting declarations may be unreliable, resulting in an abrupt completion and some global declarations not being instantiated. If this occurs, the code for the script is not evaluated. Unlike explicit var or function declarations, properties that are directly created on the global object result in global bindings that may be shadowed by let const class declarations. 6.2 Modules syntax. Module body op, module body, module item list, module item list, module item list, module item. ECMA International 2024 367. Module item. Import declaration, export declaration, statement list item, yield, plus await, return, module export name, identifier name, string literal. 6. 2. 1 module semantics. 6. 2. 1. 1 static semantics. Early errors. Module body. Module item list. It is a syntax error if the lexically declared names of module item list contains any duplicate entries. It is a syntax error if any element of the lexically declared names of module item list also occurs in the are declared names of module item list. It is a syntax error if the exported names of module item list contains any duplicate entries. It is a syntax error if any element of the exported bindings of module item list does not also occur in either the are declared names of module item list or the lexically declared names of module item list. It is a syntax error if module item list contains super. It is a syntax error if module item list contains new target. It is a syntax error if contains duplicate labels of module item list with argument is true. It is a syntax error if contains undefined break target of module item list with argument is true. It is a syntax error if capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of module module item list with arguments and is true. It is a syntax error if all private identifiers valid of module item list with argument is false. Module export name. String literal. It is a syntax error if is string well-formed Unicode. The SV of string literal is false. 6, 2, 1. 2 static semantics. Imported local names. Import entries. The abstract operation imported local names takes argument import entries, a list of import entry records, and returns a list of strings. It creates a list of all of the local name bindings defined by import entries. It performs the following steps when called. Let local names be a new empty list. For each import entry record I have import entries. Do a append I to local names 3. Return local names 6, 2, 1. 3 static semantics. Module requests. The syntax-directed operation module requests takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Module. Empty. Return a new empty list. The duplicate exported names rule implies that multiple export default export declaration items. Note, within a module body is a syntax error. Additional error conditions relating to conflicting or duplicate declarations are checked during module linking prior to evaluation of a module. If any such errors are detected, the module is not evaluated. 68. ECMA International 2024. Module item list. Module item. Return module requests of module item. Module item list. Module item list module item. Let module names be module requests of module item list. Let additional names be module requests of module item. For each string name of additional names. Do. If module names does not contain name, then I append name to module names. Return module names. Module item. Statement list item. Return a new empty list. Import declaration. Import clause from clause. Return module requests of from clause. Module specifier. String literal. Return a list whose sole element is the SV of string literal. Export declaration. Export from clause. Return the module requests of from clause. Export declaration. Export named exports. Export variable statement. Export declaration. Export default hoistable declaration. Export default class declaration. Export default assignment expression. Return a new empty list 1 6 2 1. For abstract module records, a module record encapsulates structural information about the imports and exports of a single module. This information is used to link the imports and exports of sets of connected modules. A module record includes 4 fields that are only used when evaluating a module. For specification purposes, module record values are values of the record specification type and can be thought of as existing in a simple, object-oriented hierarchy where module record is an abstract class with both abstract and concrete subclasses. This specification defines the abstract subclass named cyclic module record and its concrete subclass named source text module record. Other specifications and implementations may define additional module record subclasses corresponding to alternative module definition facilities that they defined. Module record defines the fields listed in Table 41. All module definition subclasses include at least those fields. Module record also defines the abstract method list in Table 42. All module definition subclasses must provide concrete implementations of these abstract methods. ECMA International 2024 369. Table 41. Module record fields. Field name. Value type. Meaning. Realm. A realm record. The realm within which this module was created. Environment. A module environment record or empty. The environment record containing the top-level bindings for this module. This field is set when the module is linked. Namespace, an object or empty. The module namespace object, 28.3. If one has been created for this module. Host defined. Anything default value is undefined. Field reserved for use by host environments that need to associate additional information with a module. Table 42. Abstract methods of module records. Method. Purpose. Load requested modules. Host defined. Prepares the module for linking by recursively loading all its dependencies. And returns a promise. Get exported names. Export star set. Return a list of all names that are either directly or indirectly exported from this module. Load requested modules must have completed successfully prior to invoking this method. Resolve export. Export name. Resolve set. Return the binding of a name exported by this module. Bindings are represented by a resolved binding record of the form module record string namespace. If the export is a module namespace object without a direct binding in any module, will be set to namespace. Return null if the name cannot be resolved, or ambiguous if multiple bindings were found. Each time this operation is called with a specific export name, resolve set pair as arguments, it must return the same result. Load requested modules must have completed successfully prior to invoking this method. Link, prepare the module for evaluation by transitively resolving all module dependencies and creating a module environment record. Load requested modules must have completed successfully prior to invoking this method. Evaluate, returns a promise for the evaluation of this module and its dependencies, resolving on successful evaluation or if it has already been evaluated successfully, and rejecting for an evaluation error or if it has already been evaluated unsuccessfully. If the promise is rejected, hosts are expected to handle the promise rejection and rethrow the evaluation error. Link must have completed successfully prior to invoking this method. 370 ECMA International 2024 1621 5 cyclic module records. A cyclic module record is used to represent information about a module that can participate in dependency cycles with other modules that are subclasses of the cyclic module record type. Module records that are not subclasses of the cyclic module record type must not participate in dependency cycles with source text module records. In addition to the fields defined in Table 41, cyclic module records have the additional fields listed in Table 43. Table 43. Additional fields of cyclic module records. Field name, value type, meaning, status, new, unlinked, linking, linked, evaluating, evaluating async, or evaluated, initially new. Transitions to unlinked, linking, linked, evaluating, possibly evaluating async, evaluated, in that order, as the module progresses throughout its lifecycle. Evaluating async indicates this module is queued to execute on completion of its asynchronous dependencies, or it is a module whose field is true that has been executed and is pending top-level completion. Evaluation error, a throw completion or empty. A throw completion representing the exception that occurred during evaluation, undefined if no exception occurred or if is not evaluated. DFS index, an integer or empty auxiliary field used during link and evaluate only. If is either linking or evaluating, this non-negative number records the point at which the module was first visited during the depth-first traversal of the dependency graph. DFS ancestor index, an integer or empty auxiliary field used during link and evaluate only. If is either linking or evaluating, this is either the module's own or that of an earlier module in the same strongly connected component. Requested modules, a list of strings, a list of all the module specifier strings used by the module represented by this record to request the importation of a module. The list is in source text occurrence order. Loaded modules, a list of records with fields, a string, and a module record, a map from the specifier strings used by the module represented by this record to request the importation of a module to the resolved module record. The list does not contain two different records with the same cycle root. A cyclic module record or empty, the first visited module of the cycle, the root DFS ancestor of the strongly connected component. For a module not in a cycle, this would be the module itself. Once evaluate has completed, a module says the of its copyright sign, ECMA International 2024, 71, Table 43, additional fields of cyclic module records, continued, field name, value type, meaning, has TLA, a boolean, whether this module is individually asynchronous. For example, if it's a source text module record containing a top-level await. Having an asynchronous dependency does not mean this field is true. This field must not change after the module is parsed. Async evaluation, a boolean, whether this module is either itself asynchronous or has an asynchronous dependency. Note, the order in which this field is set is used to order queued executions. C16, 2, 1, 5, 3, 4. Top-level capability. A. Promise capability record or empty, if this module is the of some cycle, and evaluate was called on some module in that cycle. This field contains the promise capability record for that entire evaluation. It is used to settle the promise object that is returned from the evaluate abstract method. This field will be empty for any dependencies of that module, unless a top-level evaluate has been initiated for some of those dependencies. Async parent modules, a list of cyclic module records. If this module or a dependency has true, and execution is in progress, this tracks the parent importers of this module for the top-level execution job. These parent modules will not start executing before this module has successfully completed execution, pending async dependencies, an integer or empty. If this module has any asynchronous dependencies, this tracks the number of asynchronous dependency modules remaining to execute for this module. A module with asynchronous dependencies will be executed when this field reaches 0 and there are no execution errors. In addition to the methods defined in Table 42, cyclic module records have the additional methods listed in Table 44. Table 44. Additional abstract methods of cyclic module records. Method. Purpose. Initialize environment. Initialize the environment record of the module, including resolving all imported bindings, and create the module's execution context. Execute module. Promise capability. Evaluate the module's code within its execution context. If this module has true in, then a promise capability record is passed as an argument, and the method is expected to resolve or reject the given capability. In this case, the method must not throw an exception, but instead reject the promise capability record if necessary. A graph loading state record is a record that contains information about the loading process of a module graph. It's used to continue loading after a call to host load imported module. Each graph loading state record has the fields defined in Table 45. 72. Copyright sign. ECMA International 2024. Table 45. Graph loading state record fields. Field name. Value type. Meaning. Promise capability. A. Promise capability record. The promise to resolve when the loading process finishes is loading. A boolean. It is true if the loading process has not finished yet, neither successfully nor with an error. Pending modules count. A non-negative integer. It tracks the number of pending host load imported module calls visited. A list of cyclic module records. It is a list of the cyclic model records that have been already loaded by the current loading process, to avoid infinite loops with circular dependencies. Host-defined. Anything default value is empty. It contains host-defined data to pass from the load requested module's caller to host load imported module 16.2.1.5.1 load requested modules. Host-defined. The load requested module's concrete method of a cyclic module record module takes optional argument host-defined anything and returns a promise. It populates the of all the module records in the dependency graph of module. Most of the work is done by the auxiliary function in a module loading. It takes an optional host-defined parameter that is passed to the host load imported module hook. It performs the following steps when called. If host-defined is not present, let host-defined be empty. Let PC be new promise capability, %promise %. Let state be the graph loading state record. True. 1. Promise capability, PC, host-defined. Perform in a module loading. State, module, return PC, 6, 2, 1, 5, 1, 1 in a module loading. State, module. The abstract operation in a module loading takes argument state, a graph loading state record, and module, a module record, and returns unused. It is used by load requested modules to recursively perform the actual loading process for module's dependency graph. It performs the following steps when called. Assert. State is true. If a module is a cyclic module record, module is new, and state does not contain module, then A. Append module to state. B. Let requested modules count be the number of elements in module. C. Set state to state plus requested modules count. D. For each string required of module, do I if module contains a record whose is required. Then let record be that record. Perform in a module loading. State. Record 2. Else. Note the host-defined parameter can be used to pass additional information necessary to fetch the imported modules. It is used, for example, by HTML to set the correct fetch destination for link rel equals preloaders equals tags import. Expressions never set the host-defined parameter. ECMA International 2024 373. 1. Perform host load imported module. Module. Required. State. State. Note. host load imported module will call finish loading imported module, which re-enters the graph loading process through continue module loading. 3. If state is false, return unused. Assert state 1. Set state to state 1. If state equals 0, then assert state to false. B for each cyclic module record loaded of state. Do if loaded as new, set loaded to unlinked. C perform call state undefined return unused. 6 2 1 5 1 to continue module loading. State module completion. The abstract operation continue module loading takes argument state, a graph loading state record, and module completion, either a normal completion containing a module record or a throw completion, and returns unused. It is used to re-enter the loading process after a call to host load imported module. It performs the following steps when called. If state is false, return unused. If a module completion is a normal completion, then perform in a module loading. State module completion. Else assert state to false. B perform call state undefined module completion. Return unused. 6 2 1 5 to link. The link concrete method of a cyclic module record module takes no arguments and returns either a normal completion containing unused or a throw completion. On success, link transitions this modules from unlinked to linked. On failure, an exception is thrown and this modules remains unlinked. Most of the work is done by the auxiliary function in a module linking. It performs the following steps when called. Assert module is one of unlinked, linked, evaluating async, or evaluated. Let stack be a new empty list. Let result be completion in a module linking. Module stack 0. If result is an abrupt completion, then a for each cyclic module record m of stack. Do I assert m is linking. 2. Set m to unlinked. B assert module is unlinked. C return result. Assert module is one of linked, evaluating async, or evaluated. Assert stack is empty. Return unused. 6 2 1 5 2 1 in a module linking. Module stack index. The abstract operation in a module linking takes arguments module, a module record, stack, a list of cyclic module records, and index, a non-negative integer, and returns either a normal completion containing a non-negative integer or a throw completion. It is used by link to perform the actual linking process for module, as well as recursively on all other modules in the dependency graph. The stack and index parameters, as well as the modules and fields, keep track of the depth first search, DFS, traversal, 74, copyright sign, ECMA International 2024, in particular, is used to discover strongly connected components, SCCs, such that all modules in an SCC transition to link together. It performs the following steps when called. If a module is not a cyclic module record, then a perform module link. B return index. If a module is one of linking, linked, evaluating async, or evaluated, then a return index. Assert module is unlinked. Set module to linking. Set module to index. Set module to index. Set index to index plus 1. Append module to stack. For each string required of module, do a let required module be get imported module. Module required be set index 2. In a module linking, required module, stack, index. See if required module is a cyclic module record. Then, I assert, required module is one of linking, linked, evaluating async, or evaluated. 2. Assert, required module is linking if and only if stack contains required module. 3. If required module is linking, then set module to min. Module, required module 0. Perform module initialize environment. 1. Assert, module occurs exactly once in stack. 2. Assert, module 3. If a module equals module, then a let done be false. B repeat. While done is false, I let required module be the last element of stack. 2. Remove the last element of stack. 3. Assert, required module is a cyclic module record. I've set required module to linked. V if required module and module are the same module record, set done to true. 4. Return index. 6 2 1. 5. 3. Evaluate. The evaluate concrete method of a cyclic module record module takes no arguments and returns a promise. Evaluate transitions this modules from linked to either evaluating async or evaluated. The first time it is called on a module in a given strongly connected component, evaluate creates and returns a promise which resolves when the module has finished evaluating. This promise is stored in the field of the for the component. Future invocations of evaluate on any module in the component return the same promise. Most of the work is done by the auxiliary function in a module evaluation. It performs the following steps when called. Assert. This call to evaluate is not happening at the same time as another call to evaluate within the surrounding agent. Assert. Module is one of linked, evaluating async, or evaluated. If module is either evaluating async or evaluated, set module to module. If module is not empty, then a return module. Let stack be a new empty list. Let capability be new promise capability. %promise %. Set module to capability. Let result be completion. In a module evaluation, module stack 0. If result is an abrupt completion, then a for each cyclic module record m of stack. Do I assert? M is evaluating. ECMA International 2024 375. 2. Set M to evaluated. 3. Set M to result. B assert. Module is evaluated. C assert. Module is result. D perform. Call. Capability. Undefined. Result. 0. Else. A assert. Module is either evaluating async or evaluated. B assert. Module is empty. C if module is false, then I assert. Module is evaluated. 2. Perform. Call. Capability. Undefined. Undefined. D assert. Stack is empty. 1. Return capability. 6. 2. 1. 5. 3. 1 in a module evaluation. Module. Stack. Index. The abstract operation in a module evaluation takes arguments module, a module record, stack, a list of cyclic module records, and index, a non-negative integer, and returns either a normal completion containing a non-negative integer or a throw completion. It is used by evaluate to perform the actual evaluation process for module, as well as recursively on all other modules in the dependency graph. The stack and index parameters, as well as modules and fields, are used the same way as in inner module linking. It performs the following steps when called. If a module is not a cyclic module record, then a let promise be module evaluate. B assert. Promise is not pending. C if promise is rejected, then I return throw completion. Promise D return index. If module is either evaluating async or evaluated, then if module is empty, return index. B otherwise, return module. If module is evaluating, return index. Assert. Module is linked. Set module to evaluating. Set module to index. Set module to index. Set module to 0. Set index to index plus 1. 0. Append module to stack. 1. For each string required of module, do a let required module be get imported module. Module required be set index 2. In a module evaluation, required module stack index. See if required module is a cyclic module record. Then I assert required module is one of evaluating async, or evaluated. 2. Assert required module is evaluating if and only if stack contains required module. 3. If required module is evaluating, then set module to min. Module required module I've. Else set required module to required module. Assert required module is either evaluating async or evaluated. If required module is not empty, return required module. V if required module is true, then set module to module plus 1. Append module to required module. 2. If a module 0 or module is true, then 76. ECMA International 2024. AB. Assert. Module is false and was never previously set to true. Set module to true. See note. The order in which module records have their fields transition to true is significant. C1 6, 2, 1, 5, 3, 4. D if a module equals 0. Perform execute async module. Module 13. Else. A perform module execute module. 4. Assert. Module occurs exactly once in stack. 5. Assert. Module 6. If module equals module, then a let done be false. B repeat. While done is false, I let required module be the last element of stack. 2. Remove the last element of stack. 3. Assert. Required module is a cyclic module record. 5. If required module is false, set required module to evaluated. V. Otherwise, set required module to evaluating async. V. If required module and module are the same module record, set done to true. 7. Set required module to module. 7. Return index. Note 1. A module is evaluating while it is being traversed by inner module evaluation. A module is evaluated on execution completion or evaluating async during execution if its field is true or if it has asynchronous dependencies. Note 2. Any modules depending on a module of an asynchronous cycle when that cycle is not evaluating will instead depend on the execution of the root of the cycle via. This ensures that the cycle state can be treated as a single strongly connected component through its root module state. 6, 2, 1, 5, 3, to execute async module. The abstract operation execute async module takes argument module, a cyclic module record, and returns unused. It performs the following steps when called. Assert. Module is either evaluating or evaluating async. Assert. Module is true. Let capability be new promise capability. %promise %. Let fulfilled closure be a new abstract closure with no parameters that captures module and performs the following steps when called. A performance and module execution fulfilled. Module be return undefined. Let unfulfilled be create built-in function. Fulfilled closure 0. Let rejected closure be a new abstract closure with parameters. Error that captures module and performs the following steps when called. A performance and module execution rejected. Module error be return undefined. Let onRejected be create built-in function. Rejected closure 0. Perform promise then. Capability unfulfilled. OnRejected. Perform module execute module. Capability 0. Return unused. 6, 2, 1, 5, 3. 3. Gather available ancestors. Module. Execlist. The abstract operation gather available ancestors takes arguments module, a cyclic module record, and execlist, a list of cyclic module records, and returns unused. It performs the following steps when called. For each cyclic module record M of module, do. If execlist does not contain M and M is empty, then I assert. M is evaluating async. ECMA International 2024 377. 2. Assert. M is empty. 3. Assert. M is true. 5. Assert. M 0 V set M to M1V. If M equals 0, then append M to execlist. If M is false, perform gather available ancestors. M execlist. Return unused. 6, 2, 1, 5, 3, 4. Async module execution fulfilled. Module. The abstract operation async module execution fulfilled takes argument module, a cyclic module record, and returns unused. It performs the following steps when called. If module is evaluated, then A assert. Module is not empty. B return unused. Assert. Module is evaluating async. Assert. Module is true. Assert. Module is empty. Set module to false. Set module to evaluated. If a module is not empty, then A assert. Module is module. B perform. Call. Module. Undefined. Undefined. Let execlist be a new empty list. Perform gather available ancestors. Module. Execlist. 0. Let sorted execlist be a list whose elements are the elements of execlist, in the order in which they had their fields set to true and in a module evaluation. 1. Assert. All elements of sorted execlist have their fields set to true, field set to 0, and field set to empty. 2. For each cyclic module record M of sorted execlist, do. If M is evaluated, then I assert. M is not empty. B else if M is true, then I perform execute async module. MC else I let result be M execute module 2. If result is an abrupt completion, then perform async module execution rejected. M result 3. Else set M to evaluated. If M is not empty, then A assert M is M. B perform call M undefined. 3. Return unused. 6, 2, 1, 5, 3, 5 async module execution rejected. Module error. The abstract operation async module execution rejected takes arguments module, a cyclic module record, and error, an ECMAScript language value, and returns unused. It performs the following steps when called. 1. If module is evaluated, then note when an asynchronous execution for a root module is fulfilled. This function determines the list of modules which are able to synchronously execute together on this completion, populating them in exec list. 78. ECMA International 2024. A assert module is not empty. B return unused. Assert module is evaluating async. Assert module is true. Assert module is empty. Set module to throw completion. Error. Set module to evaluated. For each cyclic module record M of module. Do a performance and module execution rejected. M. Error. If a module is not empty, then A assert module is module. B perform call module undefined. Error. Return unused. 6, 2, 1, 5. For example, cyclic module record graphs. This non-normative section gives a series of examples of the linking and evaluation of a few common module graphs, with a specific focus on how errors can occur. First, consider the following simple module graph. Figure 2. A simple module graph. Capital A, capital B, capital C. Let's first assume that there are no error conditions. When a host first calls a load requested modules, this will complete successfully by assumption, and recursively load the dependencies of B and C as well, respectively, C and none, and then set A equals B equals C equals unlinked. Then, when the host calls a link, it will complete successfully, again by assumption, such that A equals B equals C equals linked. These preparatory steps can be performed at any time. Later, when the host is ready to incur any possible side effects of the modules, it can call evaluate, which will complete successfully, returning a promise resolving to undefined, again by assumption. Recursively having evaluated first C and then B, each modules at this point will be evaluated. Consider then cases involving linking errors after a successful call to a load requested modules. If in a module linking of C succeeds but, thereafter, fails for B, for example because it imports something that C does not provide, then the original A link will fail, and both A and B's remain unlinked. C's has become linked, though. Finally, consider a case involving evaluation errors after a successful call to link. If in a module evaluation of C succeeds but, thereafter, fails for B, for example because B contains code that throws an exception, then the original A evaluate will fail, returning a rejected promise. The resulting exception will be recorded in both A and B's fields, and they will become evaluated. C will also become evaluated but, in contrast to A and B, will remain without an, as it successfully completed evaluation. Storing the exception ensures that any time a host tries to reuse A or B by calling their evaluate method, it will encounter the same exception. Hosts are not required to reuse cyclic module records. Similarly, hosts are not required to expose the exception objects thrown by these methods. However, the specification enables such uses. Now consider a different type of error condition. Copyright sign, ECMA International 2024 379. Figure 3, a module graph with an unresolvable module. Capital A, question mark. In this scenario, module A declares a dependency on some other module, but no module record exists for that module. That is, host load imported module calls finished loading imported module with an exception when asked for it. This could occur for a variety of reasons, such as the corresponding resource not existing, or the resource existing but parse module returning some errors when trying to parse the resulting source text. Hosts can choose to expose the cause of failure via the completion they pass to finished loading imported module. In any case, this exception causes a loading failure, which results in A's remaining new. The difference here between loading, linking and evaluation errors is due to the following characteristic. Evaluation must be only performed once, as it can cause side effects. It is thus important to remember whether evaluation has already been performed, even if unsuccessfully, in the error case. It makes sense to also remember the exception because otherwise subsequent evaluate calls would have to synthesize a new one. Linking, on the other hand, is side effect free, and thus even if it fails, it can be retried at a later time with no issues. Loading closely interacts with the host, and it may be desirable for some of them to allow users to retry failed loads. For example, if the failure is caused by temporarily bad network conditions. Now, consider a module graph with a cycle. Figure 4. A cyclic module graph. Capital A, B, C. Here we assume that the entry point is module A, so that the host proceeds by calling a load requested modules, which performs in a module loading on A. This in turn calls in a module loading on B and C because of the cycle. This again triggers in a module loading on A, but at this point it is a no-op since A's dependencies loading has already been triggered during this load requested modules process. When all the modules in the graph have been successfully loaded, their transitions from new to unlinked at the same time. Then the host proceeds by calling a link, which performs in a module linking on A. This in turn calls in a module linking on B because of the cycle. This again triggers in a module linking on A, but at this point it is a no-op since A is already linking. B itself remains linking when control gets back to A, and in a module linking is triggered on C. After this returns with C being linked. Both A and B transition from linking to linked together. This is by design. Since they form a strongly connected component, it's possible to transition the status of modules in the same SCC at the same time because during TH is phase the module graph is traversed with a depth-first search. An analogous story occurs for the evaluation phase of a cyclic module graph. In the success case, now consider a case where A has a linking error. For example, it tries to import a binding from C that does not exist. In that case, the above steps still occur, including the early return from the second call to inner module linking on A. However, once we unwind back to the original inner module linking on A, it fails during initialize environment, namely right after C resolve export. The thrown syntax error exception propagates up to a link, which resets all modules that are currently on its stack. These are always exactly the modules that are still linking. Hence both A and B become unlinked. Note that C is left as linked. 380. Copyright sign, ECMA International 2024. Alternatively, consider a case where A has an evaluation error. For example, its source code throws an exception. In that case, the evaluation time analog of the above steps still occurs, including the early return from the second call to inner module evaluation on A. However, once we unwind back to the original inner module evaluation on A, it fails by assumption. The exception thrown propagates up to A evaluate, which records the error in all modules that are currently on its stack. That is, the modules that are still evaluating, as well as via, which form a chain for modules which contain or depend on top. Level await through the whole dependency graph through the async module execution rejected algorithm. Hence both A and B become evaluated and the exception is recorded in both A and B's fields, while C is left as evaluated with no. Lastly, consider a module graph with a cycle, where all modules complete asynchronously. Figure 5. An asynchronous cyclic module graph. Capital A, B, C. Loading and linking happen as before, and all modules end up with set to linked. Calling A evaluate calls in a module evaluation on A, B, and E, which all transition to evaluating. Then in a module evaluation is called on A again, which is a no-op because it is already evaluating. At this point, D is 0, so execute async module D is called and we call the execute module with a new promise capability tracking the asynchronous execution of D. We unwind back to the inner module evaluation on B, setting B to 1 and B to true. We unwind back to the original inner module evaluation on A, setting it to 1. In the next iteration of the loop over A's dependencies, we call in a module evaluation on C and thus on D, again in no-op, and E as E has no dependencies and is not part of the cycle, we call execute async module E. In the same manner as D and E is immediately removed from the stack, we unwind once more to the original inner module evaluation on A, setting C to true. Now we finish H the loop over A's dependencies, set A to true, and remove the entire strongly connected component from the stack, transitioning all of the modules to evaluating async at once. At this point, the fields of the modules are as given in Table 46. Table 46. Module fields after the initial evaluate. Call fields modules capital A, capital B, capital C, capital D, capital E, DFS index, DFS ancestor index. Status evaluating async evaluation true, 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 true. Async parent modules. Double angle quotation mark A, B, C, pending async dependencies, B and C, D and D, copyright sign, ECMA International 2024, 81. Let us assume that he finishes executing first. When that happens, async modular execution fulfilled is called, E is set to evaluated and C is decremented to become 1. The fields of the updated modules are as given in Table 47. Table 47. Module fields after module finishes executing. Fields modules capital C, capital E, DFS index, DFS ancestor index. Status evaluating async evaluated. Async evaluation true, true. Async parent modules A, C pending async dependencies. D is next to finish, as it was the only module that was still executing. When that happens, async modular execution fulfilled is called again and D is set to evaluated. Then B is decremented to become 0. Execute async module is called on B, and it starts executing. C is also decremented to become 0, and C starts executing, potentially in parallel to B if B contains an await. The fields of the updated modules are as given in Table 48. Table 48. Module fields after module D finishes executing. Fields modules capital B, capital C, capital D, DFS index, DFS ancestor index. Status evaluating async evaluated. Async evaluation true, true, true. Async parent modules A, B, C pending async dependencies. Let us assume that C finishes executing next. When that happens, async modular execution fulfilled is called again. C is set to evaluated and A is decremented to become 1. The fields of the updated modules are as given in Table 49. Table 49. Module fields after module C finishes executing. Fields modules capital A, capital C, DFS index, DFS ancestor index. Status evaluating async evaluated. 382. ECMA International 2024. Table 49. Module fields after module C finishes executing. Continued. Fields modules capital A, capital C, async evaluation true, true. Async parent modules. Double angle quotation mark A pending async dependencies. B then B finishes executing. When that happens, async modular execution fulfilled is called again and B is set to evaluated. A is decremented to become 0, so execute async module is called and it street arts executing. The fields of the updated modules are as given in Table 50. Table 50. Module fields after module B finishes executing. Fields modules capital A, capital B, DFS index, DFS ancestor index. Status evaluating async evaluated. Async evaluation true, true. Async parent modules. Double angle quotation mark A pending async dependencies. Finally, A finishes executing. When that happens, async modular execution fulfilled is called again and A is set to evaluated. At this point, the promise in A, which was returned from A evaluate, is resolved, and this concludes the handling of this module graph. The fields of the updated modular is given in Table 51. Table 51. Module fields after module A finishes executing. Fields modules capital A, DFS index, DFS ancestor index. Status evaluated. Async evaluation true. Async parent modules. Double angle quotation mark pending async dependencies. Alternatively, consider a failure case where C fails execution and returns an error before B has finished executing. When that happens, async modular execution rejected is called, which sets C to evaluated and ECMA International 2024 383 C to the error. It then propagates this error to all of the async parent modules by performing async modular execution rejected on each of them. The fields of the updated modules are as given in Table 52. Table 52. Module fields after module C finishes with an error. Fields, modules, capital A, capital C, DFS index, DFS ancestor index, status, evaluated, async evaluation, true, async parent modules. Double angle quotation mark A. Pending async dependencies. B. Evaluation error. Empty. C's evaluation error. A will be rejected with the same error as C. Execution rejected on A with C's error.
The stream's at like
The promise in A.
11 hours, 20 minutes or something. I don't know. I'm gonna set it to like timeout for 10 minutes and then I'm gonna try to finish this up the stream right after this, whatever. So I'm like, I don't know, another stream will start after this. I'm gonna like give it 10 minutes to time out in case it doesn't send the whole stream, because it's the year 2025 and we have modern operating systems and we have modern technology and modern software, and even with all this modernness, somehow it slipped past, well, I don't know, maybe like streaming software that's capable of sending the full stream and a streaming service that's capable of receiving the full stream. You would think that'd be possible in the modern world we live in, but apparently it's not. So I'm gonna let the stream run on for like 10 more minutes and then I'll start up another stream. So BRB.
Quotation mark A. Pending async dependencies.
Did I say the word modern? Oh yeah, modern. You know, like modern. Modern.
A source text module record is used to represent information about a module that was defined from ECMAScript source text. 11. That was parsed using the goal symbol module. Its fields contain digested information about the names that are imported and exported by the module, and its concrete methods use these digests to link and evaluate the module. A source text module record can exist in a module graph with other subclasses of the abstract module record type, and can participate in cycles with other subclasses of the cyclic module record type, in addition to the fields defined in Table 43. Source text module records have the additional fields listed in Table 55. Each of these fields is initially set in parse module, Table 55. Additional fields of source text module records. Field name, value type, meaning, ECMAScript code, a parse node. The result of parsing the source text of this module using module as the goal symbol. Context, an ECMAScript code execution context or empty. The execution context associated with this module. It is empty until the module's environment has been initialized. Import meter, an object, or empty, an object exposed through the import meter meta property. It is empty until it is accessed by ECMAScript code. Import entries, a list of import entry records. A list of import entry records derived from the code of this module. Local export entries, a list of export entry records. A list of export entry records derived from the code of this module that correspond to declarations that occur within the module. Indirect export entries, a list of export entry records. A list of export entry records derived from the code of this module that correspond to re-exported imports that occur within the module or exports from exporters' namespace declarations. Copyright sign, ECMA International 2024, 85. Table 55. Additional fields of source text module records. Continued. An import entry record is a record that digests information about a single declarative import. Each import entry record has the fields defined in Table 56. Table 56. Import entry record fields. Field name, value type, meaning, star export entries, a list of export entry records. A list of export entry records derived from the code of this module that correspond to export declarations that occur within the module. not including exporter's namespace declarations. Field name, value type, meaning, module request, a string, string value of the module specifier of the import declaration, import name, a string, or namespace object, the name under which the desired binding is exported by the module identified by. The value namespace object indicates that the import request is for the target module's namespace object. Local name, a string, the name that is used to locally access the imported value from within the importing module. Note 1 Table 57 gives examples of import entry records fields used to represent the syntactic import forms. Table 57. Informative. Import forms mappings to import entry records. Import statement form. Module request. Import name. Local name. Import v from mod. Mod default. V. Import as ns from mod. Mod namespace object. Ns. Import x from mod. Mod x. X. Import x as v from mod. Mod x v. Import mod. An import entry record is not created. An export entry record is a record that digests information about a single declarative export. Each export entry record has the fields defined in Table 58. 86. Copyright sign. ECMA International 2024. Table 58. Export entry record fields. Field name. Value type. Meaning. Export name. A string or null. The name used to export this binding by this module. Module request. A string or null. The string value of the module specifier of the export declaration null if the export declaration does not have a module specifier. Import name. A string. Null. All. Or all but default. The name under which the desired binding is exported by the module identified by null if the export declaration does not have a module specifier. All is used for export as ns from mod declarations. All but default is used for export from mod declarations. Local name, a string or null, the name that is used to locally access the exported value from within the importing module. Null if the exported value is not locally accessible from within the module. Note 2 Table 59 gives examples of the export entry record fields used to represent the syntactic export forms. Table 59. Informative. Export forms mappings to export entry records. Export statement form. Export name. Module request. Import name. Local name. Export var v. Null. Null. V. Export default. Function f. Default. Null. Null. F. Export default. Function. Default. Null. Null. Default. Export default. 2. Default. Null. Null. Default. Export. X. X. Null. Null. X. Export. V as x. X. Null. Null. V. Export. X. From mod x. Mod x. Null. Export. V as x. From mod x. Mod v. Null. Export from mod. Null. Mod all but default. Null. Export as ns. From mod. Ns. Mod all. Null. The following definitions specify the required concrete methods and other abstract operations for source text module records. ECMA International 2024 387. 16. 2. 1. 6. 1 parse module. Source text. Realm. Host defined. The abstract operation parse module takes arguments source text. ECMAScript source text. Real. M. A realm record. And host defined anything and returns a source text module record or a non-empty list of syntax error objects. It creates a source text module record based upon the result of parsing source text as a module. It performs the following steps when called. Let body be parse text. Source text. Module. If body is a list of errors, return body. Let requested modules be the module requests of body. Let import entries be import entries of body. Let imported bound names be imported local names. Import entries. Let indirect export entries be a new empty list. Let local export entries be a new empty list. Let star export entries be a new empty list. Let export entries be export entries of body. 0. For each export entry record E of export entries. Do. If EE is null, then I if imported bound names does not contain EE, then 1. Append E to local export entries. 2. Else, let IE be the element of import entries whose is EE. If IE is namespace object, then a note. This is a re-export of an imported module namespace object. Be append EE to local export entries. Else, a note. This is a re-export of a single name. Be append the export entry record, i.e. import name, i.e. null, EE. to indirect export entries. B else if EE is all but default, then I assert EE is null. 2. Append E to star export entries. C else I append E to indirect export entries. 1. Let async B body contains await. 2. Return source text module record, realm, empty, empty, cycle root, empty, async, false, empty, empty, new, empty, host defined, body, empty, empty, requested modules, import entries, local export entries, indirect export entries, star export entries, empty, empty, 6, 2, 1, 6, to get exported names, export star set. The get exported names concrete method of a source text module record module takes optional argument export star set, a list of source text module records, and returns a list of strings. It performs the following steps when called. Assert module is not new. If export star set is not present, set export star set to a new empty list. If export star set contains module, then note an implementation may parse module source text and analyze it for early error conditions prior to the evaluation of parse module for that module source text. However, the reporting of any error RS must be deferred until the point where this specification actually performs parse module upon that source text. 88. ECMA International 2024. Assert. We've reached the starting point of an export circularity. B return a new empty list. Append module to export star set. Let exported names be a new empty list. For each export entry record E of module, do assert. Module provides the direct binding for this export. B assert. E is not null. C append E to exported names. For each export entry record E of module, do assert. Module imports a specific binding for this export. B assert. E is not null. C append E to exported names. For each export entry record E of module, do assert. E is not null. B let requested module be get imported module. Module E. C let star names be requested module get exported names. Export star set. D for each element n of star names, do I have same value, n, default, is false. Then, if exported names does not contain n, then A append n to exported names 9. Return exported names 6, 2, 1, 6, 3 resolve export, export name, resolve set. The resolve export concrete method of a source text module record module takes argument export name, a string, and optional argument resolve set, a list of records with fields, a module record, and a string, and returns a resolved binding record. Null or ambiguous. Resolve export attempts to resolve an imported binding to the actual defining module and local binding name. The defining module may be the module represented by the module record. This method was invoked on or some other module that is imported by that module. The parameter resolve set is used to detect unresolved circular import-export paths. If a pair consisting of specific module record and export name is reached that is already in resolve set, an import circularity has been encountered. Before recursively calling resolve export, a pair consisting of module and export name is added to resolve set. If a defining module is found, a resolved